Tesla cars, the Google search engine and Gmail, the Astrobee robots from NASA, PlayStation and Xbox, the trading systems at the New York Stock Exchange, as well as many other popular services around the world, run on Linux. This means that there's a lot of benefit to you learning Linux. And the base certification for Linux is the CompTIA's Linux Plus. Even if you don't plan on getting your Linux Plus certification, this video will help you to develop your Linux skill set. And being that this channel is all about cybersecurity and hacking, learning Linux will make you a much more capable security pro and a force to be reckoned with. That being said, here's the outline of what we'll be covering in this tutorial. This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today. All right, a couple of quick notes. The format of the training series is going to be half lecture and half practical commands that we actually run inside of Linux on the command line. As you can see over here, we have a bunch of content. So it goes up to chapter 11 as far as the lecture portion itself is concerned. And we'll be covering essentially everything that you see inside of this notes document, this Google Doc, as well as these 800 something slides that I have here for you in the Google Slides presentation. So that's going to be the part of the lecture of this particular training series. There is going to be a section on chapter 3 where we actually go through the installation of Linux, and it's something that I want to go through with you so you actually have a lab environment just in case you don't have Linux on your computer and you don't have Mac OS. And Mac OS can be kind of similar to Linux, but I want you to actually practice inside of a Linux environment. So we're going to go through the installation portion of it, and that'll be similar to a practical example that I'll give you so that we can just go click by click so that you can see how to download an ISO file and go ahead and install it for yourself and essentially set yourself up to run all of the commands that we're going to end up running when we actually do get to the practical portion of this. But for the most part, it's going to be broken down into a lecture, and then at the very end of it, when we get to chapter 12, we're going to get to all of the commands that we have. And then for chapter 12, there's individual sections as well that has all of the individual commands that we're going to run that will just break down into multiple sections under chapter 12. So there's actually 12 subsections inside of chapter 12 that goes everything from getting system information all the way to getting scripting and learning about how to create shell scripts. So that's going to be the outline that we have, or the format of the outline that we have over here. The second note that I want to give you is that you can actually get this document, this Google document with all of its notes and all of the commands and everything that's for the lecture, as well as this Google Slides presentation and its 800 something slides. You can get access to both of these things by being a member of our Hackaholics Anonymous membership community. So if you're actually an agent tier member or above, you will get access to this as a part of your membership. And in my opinion, it's actually very, very valuable. The video is obviously available to you for free. Most likely it's going to be broken down to 2 videos because when we actually get to the practical section, I think I have to break it down into its own series of videos, or at least its own separate video, because Google YouTube maxes us out at the 12-hour mark. So just in case we go over 12 hours for this training series, I'm going to break it down into 2 separate videos, but you will get access to those videos absolutely for free. If you wanted to get the docs, notes, as well as the slides, it would be part of the Hackaholics Anonymous membership. And just to give you an idea of what that looks like as far as the price comparison of what you can expect, if you went to CompTIA to try to get their Linux Plus education, just for the exam voucher itself, it's $369. But everything else, so for example, if you wanted to do the labs and their education videos, as well as the notes that they would give you and everything else, that would be $1165. And then you have these various bundles as well. So you're looking at least several $100s if you wanted to get it through Linux Plus from CompTIA, or really anything that would be comparable to this particular education. What I'm giving you in these notes, as well as the slideshow, is based on the exact outline that they have in the CompTIA Linux Plus education, so that you can be ensured that you're getting everything that you need for your examination, but you literally get it at a fraction of the price, probably less than 1/10 of the price. So that's really the entire plug that I have over here. is that if you actually wanted to get these notes as well as the slides, you can get it by being a member of the Hackaholics Anonymous membership community, and the link to that is below in the description. Now, that being said, let's actually jump into this outline so you know what to expect. Okay, so first and foremost, the timestamps that are going to be attached for this presentation are going to be in the description below, as well as the very first comment that will be pinned to the top of the comment section. And I'm going to try to give you as many timestamps as possible without making it ridiculous and being too specific. So the timestamps will be broken down, and then this is the outline of this course. So number one, obviously, we're going to go into the intro to Linux and the Linux Plus certification, which means you'll get the overview of the history of Linux, the distributions that are available, and the Linux Plus certification itself, what the benefits would be for you, and more importantly, the structure of the Linux Plus examination, which means the categories that are going to be covered and the format of the exam and any prerequisites that would be required to make sure that you do very well on this training series, as well as if you decide to go take the certification exam so that you can do well on the examination. The second section is going to be all of the system architecture and the brute process properties. So this is very similar to what happens if you got an education in CompTIA A+, but of course we're not going to go into the nitty gritty, the super in-depth stuff. It's going to be all the things that you would need to understand Linux, as well as the kernel and the shell and the user space and the basic input output system and UEFI and GRUB and the init system, so on and so forth. So you're going to get a good understanding of what these things are and how they relate to Linux. Then we're going to go into the actual installation of Linux, and you'll learn how to install Linux on a USB drive so you can have a live boot, as well as a full installation if you wanted to install it on a computer to have as a second operating system, or if you just wanted to start installing Linux on a variety of machines. If you got hired to be a Linux administrator, that's essentially what they might ask you to do, is to install Linux on an actual computer so that the computer runs on Linux. So you'll learn that entire installation process. And then we're going to go through the partitions and the file systems, so you know how you can create partitions and what primary partitions are and what extensions are, so on and so forth. We'll go through the package managers and, of course, updating, removing, and troubleshooting packages. Then we're going to go through the basics of the command line. Now, this is just going to be, again, a part of the lecture itself. All of the commands that you're going to learn in every other section that we talk about will be covered inside of the practical portion of this training series, and we're going to go in depth, and you're going to try so many different versions of the commands, and you'll get a really good training on it and a good understanding of it. So I don't want you to think that just because we're going to skim them and, you know, introduce you to the commands for these various sections, that we're not going to actually go and practice them when we get to the practical session. So this is going to be the basics of the command line, as well as the text editors and manipulating files and creating basic shell scripts and what the various portions or the various elements of a shell script are. Then we're going to go into user and group management, how to create and manage users and groups, the file permissions and ownerships and access control lists and things like that, special permissions, and of course authentication and pseudo permissions that will come to that specific section. And then we have the file management and file system. So this is actually going deeper into the file systems. We had the introduction to file systems when we were over here, but over here we're actually going to go in depth for the file systems and how to mount and unmount a file system, how to actually create a file system using fdisk or the MKFS, the make file system commands, and how to create partitions, configuring and those things, of course, and managing the swap spaces as well, because that's actually a separate partition as well. So you'll get all the understanding that you need for file management and the file systems and how to create file systems and partitions, so on and so forth. We're going to go into process and service management. So this is also very important as a Linux administrator. All of this stuff is actually really important as a Linux sysadmin. So we're going to go into the process and service management portion, understanding what a daemon is, what services are, process management commands, service management commands, and of course scheduling jobs. And then we're going to go into networking. So this is not going to be a replacement of the Network Plus training that you can get, but we will go into enough that you will be dangerous. So you'll learn enough about networking that you will know exactly how to navigate the network infrastructure and how to set up the IP addressing and the DNS and dynamic host configuration protocols, and how to actually create the network manager CLI, or how to use the network manager CLI, and how to troubleshoot network issues, and of course managing the firewalls with the basic firewall, which is the uncomplicated firewall, as well as the IP tables. So we'll go into a good amount of stuff so that you know enough to be dangerous, right? But we're not. This is not going to substitute the network plus education, because that's a whole other beast by itself. And then we have security and access management. So this is another very important element. This is a channel about cybersecurity and hacking, so security is a very, very big deal to me. So this is going to be something that I'm very interested in sharing with you. And file system security, chroot file permissions, access control lists, network security, user authentication methods, and configuring secure shell, data encryption and secure file transfer, and a lot of other things that would fall under the category of security and access management. And then we're going to go through troubleshooting and system maintenance. And these are all different elements. So analyzing, interpreting log files, disk usage analysis, backup and restoration strategies, and of course system performance monitoring. And then there's virtualization and cloud concepts. Now, this was not listed as an actual category under Linux Plus, but I think this is very important for you to learn, because most likely if you're going to get a job as a DevOps manager, or somebody who will go into DevOps, or somebody who's going to become a Linux sysadmin, you are most likely going to deal with a cloud environment, because companies these days aren't really setting up physical servers anymore. They're most likely going to go and buy a virtual server with let's say AWS or with Google Cloud or something like that, and you're going to need to learn how to essentially just navigate those things. It's not really complicated to understand, and the command line and everything that's associated with this isn't really complicated, but I just want you to understand it, and I want you to know how these whole things work, and what is a virtual machine and what is a container, for example, and how do you use VirtualBox or Docker, these various tools that are associated with cloud concepts and cloud computing. So it's not required for Linux Plus, but I think you will be more powerful as a Linux administrator. And if in case it does show up, because by the time that you watch this video, they've added it to the most updated version of the Linux examination, in case it does show up, you'll know what you're talking about, and you'll be ready for that as well. And then finally, we're actually going to get into the practice command portion, which is a massive portion all by itself, and of course, exam preparation tips. So there will be the key commands for the Linux Plus exam. There's going to be exam preparation resources like practice labs, in addition to everything we're going to talk about, mock exams, study guides. I'll give you a bunch of mock questions that you will need to kind of review just to prepare yourself for the examination, and of course, the exam day tips and how to just prepare yourself for that day, and the final wrap up that we'll go through. So this is going to be a comprehensive training course. I really want it to be very useful for you, whether or not you take the examination. So whether or not you decide to become certified should not matter, because by the end of this thing, you should be so functional and you should be so competent with Linux that even if you're not certified, you can do all of the requirements of any Linux sysadmin job, and then you can confidently put that on your resume and even on your portfolio and say, look at all of the stuff, all of these shell scripts that I created and all of the various things that I can do inside of Linux, so that you can just prove that you're competent and you're actually proficient in Linux. So I'm really excited for you. I'm glad that you're here. I hope you go through the entire thing, but in case you want to skip around and find individual sections that would be relevant to you, the timestamps are all going to be below. And that's about it. So I feel like I was talking a mile a minute because I'm trying to get through this whole thing so quickly to be able to save on time. You probably don't need to speed up this presentation, because I'm going to try to talk really, really fast to just try to get as much content crammed into this video as humanly possible. So I'm excited for you. I hope you're excited too. Let's jump into the very first section. Okay, here we go. So Introduction to Linux and the Linux Plus certification. Overview of the history, distros, and of course the common uses. So it was created in 1991 by Linus Torvalds, who developed Linux as a hobby while studying at the University of Helsinki. I don't know what you do as a hobby, but this guy created an entire operating system. The goals for this were to make it free, make it open source alternative to Minix, which was based on Unix. And that's the guy, Linus Torvalds. He's still around, and he's still the father of Linux. Inspired by Unix, which was created by Maurice Bach, Version 0.02 of Linux kernel was released in 91, and then 1.0 was released in 94. Torvalds posted the source code for free on the web, inviting other programmers to improve it, making Linux a collaborative project and the foundation for open source software. And to this day, it is still open source, meaning you can get access to it for free, and you can even make modifications to it so long as your modifications get approved by the father of Linux. Richard Stallman, who's an American, and the Free Software Foundation created the GNU, which was the open source Unix-like OS, and then they added the GNU utilities to the Linux kernel to create the GNU Linux, or the modern version of Linux that you see when you interact with Linux, or when any of these companies that we mentioned at the beginning of the video, when they create it or they use it, that's the version of Linux that they're using. So it's the most updated version of Linux. And that's the guy, Richard Stallman. That's like the best picture that I found of him. All of the other pictures are not flattering at all. And he looks like a mountain man pretty much in every single one of these pictures. And it's interesting to see that, like, this is one of the guys that's like a tech nerd that was like one of the founding people of Linux. So it's really interesting to see the different types of people that you see inside of the tech world. So yeah, this is Richard Stallman. So then what happened was Linux became a complete Unix clone. Now it's used everywhere, as you saw. Torvalds remains the ultimate authority on what new code is incorporated into the Linux kernel, and aka he's known as the benevolent dictator of Planet Linux. And the best picture that I could find to exemplify that, to embody that, was that picture right there. So without that guy's permission, you cannot make any incorporations to the Linux kernel, or at least not publicly shared. You could probably make the modifications yourself, but you won't be able to make it as one of the distros that are available to everybody else. So that is what we got for the history of Linux. Now, these are the popular Linux distributions and the various purposes that they hold. Linux distributions, aka distros, are different versions of Linux OS that bundled the Linux kernel with other software. So you have the Linux kernel as the base, and then you have a variety of different additions to it that create various distributions. So for example, we have Ubuntu, which is the most commonly used. It's popular for general users, beginners, and people who want to use Linux in the desktop environment. And it's used, or it's known for user friendliness, right? So it actually has a GUI, and you get point and click and a lot of cool things that come pre-installed with it. But Ubuntu is the most popular in my opinion, and it was like the first introduction when I heard about Linux, and I was looking at the software that was installed, the OS that was installed. It was Ubuntu distro that was installed. And then we have CentOS, aka Red Hat Enterprise Linux, or RHEL. And these things are used in enterprise environments. So they're mainly for stability and support. So there's actually a support team. There's a dedicated support team that the company can hit up and get their questions answered. And it's very, very stable, and it's good for large environments. So enterprise environments use CentOS and then Red Hat Enterprise Linux. And then we have Debian. And Debian is known for servers and advanced users, mostly because of the fact that you're not going to get a graphic user interface. There are some installments that do have it, but for the most part, it's just a black screen with a bunch of command line comments that are on it. And this is used for servers. So this is a very, very big one in the server environment. And then we have Fedora, which is great for developers. And it's more cutting edge, and it has a lot of innovations and utilities that are pre-installed on it. And this is again for people who want to go into development and coding and software development, etc., etc. That would be Fedora. And then finally, last but not least, is my favorite, which is Kali Linux. And that logo is just absolutely amazing. I love Kali Linux. And it's for cybersecurity and ethical hackers, which is us, everybody that comes on this channel. We are all cybersecurity people and ethical hackers, and we use Kali Linux. And Kali Linux also has Ubuntu installed on it, but it comes pre-installed, pre-configured with a bunch of cybersecurity tools and a bunch of ethical hacking tools and pen testing tools. And it is my favorite version of Linux. I'm biased, obviously. I love all of Linux. I think it's an amazing OS. But this is definitely mine. This is my favorite one. And that is it for the majority of the popular distros. There are some other distros as well that you will see as we go into some of the links for being able to download these things, but these are the most popular, and you can just do a Google search to see what all the different distributions are. As far as the common uses of Linux, we already kind of touched on them through the distros, but you have, servers, embedded systems, and IoT devices. IoT devices are Internet of Things. So it could be a smart appliance like a microwave or something, or a fridge or something. It could be a router. It could be cars like the Tesla cars. It could be the Arobi robots. It could be so many different things that would be considered an embedded system or an IoT device. And then you have software development and cybersecurity, obviously, and then we have cloud and data center. So AWS and Google Cloud actually use Linux. DevOps and cloud architecture, all of those things are centered around Linux. Actually, the only platform that I don't think uses Linux for cloud computing is Microsoft Azure, but they even have kind of like an integration with Linux that you can actually use to go into it as well. So for the most part, Linux is the primary OS that is used for a lot of these things. It's, believe it or not, it's massive. There's so many different entities and so many different platforms and software and equipment and systems that use Linux. So you're in a good place. By studying this, you are adding a very important skill set that I think is going to be very relevant for many, many years to come, for decades to come probably, assuming that the human race is still around. So a very, very good skill set to have. Just so you know what the benefits are by this certification for IT professionals, even if you don't get the certification and you just get really good at Linux, and you can put on your resume and on your portfolio that these are all the different things that you can do, and for the exercises that we run, you're going to get some output results, so you can develop scripts and you can do a lot of different things that will demonstrate your skill set on this. But there are a lot of benefits to it. So obviously there's industry recognition. Obviously there is career advancement opportunities. So it's recognized globally. So Linux Plus is actually a globally recognized certification, and it's very valued in IT roles as a system admin, as somebody in DevOps or cybersecurity and cloud computing. It's an entryway. So it's a gateway. It's getting your foot in the door for professionals who are seeking to specialize in Linux-based systems. It validates your skills. It has a lot of versatility to it. So system configuration, troubleshooting, security, as we've just touched on. Employers really appreciate people who actually have certifications, or at the very least understand fundamentals and practical uses of Linux. And in my opinion, it's the practical side of everything that is the most important. I know a lot of people who don't have the degrees, who don't have the certifications, but are very, very capable and really good at these things, that are getting hired in very big roles. And because it's mainly because of the fact that if you put on your resume that you can do something, as a part of the application process, they're going to have you go through some kind of an assessment. And the assessment is going to test your skills in Linux. And if you actually know what you're doing, they don't care whether or not you have the certification. They just want to know that you know what you're doing and you know how to navigate these types of environments. So it's very, very important in validating those skills. And of course, there's competitive advancement and salary potential. So if you actually, if you know what you're doing, and if you know Linux versus somebody who doesn't know Linux, you will get paid a higher rate. You can find some really nice salaries for people who know how to interact with Linux. And Linux Plus certification just kind of is that seal of approval to make sure that you actually know it. But there's this really great quote that says, what do you call somebody who got a D in med school? You call them doctor. And so even if somebody got a Linux Plus certification, it doesn't mean that they scored super high on that certification exam. It just means that they got at least the bare minimum score to be able to pass it, and then they got that cert. So you could, for the most part, a lot of people, again, could just be self-taught and without this certification, but they know a lot of Linux interactions and environments and fundamentals and advanced scripting and so on and so forth, that they actually are more knowledgeable than people who got the cert. So just kind of keep that in mind. Okay, so here is the structure of the Linux Plus exam. The exam format, currently the XK0-005 as of 2024. So the time of this recording is November 2024. It consists of approximately 90 questions, including multiple choice and performance-based questions. And the candidates that take this exam, they have 90 minutes to complete the examination. And the passing score typically varies depending on the version, but it's around 720 out of 900. 720 out of 900 is 80%. So this is not something that you can get a C around or something like that. So if you get 721, you pass. If you get 720, you pass. But it's approximately 80% is what you're trying to accomplish here. The main domains that are covered are system management, so how to install, configure, and manage Linux systems, security, which is implementing security best practices and understanding the Linux system security requirements. There's scripting and automation for shell scripting to automate tasks and manage resources, which actually, whether or not you take this, it's so powerful to be able to automate activities on Linux. And just in general, learning how to automate things is it's good for you. It's good for your life. Networking and storage management, configuring, troubleshooting the network, the storage, as well as share resources, and performance and monitoring. So monitoring the system performance and implementing logging. These are going to be the main domains, the main categories that are covered when you are going through the Linux Plus certification. And under this falls troubleshooting. Under this falls system administration, so on and so forth. So these things, we're going to go through all of that stuff so that you have a very good fundamental, good foundation, and then you actually get into the intermediate and advanced things as well. The prerequisites are none. Actually, there are no strict prerequisites, but prior experience in Linux is actually very useful in this. Although we will go through all of the introductory and intermediate stuff as well. So all the beginner level stuff we are going to cover as well. There's actually a series of videos that I've done on Linux fundamentals and Linux basics on this channel, and they're relatively short compared to what this video is going to end up being. So if you want to go check those out, just to kind of give you a foot in the water, dipping your toe in the water, so to speak, that would be useful. If you get the CompTIA A+ or Network Plus, that's also super useful. But there are no actual strict requirements or prerequisites to get into this, mostly because of the fact that we're going to be touching a lot of the fundamentals for all those requirements anyways. But the better introduced you are to this, the more familiar you are with this, you're going to have an easier time for the rest of it, and you're just going to get a lot of the information re-ingrained in your mind and reaffirmed, and you'll get a really strong understanding of everything that goes on. All right, so let's get into the system architecture and the boot process. And first in that regard is going to be understanding the directory structure and the file system hierarchy of Linux. One of the common things that you're going to hear a lot as we go through this tutorial is going to be the FHS, the File System Hierarchy Standard, and we're going to be referring to this frequently. So the FHS defines the Linux hierarchy structure and what each folder is commonly used for. And so the key directories that you see on your screen right here, these are the big directories for Linux installations, and for the most part, these things always come pre-installed every time that you install Linux. There's going to be a difference between primary and extensions and logic type of directories, but these things are all falling under the key directory. So you have the root, the bin, or also known as the binary, and then you have the sbin, which is system binary. You have the etc., which is typically used for configuration files. You have the home that houses all of the users. You have the verilog, the variable log, that houses a lot of actual logs and variable dynamic data. You have the user folder that also houses user data. You have the optional stuff, and then you have the development directory that has a lot of the source as well as the virtual environments as well. And then you have a temp folder that houses temporary data that typically gets wiped on reboot. And these are our main key directories. Now, the root directory is the top level directory. The root is literally the root for the entire system. So all of the other directories in FHS are inside of the root directory, and they are technically all just extensions of the root directory. They're organized hierarchically. Under the root, subdirectories branch out, and then more under them, and so on and so forth. So they just keep getting more and more subcategorized under the root. The root directory is owned by the root user, who has complete control over the root directory and, by extension, the entire machine. The structure and contents are crucial for system stability and security, meaning that you don't want to mess with this unless you really know what you're doing. You don't want to mess with any of it, because most likely if you do anything, if you delete something accidentally, if you modify something accidentally, you're going to mess the entire thing up, and then you have to reinstall Linux. And then there's the software packages that are installed, and their files and specific directories under the root directory. Sysadmins often work directly with the root directory to configure and maintain the system. So this is the mother, right? This is like the basic, the very, very main directory. The home of everything is the root, and it's represented by this singular /. The bin, or the binaries directory, contains essential binary executables that are needed during the boot process or in single user mode. So it's generally accessible to all the users, and it houses all of the basic binaries. So for example, the ls command, also known as the ls binary, the cat command, the cp, the mv, rm. So ls is listing all the files and directories, cat concatenates and displays the contents of a file onto your terminal, cp copies files and directories, mv moves or renames files and directories, rm removes files and directories. And these are just a few of them. There's many. There are dozens of binaries that are included inside of the bin folder, the binaries folder. The sbin is known as the system binaries folder, and this is the binary executables that are used for system administration. It typically requires root privileges to execute this, so it's not accessible by everybody. And since they involve system level changes, it's very, very important that you know what you're doing. For the most part, you're probably going to be using your own version of Linux on your home computer to go through all of this. So you're not going to be in an enterprise environment to do this. So even you are going to be the root user that gets access to the system binaries, you don't want to mess with these things, right? So the fdisk binary for creating partitions, and the fscheck for Filesystem Check for initializing the system, rebooting, these are very, very important binaries. You don't want to mess with these. These are not things that you should even try to open or manipulate, or unless you are super advanced, which if you're watching this, you aren't. So just be very, very careful with the binaries. Just leave these alone. You know, for the most part, as long as your intrusion detection system or your antivirus or any of those security appliances don't give you any kind of an error or an alert that has to do with this, for the most part, you're not going to be interacting with the system binaries. It's just good to know what it houses, and it is the part that primarily houses the system administration, the binary executables that are relevant to your system. And this is not accessible by anybody other than the root user. That's what you need to mainly keep in mind. Then we have the variance, the difference between these two, right? So you have the binaries folder that typically all users get access to. The system binaries folder is only accessible by the root user. The purpose of the binaries is essential user commands like ls and cp, so on and so forth. The system binaries are for system administration. The execution timing, so early boot process or single user mode is when binaries are actually launched and executed. The system binaries are for system maintenance and administration, so they actually manually are booted and used or activated, executed, and they're not done automatically by the system. So for example, creating partitions is going to be done manually by the root user as they try to create partitions, or when you go through the primary installation and you're assigning the various partitions that you want, that's when those things are going to be executed. Apart from that, unless you do need any of those binaries, they're not going to be activated or executed. So these are the main differences between binaries and system binaries, so that you have a good understanding of what they actually are. The etc, so the configuration binary, or not binary, sorry, folder, the etc folder directory houses configuration files for a lot of different services and applications, and these could be the things that you also install manually. This is known as the control center. And the contents of etc can vary depending on the Linux distribution that you got and the software that's installed. So it again houses the stuff that comes pre-configured inside of the system, as well as the stuff that you download and install into your system. Etc's containers, or Etc's directories, are things like the etc password that actually houses all of the user account information, but it doesn't show you anything for password hashes. So it'll show you just an X for that. The etc shadow file is going to show the user password hashes. So these two are very, very important in the concept of cybersecurity and ethical hacking. These are very, very important files. And then you have the etc group that has the group information, the etc host, for example, the host name and the IP address mappings, the host name itself, which is the system host name. You have the etc resolve configuration file that has the DNS resolver configurations. And you have the etc network interfaces that has the network interface configuration. And you'll see what that means when we actually run a couple of these networking commands, just so you can see what those things mean. And then we have the etc system control configuration that has the system kernel parameters. And again, you're not going to be messing with this. Maybe at some point you might be messing with the DNS resolver configuration. Maybe you might be messing with the network interface configuration. For the most part, you're not going to be messing with any of these things directly, unless you're doing pen testing or ethical hacking exercises where you would manually try to add a user to the etc shadow file or the etc password file, something like that. But the interaction that you have with all of these files will be through individual commands that will add or remove entries from some of these files, and that's how you will interact with them. It's very rare that you'll actually open these files directly and interact with the file directly. You'll probably use one of those binaries that we talked about earlier to interact with these files. These service configurations are like such. So if you have an Apache web server that's installed, that would also be inside of the etc folder, and it'll be etc Apache. And then if it's Nginx, it'll be etc Nginx. If you have a MySQL database installed, that's what it's going to look like. If you have the PostgreSQL installed, that's what it's going to look like. So these are the configurations for individual services, right? So it houses configuration files for the system services, as well as anything that was installed on the machine itself. So MySQL may not necessarily come installed on your system. You may install it, and then when you do, that configuration drive or directory, that configuration directory, as well as its individual configuration files, are going to be installed inside of the etc directory. And of course, package manager. So very similar to the previous slide that we were on. apt, the apt package manager resources, or the yum package manager resources. These are dependent on the type of Linux that you're running. So apt typically comes with Ubuntu, yum typically comes with CentOS or Red Hat. But these are the package managers that that you can use to install various packages as well as software and applications, and we'll get deeper into that when we actually get to that slide. But typically, again, these things are all included inside of the etc folder. So as a final note, why is the etc folder important? Well, there's system behavior, so all the configuration files directly influence your actual system's behavior. The security is very important. As we talked about, the etc password and the etc shadow files specifically are really, really important. So if there's misconfigurations that are done to any of these configuration files, that poses a security risk. But then there's actual data that is inside of these configuration files that, if mishandled or accessed by somebody that shouldn't have access to them, is going to pose a massive security risk. There's customization, so you can customize the system by editing these particular files. If you want to append to them, you could use it doing various binaries, or you could just open some of these things up and directly append or manipulate the data that's inside of them. I wouldn't do it against the actual system important stuff. So if we go and talk about those individual softwares that were installed, you can customize those by opening them inside a text editor. But for the system related configuration files, I would only use specific binaries. Unless I know exactly what I'm doing, I would not open those files directly. I would use the system binaries, because the system binaries also give you the messages if you made an error in something, or with the syntax of something, they'll tell you exactly what you need to do. So you'll get a lot of help with the terminal itself when you use the binaries, instead of opening the document or opening the file and trying to configure it manually. And of course, troubleshooting. So any system problems that can be resolved by modifying configuration files. So at the same time, vice versa, of that, a lot of system problems can be caused by incorrectly modifying configuration files. So again, just notes, take notes, be warned. I gave you the disclosure, right? So just be careful as you manipulate those data points. And again, so we have an individual slide for the caution. So always back up the configuration files. Be mindful of the file permissions. Incorrect permissions can lead to system instability, or incorrect permissions can lead to hacking that takes place. Ensure that the configuration has the correct syntax to avoid any errors. And of course, test these things in a controlled environment before deploying them to a production system. This is more relevant to somebody who's actually working inside of some kind of a company and is hired as the system administrator. So before launching it to the 500 or 5,000 employees inside of the company, before deploying it to a production system, that's what that means. Before you actually deploy it to the entire company, you need to test it on one machine in a controlled environment to make sure everything is all good and there are no glitches or errors or security vulnerabilities. And once that's been approved and everything's taken care of, then you deploy it to the rest of the company. So that's what that means. You got to test it before you submit it and deploy it to the entire system, to the entire production environment. The home directory is where user accounts are stored and an individual user account. So for example, if you have user 1, this would be the directory for user 1, and then inside of that directory is going to be a bunch of information that's just relevant to user 1. And typically it's only accessible by user 1, or at least somebody who has user 1's password. So user accounts are housed inside of the home, primary location for files, documents, settings, configuration, etc. The key directories inside of it are going to be these, and you've probably seen these. So this also is very similar to what happens in a Microsoft environment, where each user has their own documents folder and a downloads folder. They have a music folder, pictures, public, videos, so on and so forth. For the most part, all of these things are only accessible to that user except the public folder. The public folder is used to share files with other users, and typically it's accessible by everybody else that's on that system as well. But all of these individual folders right here are usually only accessible by that specific user. User ownership has to do with their home directory, and everything that's inside of that home directory is owned by that user. By default, only that user and the root user have full access to the home directory, as well as the stuff that's for that specific user. So it ensures privacy, it ensures security. A user can customize their home directory to essentially do whatever they want, so long as they don't install anything or do anything that would ruin the entire system itself. They can essentially do whatever they want inside of their directory. They can store whatever they want inside of their directory, as long as they don't pass their storage limits, which typically if they do, they just get notified and they have to remove some stuff and delete some stuff so that they open up some more storage space. And by default, the home directories are protected from unauthorized access by anybody who does not have root permissions, or is not on the sudoers list, or does not have the username and password for that specific user. The notable notes here are that you want to back up these things regularly to just make sure, in case anything happens with a system crash or something, you can just recover all of that stuff. The file permissions are, again, very important. So file permissions is another one of those things that is going to come up very regularly as we go through the rest of these videos, and it falls under security. So file permissions have to do with if somebody is supposed to access this, should access it. If somebody is not supposed to access it, they should not be able to access it. Very simple. It's not a complicated process. It's just something that needs to be kept in mind. And as you navigate and administer a Linux machine or a Linux environment, this is some of the stuff that you really need to be considered for, or consider to just make sure that none of these things happen and nobody accesses these things when they're not supposed to. And we're going to go through those individual file permission commands and how to set file permissions, so on and so forth. Storage limits, as we already talked, there is going to be definitely storage limits, and the users are supposed to maintain their own storage limits, and not maintain them, but they're supposed to keep their storage limits in mind, so that if they ever hit a storage limit, they can delete data and make some more room. But each user is going to get a storage limit so that the overall system and the overall environment doesn't get maxed out. And of course, I mean, keep it organized if you can, but I know some people that have a really, really freaking overwhelming, like scary looking desktop, because it's just a bunch of files on the desktop. There's zero organization. And it's like, how do you find anything here? And they're like, no, I know where everything is at. Yeah, I'm like, all right, bro. If you know where it's at, then fine. But if I am your manager, I'm going to be like, you need to learn how to organize all your stuff. So that's basically it. So var, or variable data, I call it the var. It's weird. I don't know, the pronunciation is weird to me, but whatever. The var directory, the var folder, it stores variable data. So this could be the system logs, because system logs are constantly updated with new activity. It could be temp files, it could be mail spools. It's essentially dynamic data that changes frequently, or variable data, as the name implies. These are some of the key directories inside of the var directory. So you have the log directory that houses all of the system and application logs. And it can be very, very important. That's another one of those locations where we refer to regularly when we're doing incident response in cybersecurity, or when we want to do troubleshooting if a system crash happens or unexpectedly. So it's a very, very important directory. The var log directory is very important. The var mail directory stores all the incoming mail for the users. The spool directory contains various services, including print jobs, mail, and news. The lib has the state information for various services and applications. And then you have the temp that is inside of the var directory, which should not be confused with the actual temp directory, which we're going to cover in a few slides. So it stores temporary files created by various applications that will be inside of this specific directory. So inside of the var directory, there's a temp directory that stores temporary files by various applications. Then we have the importance of this thing. So as you can imagine, health monitoring by looking at the log files inside of that directory is very important. So it gives you the data that's necessary to reverse engineer or backtrack what happened for system performance and any potential issues or attacks or anything that may have happened. Security analysis, again, same thing. Service operations. So spool directories in the spool are very crucial to services like printing and mail. So if there's some kind of an issue that is with your printer that isn't the actual hardware itself and there's no connection with the wires or anything like that, you may want to go over here to try to find out what is going on with the service itself, why the operation of that printing is not working accordingly. Application state, so the lib stores information needed for applications to maintain their state. So whether or not they are enabled or disabled, or if they have issues or glitching, whatever it may be, most likely it's going to be inside of this specific directory for the application state. So the var lib directory is going to store information needed for applications to maintain their state. Important considerations would be regular cleanup of the temp directory to make sure that you don't overload your storage. Rotate the files, the log files regularly, because log files can get massive if they are designed or if they've been configured to store data for a long period of time. And I don't care what the system is like. For the most part, any system can overload their log directory or the log contents very quickly if you don't set it up to clean up. So if you don't set it up to wipe the log data, or if you don't back up the log data before it's wiped, so on and so forth, those log files can get very, very large. If the system is being used regularly, log files can get really big. Permissions are very crucial again. So, right, files and directories, the permissions of those files and directories to protect system security. Somebody can get into your log directory and they can go into the authentication log and erase their tracks of being in your system. That's not good. So they can actually get into your system. They can do whatever they need to. They put some kind of a rootkit or something, some kind of a Trojan or a worm, something that they can connect to, a C2 connection, some kind of a shell, something, right? They can get in your system, house some kind of a connection where they can come in as they please, and then they erase their tracks from your logs. That's not a good thing. That is very, very, very bad. And that should not happen, because the permissions to those logs should be kept at a root level and a sudo level, so that people who are only an administrator should be able to access them, and their passwords should be super complex so that somebody can't just hack in their password by using a password cracking tool or something like that. So permissions, again, as I've mentioned, this is going to happen frequently. So permissions to certain log files and just certain directories should not be accessible by anybody other than the root user and the administrators. And of course, backup whatever is necessary. So not everything needs to be backed up, but the important things should be backed up. For example, log files should be backed up and configuration files should be backed up. That is all important stuff. We have the user directory. The user directory has user programs and libraries. So anything that has to do with the programs of that user, the libraries of data and any documentation typically is stored here. They have the user bin, so user binaries, right? The user sbin, system binaries. You have the user library. You have the local for locally installed software, often outside of the actual package manager that we'll be talking about. The user share that has shared data files like documentation, icons, and configuration files. And of course, the source code for various system utilities. The binaries are accessible to all the users. The system binaries are typically for system administration requiring root privileges. So this same thing applies here. So even the inside of the user folder, the system binaries are typically only accessible by the root user. The shared libraries used by programs, the locally installed software, often outside of the package manager, these things are very similar to what you saw previously. It's just it happens to be for the individual user. The root user will have their own directory. So it's not going to be something that you'll see inside of the user directory. It's going to be /root just by itself. But the user directory itself will have individual users other than the root that will have all of that information stored in here. So why is this important? The program execution, so in the binary and the system binary, are essential for running programs. Shared libraries are used by multiple programs to reduce disk space and improve performance. So if there's been something that's been installed that's accessible to all the users, it's going to be inside of that directory so that it's not duplicated across every single user taking up space. So you have one installation, but that's now available inside of the library so that all of the users can get access to it instead of having multiple installations of the same thing. Software installation, packages install for the users are actually inside of the subdirectories of the user, and a system documentation could be inside of the shared doc directory that contains documentation for system utilities, installed software, so on and so forth. And what we're talking about here is the actual manuals, for example, how to use a specific software or utility. The documentation for that is going to be inside of this system documentation. So the user shared doc is going to house typically documentation and instruction manuals for the various utilities. And so key points here, there should be certain things that are read-only. So the user directory is mounted as a read-only to prevent accidental modifications by somebody who should not be accessing it or should not have root privileges. Package management like apt and rpm, they manage the installation and removal of software, often modifying files within that user directory. So instead of going and manually removing files or folders, you would use one of the package managers, and the uninstall command that comes along with it that would be removing all of the software packages and all of the dependencies that comes with that software. So rarely are you going to be accessing these things directly and trying to remove them directly, which is why it says that there should only be read-only permission. So you should not have the permission to modify the contents inside of this. It's typically done by the various binaries that are inside of the system. And some files in the user are accessible to all the users. Others may require root privileges to modify, and that falls under file permissions and user access. So again, common themes. You're going to see this a lot. So the reason why I keep saying them is because I wanted to like really embed in your brain as we go across this information so that you really understand certain concepts. And then when you see the repeated themes, you start understanding how all of these things actually connect to each other, because it's not complicated. It's most of this stuff is common sense. You just need to know where certain things are housed and what the rules are for accessing them and giving permissions and so on and so forth. So that is what we got there. Now we have the OPT, the optional software. It stores additional software packages that are not part of the base system. So optional software installations from third-party sources. So let's say OBS, for example, which is the software that I'm using to record this presentation. That's something that came from a third-party software, third-party source, and that was installed. So the contents of that, the optional requirement, all of that stuff is going to be inside of the OPT folder for this particular software, right? There is a screen recording software that comes pre-installed with my machine, but that's not the one that I'm using. So that content, the content for that specific software are not going to be inside of this particular directory. This is for the optional software that is coming from a third-party source. So just keep that in mind. It's the optional configuration files or software installations or anything else that has to do with stuff that comes from a third-party source. And I'm actually going to correct myself. It's not the configuration file. So as we mentioned earlier, configuration files would actually be inside the etc folder. This is just the additional software packages that have been installed. So it would be the packages, the actual the use packages of that particular software that are going to be in here. The configuration file for that software would be inside of the etc directory. Why would you use this? So it keeps the optional software separate from the base system, which makes it easier to manage and remove. It prevents conflicts between different software packages. That's why we isolate them. And it's flexible, so it allows for easy installation. It allows for easy removal of the optional software. And you can technically come in here and manually remove them, but even if you have installed something and it ended up in here, I would highly recommend just using the same package installer to remove it, unless there was some kind of an install file that you downloaded from a place and then you used a package manager. I feel like it always comes down to the package manager. So there, especially in a Linux environment that doesn't have a GUI, a graphic user interface, if it's like a Linux server or something, you're not going to get a install file that you would double click on, and then you open the install file with the double click, and then it goes through the installation wizard, and then you just click next or something. It doesn't work like that. If you're using the command line interface, you're typically using the package manager to install something, which means that you would most likely use the package manager to remove something. So this is more so for the system itself, but again, you just need to know what purpose this serves. The optional software, the OPT, has to do with third-party software that's been downloaded. Therefore, it keeps all of that stuff separate from the base system, the system binaries, and the base installations, which makes it easier to manage and remove. And it isolates everything. So if there's something wrong, you can backtrack and try to find exactly where that problem came from. And of course, it's flexible for easy installation and removal of that stuff. The typical structure looks like this. So if you actually install something in the OPT, it typically creates a directory named after the software. So for example, MySQL. So there would be a MySQL directory for the MySQL software, and then it will house the software's binaries, libraries, and configuration files and data. And for the most part, most likely, there's going to be also something that will be inside of the etc folder. So you'll actually have MySQL inside of the OPT as well as the etc folder that would have to do with the configuration files of that. However, in this particular location, it also houses the libraries, it also houses the data, it also houses the software binaries, as well as the configuration files, whereas inside of the etc folder, it just has the configuration files. So keep that in mind. Inside of the OPT MySQL, it has everything, including config files. Inside of the etc MySQL, it only has the config files. So just keep that in mind. Key points here: ownership and permission. The ownership and permission files and directories within OPT can vary depending on the software. So if the user installed it versus if the root installed it, that could determine the direction of the permissions and the ownership. Package management: software packages can be installed using the system package manager. Others may require manual installation. That's typically in some kind of a GUI environment, based on what I've experienced so far. Sometimes you use another command line tool that is not the actual package manager itself. So for example, it's not apt or apt. It's not that. So there is some other kind of command line tool if you're only in a command line environment. So sometimes that may be the case, but for the most part, I've actually only used the package manager to install packages and the dependencies for those tools and utilities, unless I was inside of a GUI environment where there was some kind of a, you double click it and you extract the files, and then you click on the install file inside of that extraction, and then it runs through the installation, so on and so forth. Then there's a configuration for software installed in OPT. It's often located within the software's directory. And then cleanup. So when you remove software installed in OPT, it's important to remove all the files and directories associated with that software. So basically just delete the entire directory instead of going inside of the directory and then manually uninstalling things. Just uninstall everything that has to do with it. If there's data that you need to back up, save and back up that data, and then just wipe that entire directory that is the extension of OPT. So OPT MySQL, for example, you would delete the entire MySQL directory to make sure that everything inside of that thing have also been deleted. The dev directory houses the virtual device interface. So a virtual file system that represents hardware devices as files. So it allows the OS to interact with hardware devices using standard file operations. So this could be like a printer, for example. So there would be the dev SDA or SDB that represents the hard disk drives. So SD stands for standard disk. And then it could be, if you have multiple hard disks installed, A would represent the first one, B would represent the second one, C, etc. And it would just continue on from there. There would be the CD-ROM, there's the USB drives, right? So it could be the external drives as well. Null is actually something that discards anything that's written to it. So when we run certain commands that we know they're going to give us a lot of error messages, we point those error messages to the dev null directory because it immediately just deletes those error messages because they're unnecessary. They do nothing to you. And it's mostly like permission denied to such and such resource. When you do a find command, this is actually what I use this for. That's the only time that I've used this specific directory for. I'll run a find command, and I know that from the results of the find command, there's going to be a lot of data that's going to pollute my screen, and it's going to hide the important data. So it's going to be like noise, right? And typically that data is permission denied to this, permission denied to that, and it's all permission denied messages. And then within 100 permission denied messages, there's going to be 2 messages that have the data that I want. And so I point all of that denied messages, those error messages, to the dev null folder. And then from there, I can only look at the actual results. So instead of seeing 100 results, I only see the 2 that apply to me because all the error messages go to the dev null folder. And then you have dev0, which is a special file that produces an infinite stream of zeros. And so far, I have never used this thing. I think it's important from what I understand. I mean, it's listed, so I know that it's important, but I've never had a chance to actually use it. So I'm very curious as to what that's even for. But we just know that it does exist. And so it's a special file that produces an infinite stream of zeros. And we can, I'm actually gonna pause the presentation real quick. I'm just gonna do a Google search just to find out what the dev0 file is for. All right, so here's what we got. In Linux, dev0 is a special file located within the dev directory that essentially acts as a source of infinite null characters like ASCII value 0, meaning when you read from it, you will continuously receive zeros, making it useful for initializing data storage with blank values, which is why, if it's a blank value, why do you need to store it? Whatever. Okay, so key points about dev0. The function is that it provides a stream of zeros whenever you try to read from it. The disk initialization would be the use case, creating a completely blank disk by writing data from dev0 to it. Okay, that makes sense. So if you want to initialize a disk, creating a completely blank disk by writing data to it, so you just pull a bunch of zeros from this thing and you write it to the disk. Memory allocation, checking if a specific amount of memory can be allocated by attempting to read a certain number of bytes from dev0, and then generating blank files, creating a file with 0 as byte, redirecting output from dev0 to a new file. So it's basically a storage of zeros, and then you you pull that storage of zeros to either allocate testing or generate a blank file or initialize a disk. That's very interesting. That's like such a nerdy thing. I didn't even know that something like this existed. But okay, now we know. Very interesting. So why is the dev folder important? Device abstraction. By treating devices as files, Linux provides a consistent interface for interacting with various hardware devices. So for example, the file that has been assigned to a USB drive, for example, when you plug in the USB drive, you now have a folder dedicated to the file system for that USB drive. And then when you go inside of that folder, you get to interact with the contents of the USB drive. And this is more important in a command line environment, because if you're inside of a GUI environment, a graphic environment, you just click on it and you get to see inside of the file browser that, okay, these are the contents of the USB drive. But when you're inside a command line environment only, it turns it into a file system so that you can actually interact with the contents of it. Device drivers, which are software components that control hardware devices, create device files inside of dev. So the device driver, which is the software components that control a hardware device. So for example, your printer has a driver that you need to install to be able to interact with that printer. If you've ever installed a new printer, it says, hey, you need to go download the driver for this printer from our website, and that's how you get to interact with the printer itself. So that is housed inside of the dev folder. The user interaction can access, a user can access and control devices through these device files, often using commands like disk duplicate or hd parm, so on and so forth, to be able to interact with the various extensions of the dev directory. And that is why this is actually important. So it's the virtual interface of a physical device typically. So a USB drive, a printer, a hard disk on the computer, so on and so forth. This would be the virtual interface to interact with that physical device. Key points here are that the device files are often created dynamically when a device is plugged in or when the system boots. So when you plug in your USB, all of a sudden a little folder or file pops up that has to do with that USB. Access to device files may be restricted to root or specific users depending on that specific device. And the correct device driver must be installed and loaded for a device to be accessible in dev, for example, your printer. USB drives typically don't require device drivers, but printers usually do. So something that does something in the physical world typically has to have its own driver that comes installed, and then that will be inside of the dev folder. Then we have the temp folder. So the temporary file system, it's used to store temporary files created by various applications and system processes. The files are typically deleted when the application or process finishes or when the system is restarted or rebooted. The temp has write and execute permissions. It's a very popular target for hackers. Most of the pen testing exercises that I have done they've had to do with, creating a shell or some kind of a script that does some malicious activity, creating it outside of the machine that I'm targeting, and then taking that specific file and using something like wget or some kind of a Python server to transfer it from my machine to the target machine. And then I put that file inside of the temp folder because the temp folder has write and execute permissions. And I can have no access to any of the other folders that we just talked about. So the root folder, obviously the home, I can have literally no access to anything else, but typically there is always access to the temp folder. So if I drag and drop it or transfer my binary or the payload that I have inside of the temp folder, then I can execute it from the temp folder. So this is a very popular target for hackers because of the fact that it has these permissions that typically come pre-configured. You can obviously change this, but for the most part, it has write and execute permissions, mostly because of the fact that it usually just deletes everything once the system has been rebooted. So there's nothing in here that's permanent. It's a temporary file system. So that's why it has those permissions, and that's why it is such an attractive target. Temporary storage is a convenient location for applications to store temporary files without cluttering the user's home directory or other permanent locations. And when you close the software, those files get wiped from the temp folder. When you restart the system, those files get wiped. System processes often use the temp folder to store temporary files during operations, such as package installations or system updates, and then they get wiped. User applications, such as web browsers and text editors, also use the temp folder to store temporary files, and then they get wiped. So that's why it's probably one of the most volatile folders here because it's just constantly changing based on the software that you're using and the activity that you're having. So you don't really, none of these things are permanent. It's all temporary. Some key points here: there are automatic cleanups. So many systems automatically clean up the temp directory on reboot or at regular intervals, or when you close the software down or something like that. Security, you got to be aware of potential security risks associated with the temp files because they contain sensitive information sometimes, or that specific directory can be accessible fairly easily. If necessary, you can manually clean up the temp directory using commands like remove or remove rf, meaning to reformat. However, be cautious not to delete important files. So again, just be aware of certain things. When you're doing automatic cleanup or automatic wiping of something, make sure there's nothing in there that is important that you should have backed up before you wiped everything inside, before you like digitally napalm the entire thing and just wipe everything. And so these are some of our other important directories. The boot directory stores bootloader files. Dev, we've already talked about. Lid, we've already talked about. The mount directory houses the mount point for removable media. The proc is the virtual file system providing information about system processes. And then the SRV contains data for services provided by the system. And then there's the system, the sys, which is the virtual file system that has info about the system's hardware. So for example, the CPU or the GPU, so on and so forth. So these are other important directories. However, what we talked about is most likely going to be talked about very frequently. You do need to know what is inside of these things. You don't have to know the nitty-gritty. You don't have to know all the finer details, but you should be aware of these individual directories as well that are all a part of the file system hierarchy standard. Okay, so now going into the file system types and mount points. So these are our common file system types. You have the ext4, XFS, NTFS, and FAT32. The ext4 is the fourth extended file system, which is designed as the successor to ext3 and ext2. It's a journaling file system for Linux. And what that means is that it houses a journaling file system that basically it records everything that happens inside of the file system in case the system crashes or there's some kind of a power failure or something, and it needs to pick up where it left off. It maintains a journal. So it supports large files, for example, 16 terabytes in size, which is freaking massive. It makes it suitable for storing large media files and databases. It has the large file system support that can handle file systems of up to 1 exabyte in size, accommodating massive storage needs. Enhances performance, so improved performance, especially for the large file systems, and it can be extended. So it's designed to be extensible, allowing for future enhancements and features. And hopefully you can actually see the bottom part of this. I'm not sure exactly if you could see that inside of the video, but the bottom piece right here says extensibility. The ext4 file system is designed to be extensible, allowing for future enhancements and features. So these are the key features that we have of the ext4 file system. Then there's the XFS file system. The XFS file system also has journaling for high performance, scalability, and reliability. It's used for large file systems and high performance workloads. So this is typically for an enterprise type of an environment. It's optimized for sequential read and write operations, making it ideal for file servers and databases. It can handle file sizes up to 8 exabytes in size, so it's pretty freaking massive. The ext4, very similar to the ext4, it uses journaling to ensure data integrity in case of crashes. It can be scaled, so it can handle a large number of files and directories that is really good for file servers with a lot of users. So typically this is used for a central file server that a lot of remote users can access, and it makes it very easy to scale up and house more files as well as give access to more users. Then there's flexibility, which has online file system resizing and real-time defragmentation, which makes the file system very flexible. So you can actually make certain edits without removing permissions or without removing accessibility to it. You can make certain modifications to the XFS file system. So it's typically used for large databases or data centers with many users. The common use cases here are often used in high performance servers like the web server or the database server and file servers. So the server, essentially, it serves the data and other people can take the data from it. So it can be one central location. For example, it would be the web server, and then multiple users can access that website. It could be a database and multiple users can access that database. It has the NAS devices, so network attached storage. Devices often use XFS to store large amounts of data. And then you have virtual machines like the XFS that can be used as the file system for virtual machine disk images. And just a quick note, a network attached storage device is essentially a fancy name for a server. So it's the physical server itself that uses the XFS file system to serve that data. So it stores a bunch of data that other people can access, and it's attached to a network, meaning that it's accessible via a network connection. So that's what an NAS device is. And then it typically uses the XFS file system to be able to house that data, to store that data so that other people can get access to it. The NTFS, the New Technology File System, is actually a file system that's been used in modern Windows operating systems. It's reliable, it's secure, performs well. The reason why you need to know this is that most often you're going to need to format a drive that can interact with the NTFS system, or at the very least, you need to know what it is so that in the context of your interaction between Windows machines and Linux machines, you need to know how to format a file system or some kind of a mount so that it can be accessed by both of these file system types, right? So if somebody is using a Linux machine and another person is using a Windows machine, they both should be able to get access to your overall server. They should be able to get access to your XFS file system, for example, so that they can pull whatever data they need from it. So this is one of the reasons why we're actually even talking about the NTFS, the New Technology File System. It's secure. It offers robust security features like access control lists that allow granular control over the file and folder permissions. It uses journaling, very similar to everything else we've talked about, to improve the integrity and recoverability of data. It's optimized for performance, especially on modern hardware, and it can handle large file systems and large file support. So it's a solid file system, and it's been used on the modern Windows machine. So obviously, this is a very, very solid, good file system. It typically is only available. So if something has been formatted for NTFS, typically it can't be accessed by a Linux machine. That's based on my experience, at least. So what you want is dual formatting. And typically when you do something that can handle both of them, it is not just NTFS. Just keep that in mind. So NTFS is typically inherent to Windows, right? It's very much so dedicated to Windows. Compression is one of the other features here. It can support file and folder compression to save disk space. It allows you to encrypt files and folders to protect sensitive data, meaning you use password protect files and folders. And it has hard links and symbolic links. It provides flexibility in file management. A hard link is a direct reference to a file system, essentially creating a duplicate entry for the same file data, while a symbolic link, also called a soft link, is a file that stores the path to another file, acting like a shortcut that points to the original file's location. Meaning, with a hard link, multiple file names can access the same data. A symbolic link just points to the original file's path on the system. So for example, a symbolic link could just be the desktop shortcut, for example. So that would be the main difference. The hard link is a direct reference to a file on a system, essentially creating a duplicate entry for the same data. Symbolic link is just a shortcut to that file, right? So a hard link duplicates the same exact thing, puts it somewhere else. A symbolic link or soft link is the shortcut that points to that file. The common uses of NTFS would be the Windows operating system. So it's the default system for Windows NT 2000, XP, Vista 7, 8, 10, and 11. So the more recent versions of Windows. Many external hard drives are formatted with NTFS, especially those that are designed for Windows system. Again, so we're referencing being able to use it by Windows. A lot of external hard drives are formatted as such, so you want to make it formatted to access both types of machines. So for example, Mac OS as well as Windows. So you would need to reformat the hard drive. USB drives can be formatted with NTFS to store large files and folders, and you can also reformat them to house both types of files, so on and so forth. So NTFS, New Technology File System, common use cases. We have the FAT32 file system. This is by far my favorite name for a file system. So the FAT32 File Allocation Table 32 file system. It was used in the early days of personal computing. It's not as feature-rich like NTFS or XT4, but it remains popular due to its simplicity and broad compatibility, and is still used in a lot of environments. The key features is that it's relatively simple, which makes it easy to implement. It's compatible with a wide range of operating systems, including Windows, Mac OS, various Linux distributions, so it is cross-formatable. It has read and write access, allowing you to create, modify, and delete files. It does have a limited file size, so it has a maximum file size that's limited of 4 gigabytes and a limited partition size for FAT32, meaning it's 2 terabytes. It's still fairly big, so a 2 terabyte file system or a 2 terabyte extension partition is not bad, especially if you're dealing with just one person, one user. But most likely you're not going to be using that inside of an enterprise environment with a bunch of different users and a lot of different data. So FAT32 for the most part is being used by one individual person for like a home computer or something like that, or maybe a USB drive or an external hard drive that is maxed out at 2 terabytes. The common use cases is the USB flash drive, so commonly used for USB flash drives, memory cards like digital cameras or other devices, and external hard drives that only have a maximum of 2 terabytes typically use FAT32. And that's actually what I did for most of my external drives, because I don't have external drives that go past 2 terabytes. So when I can, I do go ahead and format it for the FAT32 so that I can use it on both my Windows machine as well as my Mac OS and Linux machines. All right, now we can go into the system architecture, which would be the kernel, the shell, and the user space. So the kernel, it's the core component of a Linux-based operating system. It's basically the bridge between the hardware and the software layers, managing system resources, facilitating communication, meaning that if you have, if you put a request, or we call it a call to the system, if you send a call to your CPU to perform a certain action, the kernel is that middle ground between whatever the software was that made that call and the actual CPU operating that call. So it's the middle ground, it's the bridge, as it says, between the hardware, which is the CPU, the GPU, the motherboard, so on and so forth, and the software layers, meaning your text editor, for example. When a text editor makes a certain call, the kernel translates that call, it transfers that call to the actual hardware, and it's the bridge that does that communication. The key roles of the kernel are resource management and several other management types as well. So you have memory management, process management, device management, and file system management. So allocates and deallocates memory to processes as needed. And we're not talking about storage here. We're talking about the random access memory, the processing memory. You have the process management to create, schedule, and terminate processes. It controls access to hardware devices like the disk drives, the network cards, and the printers. And then you have the managing of the file system and providing access to files and directories. So memory management specifically, it allocates memory to processes as needed, dividing physical memory into virtual memory segments. Page fault handling. So a page fault, or a page in general, is just a certain amount of data. And the handling of the faults that happen with pages is typically done within the kernel. So if a process tries to access a memory page that's not currently in physical memory, the kernel triggers a page fault and then loads the missing page from the disk. Then it swaps. So physical memory is scarce. So typically it's in a computer that's a little bit older, or maybe it doesn't have as much physical RAM, let's say 4 gigabytes of RAM or less. So if the physical memory is scarce, if there isn't enough physical memory, the kernel swaps the interactive pages to the disk to free up memory for active processes. We also refer to this as the swap space, and we're going to be talking about this a lot later on. But if there isn't enough physical memory, the kernel is responsible for swapping between virtual memory as well as the physical memory to make sure that the system doesn't crash and you get access to the amount of processing power that you need to be able to run your active processes. So this is what we mean by memory management. You can allocate memory, you can handle any data loading. So if there's any data pages that aren't loading, the kernel is responsible for retrieving that data. And then it's also responsible for managing the actual swap space, managing the processing power between the physical memory and any virtual memory pages that have been designed, also known as the swap spaces, so that the computer doesn't crash and you can still actually run the processes that you need to process. Then we have the process management. So we went from memory management to process management. And process creation and termination is one of the big things. So the kernel creates new processes. It assigns them unique identifiers, UIDs, and then terminates them when they're no longer needed. So when you close it down, it terminates it and the UID goes away. Process scheduling. So if you have anything that should run a certain amount of time on boot, for example, when you start up your computer, or every day or every 5 minutes, whatever, those things are done inside of the kernel. That process scheduling is done inside of the kernel. And then the CPU time efficiently is allocated via the kernel. Context switching. So between different processes, saving their state and restoring the state of the process to be executed. So for example, if you go from Google Chrome to your text editor, you're technically switching the context. And then if you come from the text editor back to Google Chrome, you should be able to pick up where you left off where you were on Google. And so that is considered a context switch. And the kernel switches between those processes, saving whatever their state was, and then restoring it when you go back to it so that you can just continue with business as usual. Inter-process communication is also facilitated by the kernel, meaning that they can share information and synchronize their activities with each other. And inter-process communication could be something like copy-paste, for example. You take something from one thing and you paste it to the other one. Or if you have two processes that are integrated with each other that rely on each other, those things can be done via the kernel as well. So whatever the processes are, whether it's a background process or a foreground process, meaning something that you can visibly see versus something that you don't see that's just running in the background, there's certain communication that takes place between those processes to make sure that the computer is running properly, your system is all good, and that's all done through the kernel. So the conversations that happen between processes, the conversations that happen between physical hard drives, as well as the physical CPU and your software on the computer, all of those conversations are handled via the kernel. And finally, we have the device management here. Or I think there's actually one more role here, but device management is one of the other ones as well, which would be the loading and unloading device drivers, software components that interact with specific hardware. It loads and unloads those specific things so you can interact and communicate with the physical hardware. You can have the input-output operations. So when you click something on your mouse, that's considered an input. Your mouse is considered an input device. When you type into something on your keyboard, that's considered an input device, or the input that's being received by the computer. And then the reaction from the computer would be considered the output. So if I click on something, it needs to open, that's an output. If I type something in the keyboard and it prints onto my screen, that's the output. So the kernel handles the input and output, transferring data between devices and the memory, which would be considered all the processing that's being done on the computer. And then the kernel also responds to interrupts generated by the hardware devices like the disk drives and network cards. And if there is any kind of interruption happening within the processes of those, it's also handled by the kernel itself. Hardware abstraction layer, also known as HAL. So this is the consistent interface for software to interact with hardware, hiding the complexities of different architectures. This abstraction allows software to run on various hardware platforms without requiring significant modifications. So the HAL, the hardware abstraction layer, it's all done by the kernel. So this is another rule that's done by the kernel. And it's considered the interface for a software to interact with hardware. So various hardware platforms have different functionalities. So a 4 GB RAM is different than a 16 GB RAM. a CPU that is one brand is different from a CPU that's NVIDIA or something like this. So these are various types of hardware or hardware platforms. And this specific this specific abstraction allows the computer, the software that you're using, to interact with these different types of hardware without requiring any kind of modification, right? So that's what the purpose of this is for. You don't need to modify the software to interact with a 4 GB RAM, although it might run a little bit slower. You don't need to modify it because the kernel will handle all of that translation for you. Same thing, if it's a 32 GB RAM, you don't need to modify it. The kernel will handle that for you. Specifically, HAL within kernel will handle that for you. And then we have the system call. So this is another one of those things that I've already kind of touched on a little bit. But a user level program interacting with the kernel and requesting services is called a system call. So you make a call to the system to do something for you. You make a call to your calculator to process a calculation for you. And then the kernel translates that call, it translates that request to the CPU. The CPU processes that and then feeds it back to you. So you put your input into the calculator, the kernel translated that input or transferred that input to the CPU processed it, and then the result came to the calculator as an output for you. That's called a system call. System calls enable programs to perform tasks like creating files, reading and writing data, making network connections, doing calculations, playing a video, yada, yada, yada. All of these things are considered a system call. Then we have security. So this is one of the big things for our community, the cybersecurity and hacking community. So security mechanisms to protect the system from unauthorized access and malicious attacks is done via the kernel. It includes user authentication, access control lists, and network security features. So user authentication, meaning the kernel verifies the user identities and grants access to system resources based on their privileges. That's all done by the kernel. So when somebody logs in, first of all, it verifies that, okay, this login is actually correct. And once you're logged in, the kernel processes your actual permissions and says, okay, based on what Hank has privileges to, he can access these various resources. And that's all done by the kernel, all behind the scenes. So as soon as you log in, the kernel says, okay, you have permission to, it's not going to declare it to you onto the screen, but it's just going to process that internally. And it's going to say, okay, this user has permission to access all of these things based on their password and username and permissions that have been assigned to them, their privileges that have been assigned to them. Then there's access control. So it enforces access control mechanisms to protect system files and directories. So if you actually if you shouldn't have permission to access a certain file, the kernel is the one that says, hey, user access denied, right? You don't have access to this thing because of your privileges for your user. And then there's the network security features like firewalls and packet filtering to protect the system from network attacks, to detect a phishing link that's been clicked, or to detect that you're visiting a malicious website, or to detect that somebody is trying to access your system and they've been denied access through the firewall. All of this is done by the kernel. The kernel processes all of those commands and all of those requests, aka the system calls. And now we have the shell. So the shell is probably the most basic version of your interaction with the kernel. So it's a command line interpreter that allows you to interact with a computer system. And it's text-based, so it's you probably have seen a version of a shell when you see any kind of a movie or a show about hacking. It's that black screen that has a bunch of white text on it, and it looks like gibberish, but to the hacker, hopefully they know what the hell they're doing. That person interacts with the system through the shell. So when we want to make a system call, for example, we want to run a program, when we want to access something inside of the file system or manage the resources of the system, the shell is our way to interact with the computer system. And this is how you interact with the kernel. You're not technically directly interacting with the kernel, but when you input something into the shell, the kernel takes that input and processes it and goes and calls on the system resources, and the file system does everything else that you want it to do. And this is how you directly communicate with the kernel. There's a lot of different ways to communicate with the kernel. For example, your calculator or your text editor. But at the most basic level, when you're interacting with a Linux server that only has a command line, the shell is how you interact and how you process your commands to the system. The shell works like this. You provide your input, right? So you type in a command into the shell. The command gets parsed, so meaning let's say there are 4 different pieces to that command. You say sudo, which is one portion of the command. You say nano, which is another portion of the command. And then you say the name of the file. So let's say that's 3 different commands, right? So it gets parsed. The command gets broken down into its individual sections or its individual tokens, and then it gets executed. So sudo says that you have root level privileges, and the shell will process that first, and it'll say, okay, if you have root level privileges, enter your password so I can verify that you're actually root. And then when you do, it's like, oh, okay, so you're all good, or it'll say you actually don't have access to this. Then once it has processed that, then it'll execute nano, and nano is a text editor, so it'll just open up the file name, which will be the 3rd piece of that command. It'll open up that file name inside of the nano text editor, meaning that it's executing the full command that you've given to it. And then once you do that, it opens the file and you get to see the contents of the file, which is considered the output. Shell scripting is an extension of shell's interactions and commands that essentially allows you to create a document, put a bunch of commands inside of it, and then when you run that one document, when you run that one shell script, then it runs all of the commands inside of that shell script without you having to manually input all of those commands. So this is a very powerful concept in automation. So if you have a repetitive task like looking at a log file and doing it daily, and you need to make sure that there's nothing fishy inside of the log file, you create a script that checks that log file every single day, and it checks for certain strings or certain pieces of data to make sure that it's not in there. And if it isn't in there, it'll give you an alert that says, hey, there's something to worry about. If it's not, it just says, hey, everything's all good, system check, everything's fine. And that's a very, very simple but powerful use of a shell script. So you can create a bunch of different repetitive tasks or automate a bunch of different repetitive tasks using shell scripts. And these are essentially text files, like we also mentioned, and they just have a sequence of commands that can be executed by the shell. Why we use the shell script is, as you can imagine, when you think about automating, it does a lot of different things for you. So number one, it's efficient. So instead of you having to do it every single day, you can just schedule a task via one of the tools that we already talked about and go through that task scheduling with a shell script. So you say, hey, system, run this shell script every single day at 9 a.m. or every single time that I start this computer, run this shell script. So it automates that for you, okay? The second part of it is that it's very consistent. So sometimes the human makes an error when they run a shell script, or not even a shell script. So let's say you want to run one of the commands and you mistype something, that's considered human error, or you forget a part of your series of commands that you're supposed to run. That's a human error. So instead of relying on the human, you just write it once, make sure that it's written really well and there are no errors in it. And now every single time that you need to perform that single task, it's done consistently, exactly how it's supposed to be every single time. That's great. Flexibility is that if you wanted to do the same task, but you want to do it with a variety of different files or with a variety of different users, you can just modify that script, and then now it'll do the same exact series of actions. Now I'll just do it with this user, and then the next user, and so on. So it's flexible. You can modify it. And then, of course, you can reuse it to death. You can just keep running the same script over and over and over again, and it'll never complain. It'll never, waver. It'll never water itself down. It'll run exactly the same way over and over and over again, and will have no problem no matter what version of Linux you're running, no matter how old it is, so on and so forth. It's super reusable, and it's just very useful. So some of the system administration use cases: you can back up system files, you can monitor system resources, you can install and configure software, you can automate user account management. You can parse log files. You can extract data from those files. You can convert file formats. You can deploy web application. You can run tests against those applications. You can compile and minify code, which is actually very useful. And then there's just general stuff. So renaming the files in bulk, moving and copying files, scheduling tasks, all of these things can be done through the creation of shell scripts. So we're going to get into the nitty gritty of this when we actually start creating shell scripts. So you don't necessarily need to memorize all of this right now because you're going to run this over and over and over again to practice these things and create them. But when you open a shell file, when you create a shell file that essentially could be file.sh, that would be a shell file. You open that, the very first line needs to be the shebang line that calls to the path of your specific shell bash or ZSH or whatever it is. That would be the interpreter that you use to write the rest of the code. So when you put that at the top of the text document, the computer then knows, oh, okay, this is what I'm going to run first. This is the very first thing that I'm going to run, and this is going to interpret the rest of the commands in this document. So then it knows that it's supposed to run a script. And then you can start, usually the very next line is a comment. So notice how this has a hashtag right here, but there's a exclamation at the second part of it, and then you have the path to the file, the bash file. What this is very different by having a singular hashtag. The singular hashtag is just a comment, meaning that this is not being processed. It's just something for somebody else who opens this file that wants to see what these individual lines of code represent. So you have a hashtag and then you explain what the next block of code does, or at the very top of the file, you'll have one hashtag right under your shebang line that will explain, okay, the purpose of this script is to do X, Y, and Z. And then for each block of code, or for sometimes even each line of code, you will have a comment right above it that says, this is what this line of code is going to do. And then you'll have the line of code that doesn't have this. So if there's no comment hashtag in front of it, that line of code is actually going to be executed, which means if you don't want the script to execute that line of code, you put a comment in front of it, and then all of a sudden, that specific line of code has been neutralized and deactivated. And this is actually something you'll find a lot in configuration files, where a lot of the commands that have already been pre-written, there's a comment sign in front of them, there's a hashtag in front of them, which means that that specific line of code isn't being run. But if you want to configure that software to do that specific activity, you just remove the hashtag, and now that line of code has been activated. And then there's structures for actual flows. So there would be the if-else commands. So if this happens, do this, otherwise, meaning else. If this happens, do this, else do this other thing, or don't do anything. For XYZ, do ABC. While this is true, then I want you to do this other thing. If it's not true, then stop doing it. These are types of the control flows. And then you have variables. So it could be, name is equal to Hank. That would be a variable. And then you can use values inside of variables. And variables are very, very useful. But essentially, these are kind of like the main points of a script. You can create variables within those, or you can call on the elements of those variables inside of an if-else statement. You can have inside of the if-else statement, you can have multiple variables and just recycle all of these things over and over and over again to create complex bits of code. But for the most part, this is the basic, super basic structure of a shell script. And then we have the user space. So the user space is the environment where the user level applications actually execute. So it's the separate space from the kernel, obviously, but it's the front facing environment where the user actually interacts with the system. So it's an isolated environment for applications to run without directly interacting with the hardware. So it goes from the user space to the kernel and then to the hardware. Technically, the shell is a part of the user space. This is a crucial separation for system stability and security, because you don't want the average user that doesn't know what the hell they're doing, they don't know their head from their butt, for lack of a better word. You don't want the average user to start interacting with the kernel directly, because they'll mess up the system. So you give them a user space, and a user space has its own series of filters and software that interacts with the kernel. And then if there's something wrong, the user space typically is the output that displays whatever the error message is to the user that says, hey, this is what you did wrong and this is what you need to fix. The key characteristics of the user space are that the processes are isolated from each other and from the kernel, preventing one process from affecting the other. So for example, the video viewer, so your video player, shouldn't be interacting with a text editor, right? It just isolates these processes from each other, and they also get isolated from the kernel itself. The user space contains a wide range of applications, including text editors, web browsers, games, system utilities, and then there's limited privileges that have been applied, so preventing the user space or from these actual users or these softwares from accessing hardware or accessing hardware directly or modifying system level settings. So you can't use a basic text editor to modify the kernel. It just doesn't allow you to do it because there's the limit of the authentication that takes place and the privileges that are verified by the kernel that say, hey, you can't modify me. You don't have the privileges to modify me. And this is where a lot of these things come in from, right? So for each user, their user space has limited privileges according to whatever the system administrator said they could or could not do. The user space is separate from the kernel, but they actually interact with each other, right? So the user space is how the user communicates with the kernel, whether or not they know that they're doing it. The kernel provides system calls that allow user space processes to request services from the kernel. Services that are requested by the user space from the kernel are the file system access, network communication, process management, memory allocation. So reading and writing files, right? Sending and receiving network packets, meaning you send Gmail to somebody or try to connect with Gmail through your internet or connect with YouTube through your internet. Those are all considered sending and receiving network packets. It doesn't seem very fancy when you think about it like this, but every time that you request a video to be loaded from YouTube, you're requesting a packet of data to be delivered to you. And that's done through your network. Creating and terminating and managing processes and memory allocation, so requesting and releasing memory by using the calls to the system, so system calls as we mentioned earlier. The user space processes interact with the hardware devices and other resources through the kernel, ensuring a secure and controlled environment. So when you think about the kernel and then the shell and then the user space, when you think about these three things, you can see how they kind of layer on top of each other. The kernel is the bridge between the user talking to the hardware, but they need some way to talk to the kernel. So they use the various tools and software and resources from the user space to talk to the kernel, and then the kernel talks to the hardware. And that's basically how you interact with a system in general. And now we need to know how the computer boots. How does a machine boot? What is the boot process? So there's something called BIOS and then the updated version, which is UEFI. BIOS is the basic input-output system, and it's common on the older systems. You may have actually, I don't know how old you are, but I remember BIOS on my very first computers. When I would boot the computer, it would say, BIOS is initiating, right? So it initializes the hardware and passes control to the bootloader. So it actually turns on the hardware, the CPU, the motherboard, etc., and then it passes the control to the bootloader, meaning it's going to boot or load the rest of the system, right? To access BIOS setup, you typically need to press a specific key. Depending on the computer, it would be delete, F2, or escape. Again, this is very old. Most likely, your computer does not have BIOS and it has UEFI, and that you do that during the boot process. So as soon as you turn the computer on, you start tapping F2, for example, until you actually get to the BIOS menu. And it allows you to configure the various system settings like the boot order, the clock speed, and the hardware settings. And the way that looks is like this. So this is actually when you get to the boot menu. Again, I don't know if you recognize this. Most likely you don't recognize this because this is ancient for the most part. Some people, I know that we have a few viewers that are a little bit, they're around my age or maybe a little bit older than me, that would definitely recognize this. And this is something that would be done in, really old computers. But this is basically the BIOS menu, right? So this is when you actually get into BIOS, and then you can do things like, the boot priority of the hard disk, quick boot, first boot device, second boot device, third boot device, checking of the password, and etc., etc., etc. This is not interacted with the mouse. This is interacted strictly with the keyboard. I don't know how much of this is completely relevant, but this is basically what you need to know, is that BIOS is on the older systems. It's considered the basic input-output system, and this is the piece of the boot process that initializes the hardware, and then after the BIOS is done, it passes the control of the hardware to the bootloader. Key functions is to power on and self-test. It's called post. So it conducts a series of tests to check if the hardware is all good, and then it issues a series of beeps to indicate the outcome of the test. So this is very nostalgic for me. I can recall those beep sounds every time I turn on my computer. And if there's an issue, the beep sounds are different. And once the post is done, hardware initialization happens. So it initializes the essential hardware like the keyboard, the mouse, the disk drives. Then it transfers the control to the bootloader, which loads the operating system, which then loads the system itself. So it passes the control to the operating system bootloader, and then it goes from the bootloader to the operating system itself. So it goes from BIOS to post, initializes the mouse and the drive, so on and so forth, and then it initializes the bootloader to process the rest of the boot process, and then it transfers the control of everything to the actual operating system. And then you have the basic input-output services, so that's the rest of these things. For the operating system, like the keyboard and mouse and display output, those are the things. So the keyboard and mouse would be your input, display output would be the monitor, and that's your basic input-output. UEFI, the Unified Extensible Firmware Interface, which is just a big mouthful compared to basic input-output system. The UEFI is the modern interface designed to replace BIOS. It offers more flexible, faster, secure bootting process compared to BIOS. And this is what this looks like. So you just from the get, when you look at it, you're like, oh, this seems more modern, right? It typically does the same things though. So it can actually have the same boot or tool or password or prioritization. All of those things still can happen with the UEFI. It just happens to be quicker. It happens to be a little bit more secure. In this particular screenshot, we see that there's an AI tweaker. Wow, super fancy. So it allows you to have the overclock tuner, the CPU, the selection, the filter of the PLL, the yada, yada, yada. These are all of the things that fall under the CompTIA A+ category to understand what all of these things actually mean. And you really don't need to master this for Linux. It's just that you need to understand that there was initially BIOS and then there was UEFI. And then the process of the purpose of these things is to interact with the hardware, make sure that the hardware is initialized, make sure that all of the system checks are good, so everything is running smoothly, and then it transfers the control to the bootloader, which does the rest of the loading of the boot process, and then ultimately transfers the control to the operating system itself, which means that it transfers it to Windows operating system or Linux operating system or Mac OS operating system. They usually all have the same type of process. It first calls on the hard devices, the hardware, and then the hardware is all good, then it transfers the control to the operating system. Key advantages of UEFI over BIOS. UEFI can boot systems faster. The graphic user interface, so it's actually point and click instead of just being keyboard navigated, and it's nicer. So it's a user-friendly graphic user interface. Secure boot, so it enhances security features like secure boot, which helps protect system from malicious software attacks. Large disk drives are supported through this. It can support the largest disk drives or larger disk drives than BIOS could. And then there's network boot that allows you to boot from a network resource, making it easier to deploy and manage systems remotely. So you can actually run something from a different location, which was not previously available through BIOS. Very similar to what BIOS was, right? So it still has the power on self-test. It still has the bootloader execution, and it still has the operating system boot. So all of those things still happen with UEFI. It's doing literally the same thing. It's just a little bit more advanced, more flexible than what the standard was with BIOS, and it's faster, more secure, more feature-rich boot process. That's basically what it is. It does essentially the same exact thing. It just does it faster. It's a little bit more flexible. It allows you to do it from a remote location. It's more secure, so on and so forth. Then you have the actual bootloader. So the bootloader is the middle ground between BIOS, UEFI, and the actual operating system. So once you start the BIOS or once you start UEFI, the Grand Unified Bootloader, or GRUB, is the bootloader that's in Linux distributions, and it takes control of the system and finishes the initial boot process. Then the intermediate, so again, it's the middle ground, right? It's the intermediary between the hardware and the operating system, and ensures that the correct operating system is loaded, and it provides a user-friendly way to choose between the different boot options. So for example, when we go through the installation portion of this, and you see as I go through the install process of Linux, we're going to be using the bootloader of my machine. And we're going to see oh, you know what? It's actually choosing us to choose Kali or the Windows installation. It's allowing us to choose the OS that we want to load. And that's where that goes, right? So the BIOS and UEFI make sure that the hardware is all good and there are no glitches. And then it goes to the bootloader, and the bootloader says, okay, which one of these OSs do you want me to load? And that's essentially the whole process between this thing. And this is kind of what, literally, this is actually what it looks like. Just a much kind of a more modern version on the computer that I had. But you see right here, it actually has two different operating systems. It has Linux Mint and it has Ubuntu. And it has advanced options for Linux Mint and advanced options for Ubuntu. So it has two different operating systems that you can choose from. And then it loads it, right? So it's flexible. It can support multiple operating systems, making it versatile for dual boot and multi-boot. It allows customization of the boot menu, timeout settings, default boot options through a configuration file, so you can develop that. We're not going to talk about that. It can be configured to provide secure boot options, protecting the system from malicious bootloaders. And it supports advanced features like the chain loading, network booting, and kernel parameters, which again are beyond the scope of this particular training. But what you need to know, BIOS UEFI checks the hardware, passes control to the bootloader, which allows you to check which operating system you want to run. And then from there, it transfers the control to the actual operating system. So the boot menu presents a boot menu that allows you to choose which operating system you want, which we already saw. If you have dual boot, which was what the example was, you can choose whichever one that you want to boot, whichever OS you want to boot. Then once you've selected it, GRUB loads the actual kernel and initial RAM disk into the memory, and then it transfers the control to the loaded kernel, which then takes over the boot process. Dual boot is literally what you saw. So this is just a breakdown of it. When you install an operating system alongside an existing one, so for example, that Linux Mint could have been the primary and Ubuntu could have been the secondary, the installer software modifies GRUB's configuration to include the newly installed OS as a boot option. Creating the boot menu generates a boot menu. User selection allows you to choose the desired operating system from the menu, and then loading the selected OS and then transferring the control to that OS. Once it loads the OS, it loads the kernel for that OS and then the initial RAM, the random access memory for that. And then it allows you to actually start processing, or it allows the computer to start processing all of those things. And then the control is sent to those things. So it transfers the control to that kernel and that RAM, initial RAM disk. And then those things essentially take over the control from the GRUB, and then you're actually in the operating system. It initializes the operating system, and that's when you actually get into Linux, right? So the benefits of this is that it's flexible. You can have multiple loads, experimentation. You can test new operating systems. It specifies task optimization for the specific OS that you want. So if you want one that's inherent to gaming, or one that's intuitive or just better with gaming, software development, system administration, all those things you can actually choose based on your goal. So you can choose the OS that matches your goal. And any data that's stored on partitions that would be formatted with different file systems, you can actually go access those individual ones. So for example, if you have data that's only available to the NTFS, which is a Windows thing, you can go and recover that data because you have dual boot. And then once you've gotten that, you can switch to Linux, right? So it allows you to deal with different formattings of data as well as different goals like gaming, software development, so on and so forth. So it's flexible. It's very beneficial. If you can do it, then do it. If you just want to run Linux from a USB drive and have a live boot, then do that. If you don't want to mess with your overall hardware installation or the storage capacity of your hard disk, then you can just load everything from a live USB, which is all good as well. So dual boot is more when you install it to the actual hard drive itself, to the actual physical computer. You install Linux, and now you have Windows and Linux on your file system. Then it goes from GRUB to SysVinit. So SysVinit is actually the traditional initialization system that was used in Linux distros to start system services and processes during boot. So SysVinit, or the next one, the systemd that we're going to talk about, those two are the step right after GRUB and the bootloader. So it's basically a sequence of scripts that run in a specific order to bring up the system. It runs those scripts. So if you are running SysVinit, which is again kind of like the legacy, the older version of it, it runs the scripts that are located inside of the etc initd folder, and they're responsible for starting and stopping the system services. It has different run levels. So for example, run level 0 is the halt state, run level 1 is the single user mode, run level 5 is the default multi-user mode, and it can choose those based on whatever the configuration was. And then during the boot process, it transitions through various run levels, starting from a low level, gradually moving to the higher level. And then as it moves through those, it executes the corresponding initialization scripts for each one of those run levels that are all located inside of this, right? The limitations here are that it's pretty complex to configure this and difficult to understand if you don't know coding or development language or syntax. It can be relatively slow, especially on systems that have a lot of services, or they have physical limitations, like the RAM is small or the CPU is old, so it can be fairly slow to boot. And it's limited on parallelism, meaning that it can only start the services one after the other, which is sequentially, which is inefficient, right? You typically want to start everything at the same time. If you just have to wait for this one to load and then move to the next one and then move to the next one, it'll take a long time, especially if the system itself, if the hardware on the system is actually slow and old, then this process can actually be fairly lengthy. So then you want to go into System D, which is the more current version of it. It's sophisticated, and it essentially does what SysVinit did, but it does it better. It's faster, more flexible, more feature rich, and it does the same thing, right? So where UEFI did the same thing that BIOS did, System D does the same thing that SysVinit did. And the way that it works is that during the boot process, it takes control and starts essential services. It manages the lifecycle of system services, including starting, stopping, and restarting them. It ensures that the services are started in the correct order and based on their dependencies. And then it logs system events and applications to a central journal. So this was not previously provided by SysVinit, right? So it goes through the boot process. It runs all the services that it needs to. If there's any dependencies that are required by those services, it'll make sure that all of those are also started. And then it journals the entire process and logs them in case there's any kind of troubleshooting that needs to take place, that you can backtrack and find out what happened. It's faster, obviously, as we've already talked about. It runs those systems in parallel. So as we talked about, where it doesn't provide parallel options in SysVinit, this can actually optimize everything by running everything at the same time and starting them at the same time, which reduces the boot time significantly, as you can imagine. If there are any dependencies by those services, so if a service requires something else to run, it manages those dependencies automatically and just makes sure that everything is all good so that all of these things load simultaneously. Some things have dependencies that are required, and we'll talk about the installation of dependencies later, but you want all of these things to load simultaneously. You want them to load automatically without you having to worry about it, without the average user having to worry about it, because they don't know what they're doing. So it provides a unified framework for managing system services, including starting, stopping, restarting, and enabling, disabling services. That is System D. It activates sockets, services that can only needed for further improving system performance. It can be activated through the sockets, and sockets are actually also very useful for networking as well, but that's beyond the scope of what we're talking about. So System D can activate services only when they are needed, further improving system performance. So if you don't need it, it's not going to be activated. Journaling, we already talked about it, in case there's a crash or analyzing system logs. Timers and scheduling, so precise scheduling of tasks. And device management, managing devices like disk, network interfaces, and USB devices. All of this is done through System D, which is very awesome and most likely, hopefully, the thing that you will have to deal with when you go through your actual responsibilities as a Linux administrator. Most likely, you will not have to actually deal with this in the real world at all, meaning you won't have to deal with SysVinit, most likely, unless you're really dealing with like an old school system. If you do, then just remember that they run everything is run based on those run levels that are associated with each one of those scripts that are inside of the etc folder, and the stuff is done not in parallel, meaning it's done one after another. It doesn't deal with dependencies very well. It's fairly slow. These are the key features that you need to keep in mind about SysVinit. And where SysVinit falls short, System D takes all of those things and then some, and just fills in all of those gaps. And you just saw how it did all of those things. And this is where we actually get to look at those run levels and boot targets. So run levels would be relevant to SysVinit, right? So these are the specific boot processes that is done through those various scripts. Each run level represents a specific state in the system, and then the system transitions through these things during the boot process. So you have these run levels. So halt the system basically means stop the system. One would be the single user mode. Two is multi-user mode without the file system, the NFS. Then there's three, which is the multi-user mode without the graphic user interface. Four is not used. Five would be full multi-user mode with the graphic user interface, and this is typically the default that loads. And then six would be the rebooting of the system. So these are the various run levels that come in SysVinit, and these are associated with those scripts that we talked about that are inside of that etc initd configuration. So boot processes, when a system boots, it starts in a low run level and it works its way up. As it initializes, it moves to higher run levels, starting whatever service is associated with that run level. For each of those run levels, the scripts are inside the etc initd directory, and these are defined. They define the actions that need to be taken when entering or exiting a particular run level. And then the init process, which is responsible for managing the run levels, can be instructed to switch to a different run level using the tell init command or by issuing a specific signal. And this is an example of that. So when you say tell init 1, you're asking it to run level 1, right? So tell init 5 would be asking it to run level 5. And you start the system in single user mode, which is what run level 1 is. So it causes to transition to that, stopping most of the services and going only to the environment that is associated with run level 1. And then you have boot targets in system D, which replaces run levels. So SysVinit had run levels, system D has boot targets. Powerful mechanism for managing the system state. They represent groups of services that should be started or stopped altogether. They define and control the targets, and by doing that, you can efficiently manage the system's behavior under different circumstances. So the target works like this. You have the dependency management, the activation of the target, and a deactivation of the target. So it automatically determines what dependencies between services are required and then starts them in the correct order for whatever the services are that you need to have. And when a target is activated, the system D starts all of those services associated with that, including the dependencies for all of those services. And then when you deactivate it, it stops all the services that are associated with it. So fairly simple. The common targets would be this, right? So you have the multi-user.target. It's the default target. It starts multi-user mode or multi-user target. And it starts services required for a multi-user environment, including networking, file systems, basic system services. Graphical target starts graphical services like the display manager and desktop environment. Rescue target, that starts services necessary for system recovery, like a minimal shell and network access, which typically does not happen unless you're actually troubleshooting. And there's the emergency target, which is the minimal target, starting only the most critical services required for system maintenance, which does not include network access for the most part. You're only dealing with that specific system and you're trying to figure out exactly what's going on. So it is the lowest level, and it only loads critical services required for system maintenance. So that's essentially the various forms of this. This is the highest level, and graphical user target or the graphical target and the multi-user target load together because you want to have multiple users, including networking, file systems, basic system. But the graphical target starts the graphical surfaces like the display manager and desktop environment. If you have a version of Linux that actually supports a GUI, this is the target that would come with the boot inside of system D. If you want the SysVinit scripts, if you want to manage them, you have to know where they're located, which is the etc initd. They're typically named after whatever service they're actually running. So Apache 2, if you're running Apache 2, MySQL, Secure Shell, etc. Each script contains instructions for starting, stopping, and restarting the corresponding service. SysVinit executes these in a specific order, ensuring that services are started in the correct sequence and the dependencies are met. So, for example, if you're running an Apache 2 server, you would need to load the Apache 2 server before you can load any other software or service that requires Apache to be running. If you try to load the software or service, but you don't have Apache running, then that doesn't work, right? So it needs to run in order. So it does that in the correct sequence to make sure that whatever needs the previous thing already has that thing so that it can run it. System D enables a service, and this is very similar right here. So instead of doing these scripts that would be running sequentially the way that they are, you can do it manually through enabling, disabling, starting, stopping, checking, restarting, and reloading. And this is all the pattern here is very simple. The syntax is very simple. So if you want to enable a service, you would use enable. If you want to disable it, disable, start it, stop it, check the status of something, restart something, reload something. It's very intuitive. So sudo systemctl system control, enable service name, disable service name, start service name, stop service name. And if you can probably put two and two together, you would need to enable the service first before you can start the service. And then you would have to stop the service before you can disable the service. So that's the order of these things that come in. Once you've enabled it, you can check the service and it says, oh, it's been enabled, but it's not going to be active because you haven't started it. Once you start it, you check that service status and you're like, oh, this is active, it's currently running. So you get that the status of that thing. And then if you need to restart it, you can just do restart the service. You can't restart it if it hasn't been enabled. Common sense, right? And if you need to reload the service configuration after you've done certain modifications to the config file, you would just reload the configuration or reload the service, and it will just reload it. It has to be running, obviously. Actually, it probably doesn't need to be running, but if it is already running and you modify the configuration and you want that configuration to apply, you would need to reload it. You don't necessarily need to restart it. Okay, so let's talk about the installation and package management portion of this whole thing. Specifically the preparing and installing distributions. Now, selecting a Linux distribution really has a lot to do with what you are trying to accomplish. So there are a variety of different versions of these distros. So we have the desktop version for Ubuntu, Fedora, and Mint. We have the server version, CentOS, the Ubuntu server, Debian, and then there's actually this one that I kind of forgot to put in the title here, which is the Red Hat Enterprise Linux. And of course, there's security and pen testing for Kali Linux. So it just depending on what it is that you're trying to do, these are the various locations that you can download your ISO images. So this is what's very important to consider. So if I go to the Kali website here, this is what it would look like. And so we have the various installer images, virtual machines, cloud, mobile, ARM devices, containers, live boots, and so on and so forth. For the intensive purposes of this particular portion of this tutorial, I'm going to be using a live boot ISO image, which means we want to install something that we can load from a USB drive. That's the whole purpose here. And you can have it in like one of those mini kind of USB drives, or you can actually have an external drive that is attached via a wire. That's what I'm going to be using. And mostly because of the fact that I'm also going to be using it as a storage container. So typically a small USB plug-in that is like the size of your thumb, for example, a thumb drive is what they call it. A small USB thumb drive does not have that much memory on it, so it won't go into the terabytes, at least not that I have looked for recently. I'm pretty sure they have them that can go into a significant portion of storage, but I'm going to be using something that has a significant portion of storage because for the rest of these tutorial recordings, I have to record the videos on that specific drive and make it so that it actually has enough storage for me to store video files, right? So, but essentially, this can be installed on any kind of USB plugin, which is called a live installation. It's a live boot or live installation. So we can choose anything that we want from this particular website, depending on the type of service or the type of purpose that we have for that specific installation. And then same thing applies to all of these other ones as well, right? So you want an ISO image for the specific distro that you've chosen, so that you can have that installed either through your computer itself, hypervisor, where it's like a cloud computing virtualization, or you want to install it as a live image to boot from a USB drive. So in either one of those cases, you would get your ISO images from these links. I'm going to put these links inside of the description below so you can get access to them directly. And I highly recommend that you don't get them from any kind of a torrent website. Just get them directly from the actual website for these individual distributions, so that you can be sure that there hasn't been any manipulation done with the ISO, and you're not downloading anything that you shouldn't be downloading, or anything that has been tampered with. That's a really big important piece right here. You don't want to download something that has been modified, even if the developer says, oh, this is going to be really, really helpful or whatever. Learn how to make those modifications yourself. Don't download something that's been pre-modified, especially from a torrent website, because you never know what you're going to be downloading, and if there's some kind of a malware or ransomware or something that's installed on it, a Trojan, worm, whatever, you just don't want to deal with that kind of stuff. So again, one last final notice: download directly from the websites that you see here, so that you get the actual ISO images that have been verified, and you know that they're good to go. Now, as far as the installation process itself is concerned, I'm just going to kind of give you an overview of this, but I'm going to demonstrate what this looks like when you want to use one of these ISO images to install a Linux version for yourself. So in this particular case, now as far as the installation process is concerned, I'm just going to give you like a step-by-step breakdown, and then we'll go into an actual live installation of Kali Linux, because I love Kali Linux, and we're going to install it on an external USB drive, and then you can just see what that entire process looks like. So first and foremost, you want to prepare your external drive. I always format it, especially if it's just a fresh drive and you want to make sure that it runs on all of the major operating systems. So for example, a Windows, Mac OS, and Linux operating system, you want your drive to be able to adjust to whatever that OS is and actually run on all of them. If it's formatted in one particular format and won't run on Mac OS or Linux, then you're going to be hindered and limited. So even if it's a brand new drive that you've gotten, you can use something like the Mac OS disk utility or the equivalent version on Windows to just format the drive so that it can run on all of the different OSs. And I'll show you what that looks like in a bit. So you want to prepare the drive and then make sure that it actually has enough storage space for Kali Linux. It's not a big file, so the installation and the ISO image is not large, but the recommended size is to have at least 4 gigabytes on the drive, just to make sure that you're all good. Then you want to download the Linux from one of the official links that I gave you and get the ISO image of the distro that matches your system architecture and your needs, whatever you actually want to do. And then we have the creating of the bootable media. So this is where Etcher, which is a tool, it's a free tool, so is Rufus. They're both free tools. Etcher is for Mac OS, Rufus is for Windows, and it essentially turns the ISO image, it creates a live image on that USB drive, so that USB can now be a bootable device. And once you connect it to a Windows machine or anything that allows you to do that, you can go ahead and load that Kali Linux image from the device. So technically, you're just literally going to be walking around with essentially a computer on a USB drive. That's kind of what it feels like, right? So you want to turn the USB drive into a bootable media, and we'll be doing that live as well. And then we're going to boot from the USB drive. So when you actually go through this process, this one is kind of fairly simple and straightforward. You're just going to be going through the wizard itself. There are a few elements that once I boot from the USB drive, I'm going to be recording, so I can show you what specific options you would need to choose to make sure that it loads. Most likely, in every case that I've gone through, you need to get to the BIOS or UEFI settings, which is the very base settings of the computer, so that it allows you to choose a boot from either the internal memory or from an external file. And what we're going to be doing is loading from an external file. And then we have the Linux installation itself. So this Typically, this is done using Rufus or Etcher, but sometimes it's actually also done from your computer when you're going through the boot process where you do your Linux installation. Now, if we're running from a USB drive, you don't necessarily do any kind of a Linux installation. It just loads from that USB drive. So that's kind of one of those optional portions. And same thing here. This is most likely done in Etcher or Rufus, and sometimes maybe it'll be done while you're booting from the computer, where you choose your language and the location, keyboard layout, etc., etc. Then we have the external SSD portion of this, where you choose this as the installation target, and again, this is done through Etcher or Rufus, where you choose the external SSD, which is when you choose the USB drive to be as your installation target, and then it'll install the live version of Linux onto that external SSD. And then you just go through the motions. You may be prompted to set up a username and password. If you aren't, the basic username and password is Cali. So Cali would be the username, Cali would be the password, and then once you're logged in, you can modify those. And then you just start it. You restart the computer, you boot into Linux from the external SSD, from the file inside of the SSD, and then from there you actually have your boot running and your operating system will load and you'll be inside of Kali Linux. So this is what the step-by-step looks like. So what I'm going to do now is I'm going to actually go through all of those steps and just show you what that looks like. Okay, so this is my disk utility on Mac. And so what we can see here is that I have my primary 2 terabyte drive and I have the Linux drive that's right here. And then there's actually a Balenza Etcher disk image as well that's been activated, because that's what we're going to be using to do our installation of the Kali Linux ISO. So in this particular case, I've already formatted this drive. I just want to show you what that process would look like so that you can make it usable by all of the operating systems. So I've clicked on the actual drive itself. Up here, I'm going to go through erase, and then the name is fine, it's Linux. The format is the big piece right here. So MS-DOS, as you can imagine, is Microsoft, Mac OS Extended, and Journaled. These two are going to be Mac OS specific. What we want to do is we want exFAT. exFAT is the multi-OS version of this, where you can just make sure that this thing will run on essentially any operating system that it runs on. Now, if your options for this formatting aren't exactly the formatting that you see right here, then just a simple Google search or a conversation with Gemini or GPT will allow you to find the specific formatting option that will allow you to go through a boot from any kind of a machine, Mac OS, Windows, so on and so forth. And then security options, this portion is, I've specifically actually had information that was on this drive previously. So I left it at fastest because it would be possible to recover the data that was on this drive if I leave it as fastest, because it's not the most secure, meaning it's not going to wipe it and make it unrecoverable. When you take it all the way to the end right here, it makes it absolutely unrecoverable. You won't be able to take any data from it, and it essentially overwrites the drive with a multiple series of zeros and ones, and literally just making it unrecoverable. You won't be able to boot anything from it. So that one's up to you. If you're getting a brand new drive, it doesn't really matter. But if you're wiping something that you previously had, you might want to keep it so that you can potentially at some point reboot it. And then once you've selected your options, you just click erase right here, and then it'll just erase the whole thing and make it a brand new drive so that you can use it for your installation process. And then this is what it'll look like. It'll just be 1 terabyte free, and then you have 12 megabytes that are still used, which I presume would be all of that data that I previously erased that's still kind of sitting somehow in storage back there. So that's pretty much it. That's all we got. And then the disk itself, the USB drive, will actually be ready for installation using either Rufus or Etcher. And now that my drive is ready, what I'm going to do is I'm going to choose the version of these ISOs that is most applicable to me. And in this particular case, it's the live boot that's available over here. So it's literally unaltered host system, meaning your main computer won't be changed in any way. You get access to the hardware of the host system. So if you have a 16 gigabyte RAM, the live boot will use the 16 gigabyte RAM. And then the customized Kali kernel, of course. Performance decrease when heavy in and out is not a input output is what that essentially stands for. It won't be affected in any way because, again, it just is doing a live boot from this piece and you're using the main system. So very quick, very easy. You get a full Kali installation or Linux installation, and then you can do this with all of the different versions of Linux as well. This is not limited just to Kali, so you can run all of the other ones from a USB drive as well. So I'm going to click the live boot, and then from here I'm going to pick 64-bit because my machine is actually, it can handle a 64-bit, so I'm going to do 64-bit, and from here on out I'm going to be using a Windows machine, and I just have verified on there as well that it is all good. And then the piece right here that you see that it says torrent and then the sum value, this is the piece that you can verify what the hash of this particular ISO image is. And for security purposes, if you don't get your ISO image from the Kali website directly, if you get it from some kind of a torrent website, you need to run the SHA-256 sum and find whether or not that value is exactly this value. If the value has been altered even by one letter, then don't do it, because the official installation SHA-256 hash value is this, which means that this is what Kali has actually confirmed. Therefore, it's something that you can trust, right? That's essentially how I'm going to go about trying to explain this as best as I can. The installation itself is 4.3 gigabytes, so we're going to just click download, and it'll start the download right here for me. And once that has been downloaded, we will go through Etcher and we will install it on our USB drive. Okay, so our ISO has officially downloaded and I have Etcher open, and as you can see, it's very, very simple. It's not a complicated interface. So what we're going to do in this case, we're going to flash from the file that we've downloaded, the ISO image. You can also flash from a URL, or you can clone a specific drive that you have. So I'm just going to do flash from file. And then from here, I have to choose the ISO image. And in this particular case, it's literally right here in my Kali Linux in my downloads folder. So I'm just going to click that ISO image. It has the ISO at the end of it. We're going to click open, and then we're going to select the target onto which we want to write this specific thing. And in this case, I have my Seagate BUP Slim BK. This is the one with the 1 terabyte. That's the one that I know that I want. There's the Apple SSD and all these various things. I don't want to mess with these in any way. This is the one that I want, which is the 1 terabyte drive. The Seagate 2 portable media, the 2 terabyte drive, that's the one that I don't want to mess with. Now, there is a way that we can just make sure which one these are, because I've actually renamed these and I'm not seeing the renamed version of this. So there's a way that I can find out which drive it is that has been assigned to disk 5 and disk 4, etc. And we're going to do that inside of our terminal. Okay, I have loaded my terminal very, very simply. The command itself is very simple. So it's disk util for the disk utility, and we're just going to do list. And you press enter and it brings up a bunch of data, including all of these partitioned drives that we have over here. And these partitioned drives should actually have their name that we've assigned to them as well. So in my particular case, we already saw on the Etcher that we had dev disk 4 and dev disk 5 were the two drives that it noticed that it said it has a lot of information or a lot of the size data, storage data on it. The 2 terabyte one is the one that is named right here, which is the primary 2 terabyte. That's the actual name that I gave it, not the name that it came pre-installed with inside of the when I bought the Seagate drive. That those are the names, are the ones that you see, like those original names is what we see. The next one is the one that I've named Linux, and that's the drive that I'm most interested in. And then we can see that it has the 1 terabyte size and the availability. In this particular case, we have the 2 terabyte size, but the availability is not that much because I've stored so much data on it. So it's not really that good as far as the availability itself is concerned. I definitely want this one that I named Linux, and I can see that it is inside of the dev disk 5 partition right here. So that's what is most interesting to me and most useful to me. So now I've confirmed that data, I've confirmed that information. I know that I want the drive that's on dev disk 5, so I can continue with my installation on Etcher. And here it is. I already had it installed because that's pretty much what I figured, because I knew it was the 1 terabyte drive. So this is it, the Seagate, BUP, SlimK Media, etc., etc. I'm going to select this one as my drive, and that's it. Once that's done, you just click Flash, and it says, hey, you're about to erase an unusually large drive. Are you sure that you don't want, are you sure that the selected drive is not a storage drive? And I'm just going to say, yes, I'm sure, because what I know is that I can go ahead and use that as a storage drive when I do launch Kali Linux in front of my, or from my other computer. You will also get notified to enter your password, because it is a privileged access type of a thing that it needs to run. So I haven't pressed enter, so it actually stopped, but we're going to retry this one more time because I just want to make sure that I do run it correctly. So we're gonna run it all over again, and I'm just gonna enter my password at the very end real quick, just to give it permission to do what it needs to do, and then it'll create the drive for us. Okay, so there you go. The password went through. I got a permission request for Etcher to access this particular drive, and I gave it the request, and you can see it's working, and it works very quickly because it's not a massive ISO image or anything like that. So it's going to take maybe another 30 seconds or so, and then the installation of Kali Linux will be done on this external USB drive, and then we can go ahead and boot it and talk about the rest of the stuff about partitions and package managers, so on and so forth. Alright, so when I reboot my computer and I just keep pressing F12, this is on a Windows machine, it'll take me to the boot menu. And then when I get to the boot menu, the option that I want is to actually get to the boot screen, which is F9 for me. And then I choose a live boot from a file, and then I choose the Kali image that I had. And then I go to EFI, and then I go to boot, and then I choose the 64-bit version of it. And then this is what we land on. This is the actual menu for Kali from any kind of a USB drive, or even a CD-ROM if you actually had a CD-ROM. And then you see that we have all these options to boot from live from the USB itself, and then we have the installation portion. And what I'm going to do for this section is I'm going to boot it from the USB live image, and we're going to boot it with USB persistence. And as soon as you pick that image, it basically brings you to the loading screen here. So it usually takes about maybe like 20 to 30 seconds for this to actually load. And then when it loads, we have the operating system running, ready to go with all of the utilities installed. And essentially that's it. So it's that quick to just boot from a USB drive without going through the full installation process. So you'll see here in a couple of seconds that it'll actually load, and I had to actually record the screen with my cell phone, so that's why the image quality is like this. But when we start doing this screen capture, once we're inside of the Kali Linux machine, it's going to be much clearer, and you'll be able to see everything as I click around. And here we have it. This is literally the operating system loaded, ready to go. We have, of course, the file system with all of the system binaries and everything like that. You can open up a terminal and have that run very quickly and smoothly. And all of the utilities, for the most part, like 90% of the utilities are already pre-installed. And then if you wanted to go to your home as the user, you would access it through the file system. If you went through the menu, you would get access to all of the utilities and the shortcuts that are available. So it's a fully functional operating system that's available. So what I'm going to do right now is I'm going to restart it, and it'll take me back to the very beginning of the computer's boot process, and then we'll do F12 again so that we actually can get to the boot menu. And then once we are inside of the boot menu, we're going to repeat the same process that we did before, meaning we're going to go and actually do the boot menu itself by F9. Then we're going to boot from a file. We're going to choose our Kali live image. And then I'm going to go to the EFI option and go to boot again and then choose the 64-bit version again. But this time around, when we actually get to the menu here, I'm going to actually click the installation option so that we can go through a full install. So you can actually see what it's like to go through the installation process with Kali Linux Wizard and how to select your partitions and so on and so forth. So pretty much just like every other operating system, when you boot it for the first time, it'll ask you your preferences. So your language and your country and I guess the version of English for me. And then I'm going to just keep pressing next until it gets me to the portion where I have to choose my partitions. And essentially it's going to ask me how I want to split the memory storage of the computer that I'm on, because I'm using technically a type 2 hypervisor, because this is being booted from my Windows machine. So my Windows machine, the operating system of the Windows is going to be the primary portion of the operating system, and then we're running Kali Linux as an extra installation. And so the main hardware of the Windows machine is going to act as the basis for this, and then we have the Windows machine itself, and then this is going to be our dual boot option, where we can, if we whenever we restart this and we get to the boot menu, we can actually choose to boot Kali Linux instead of booting the Windows machine. So actually, technically, I think this is a type 1 hypervisor because we're booting live from the hard drive. We're not booting on top of the actual Windows operating system. So I won't go inside of the Windows operating system. So you can see I'm setting up my username here, and I'm setting up a password for my installation. All of these things are very, very intuitive and very easy to follow the instructions. And I do stand corrected. So once this installation would be finished, this would actually be our dual boot option, where we are running Kali on top of the hardware of my computer instead of running it on top of the Windows OS. So meaning you would log into Windows OS and then you would use some kind of a hypervisor to launch Kali Linux. Instead of doing that, we're booting it live from the Windows OS. And this is the portion that we get into where we do the selection for how we want to create our partitions. And so it essentially just gives the recommended option. If you don't know what you're doing, you can just follow along with the options that it gives you, and it creates the most basic partition split apart for your root directory, your user's home directories, and all of the other primary and extended partitions that would be necessary to boot Kali Linux. And I'm using the external drive that you can see right here. It has about 1 terabyte of storage that would be used for my partitioning file system. And then that's what I'm going to use to create the rest of this, the browser, or not the browser, the wizard. And then it's going to be a guided process, and everything else would, after that, once you press accept and you press enter, it's going to start creating the partitions. And then it's going to actually take you into the boot menu, very similar to what we had from the live version. You would restart the system, and then you would select your Kali Linux installation, Kali Linux operating system, and then it would just load Kali Linux, and it would look exactly what it looked like from the live boot that we did from the USB drive, except that time around, you would be running it directly on top of your hardware. So I'm restarting my computer, and then we're going to get back to the presentation. All right, let's talk about managing partitions, file systems, and disk usage. Here are some important partitioning concepts to consider and to keep in mind. So the role of partitions in isolating systems or user data is mainly to preserve space on a physical storage device. So if you can think of partitions as logical divisions of a physical storage device, allowing the operating system to manage the data in separate, isolated areas on the same device. They're key in organizing the data and helping with performance, security, and manageability. And the visual is really the big thing that I kind of wanted you to wrap your head around. I work well with visuals, and I feel like you may also get value from this as well. So if we look at this left portion right here, let's say you have two physical storage devices, right? So you have piece 1 and piece 2, and piece 2 has been broken down into 3 separate pieces right here. You can consider that to be partitioning. And so this can be actual physical storage, or it could be one of the primary partitions, as we'll talk about in the next slide. It could be one of the primary partitions that has been broken down into multiple pieces. But to really just kind of wrap your head around what partitioning is, kind of like the name implies itself, you're breaking storage space down into parts. So it could be the actual physical storage space. So you could have one physical storage device that's on your computer. So whether it's a server, or it could be your laptop, or the Kali Linux machine, or really anything on a USB drive or something like that. You could have an external storage device that you've plugged into your computer. That could be the physical storage device. And as you go through booting and setting up your computer, so let's say you're installing Linux on one of your storage devices, or as a virtual computer or a virtual machine, and as you go through the installation, it asks you for the drive to use for partitioning, and then you select your external drive to be your partitioning storage, or your storage device that you will partition. And then from there, it'll just go through its various options, and it'll guide you through it, or you can manually select how you want to do it, like we did in the installation video, or the installation portion of this video, right? So that's essentially what partitioning itself is, right? So when you think about the advantages that comes along with partitioning, there are threefold, and this is just kind of a general approach to it. So the isolation of data, right? So they keep system files separate from user data, reducing the risk of user data corrupting, or the corruption of user data in the event of any kind of a system failure, right? So you keep system data as well as user data separate from each other. You isolate those data types from each other, so that in case anything happens, one or the other won't affect the other, right? And then you have the performance of it. So when you separate frequently accessed files, such as the stuff that's inside the var directory, the variable directory, from system critical files, that can improve the performance of the machine, right? So frequently accessed files can be logs, they can be dynamic data, email spools, whatever it may be. Those things, if they're kept separate from the system critical files, then it can actually help the performance of your device. It can make it run smoother and faster. And then you have security and recovery. And this is a really big one, especially for our world on this channel. We talk about security all the time, and you're probably going to be in incident response at some point. And having backups and securing the crucial data is very, very important. So when you isolate system files inside of a partition, separate from user files, it makes it easier to manage the permissions and restrict access to those system files right here. And it enables quicker recovery in the event of data corruption or system failure. So these are some of the key advantages of going through partitioning. Now, here are the examples of the common primary partitions. Most Linux devices break down to, at max, 4 primary partitions. One of the biggest and most important one is the root partition. So this would be the main directory where everything is installed, including the home partition and the var partition and everything else, right? It is an extension of the root partition, and keep that word extension in mind. So you have the root partition, the home partition, and the var partition. These are typically the most common partitions, and when you go through the installation of any Linux device, you will see that as your options, right? You can say that, use one specific location, use that as the main partition, or break it down into these 3 common partitions. And then the swap space is a separate partition for managing memory overflow, and we'll talk about what that is in a little bit. But these are the most common partitions, and in a lot of cases, these are also the primary partitions. So this is what we're going to be talking about right now. So the primary primary partitions are the main partitions that can be directly used to boot the operating system. So for example, the root partition, the root drive, that / that represents root, that is a primary, or I would say the primary partition. The limitations have to do with the traditional partitioning scheme that actually allow a maximum of 4 primary partitions per hard drive. Now, it's common to use primary partitions for the main operating system and important system data, and then have your extensions and logical partitions go for other types of data. So the root, so if we go back to this real quick, this is the main directory where everything of the OS is installed. The home is the storing of the user-specific files. So for example, the variety of different users. If you have 5 users inside of the home directory here, you'll have 5 separate folders or 5 separate directories for each one of those users. And typically it's the username that's assigned for each one of those directories. And then you have the var partition, which is isolating the frequently changing files like the logs that can grow in size over time, and then you'll need to wipe them eventually to help preserve space on the overall storage of the computer, right? So if your computer has, I don't know, let's say 1 terabyte of storage, then this specific thing will take up a lot of space, because if you don't have proper scheduling of the backups and the wipes so that you can transfer it from that main terabyte of storage into another storage device, this can overflow very quickly and it can take up a bulk of your 1 terabyte, right? So these are the primary partition types. Now, what happens is that you have these primary partitions. So these are the actual primary partitions. More often than not, the root is, I would say 100% of the time, the root is the primary system partition. It's the main partition where the Linux operating system is installed. It contains all the system files, the libraries, binaries, and everything else. So we talked about those when we looked at the file system earlier. We were talking about all of those extensions of the root partition, and that's where all of these system files are considered to be installed. And so we talked about the library and the binaries and the system binaries and the temp log and all of that stuff, or the temp folder, and all of these various other partitions or extensions of the root partition. Then you have the boot partition, which contains the bootloader, the kernel, other files needed to boot the Linux system. It's usually a small partition and around 500 megabytes to 1 gigabyte, because it doesn't require a lot of data space to run store the kernel and the bootloader and all those things. But this is also a main primary partition, because without this, the system won't be able to boot. It won't be able to start. And then you have the home partition, which is also another one of those primary partitions. And these are the 3 that have to do with the variety types of data that are stored, let's say permanently on the machine. And then you have the swap partition that deals with the random access memory. It deals with the temporary data and the processing power of the machine that you're using. So it's used as virtual memory when the physical RAM of the computer is maxed out and you need a place to store some of the virtual or the volatile data points that need to be stored temporarily until you don't need them anymore. And so the swap partition deals with the random access memory or data that's similar to the stuff that's on random access memory, which is considered to be volatile data that just is also considered to be dynamic data that goes in and out, and you use it more in like a live environment. And then typically when the system reboots and when it restarts, this whole thing is reset and you don't have to worry about this stuff anymore. We don't consider hibernation to be a part of system reboot. System reboot is when the computer is actually restarted or the system is actually restarted. Hibernation is just when it goes to sleep, and then you need to recover all of the data that was inside of the RAM, inside of the hibernation file, as well as the swap partition to pick up where you left off. So these more so are permanent partitions with stored data that you can access after reboot, after reboot, after reboot. And then this is volatile data that typically is reset and wiped every time you reboot the computer. And of course, hibernation does not count as a reboot. When a computer goes to sleep, it does not count as a reboot. So these are our primary partitions. And then we have the extended partitions. So an extended partition is a container for additional logical partitions. So the extended partition is not the actual storehouse of the data. It's a container for other logical partitions. So it helps to bypass the 4-partition limit that's dedicating one primary partition as an extended partition, which typically is the root partition. So the root drive, the root partition, ends up being that one primary partition that becomes the extended partition, and then within the root drive you end up having all of these other logical partitions. So for example, the /tmp and the /dev and / everything else that falls under a logical partition. So the primary partition gets extended, right? So primary partitions can and often do act as extended partitions. However, there's only one extended partition that can be created on a physical drive, but it can contain numerous logical partitions. So that means you can literally have essentially as many as you need within that one primary partition that has been extended. So the extended partitions are commonly used on systems that need more than 4 partitions without using newer partitioning schemes like the GPT partitioning scheme. So we're talking about a lot of the traditional Linux, which in the modern world it's still being used. So you're going to most likely run across the primary, or the we can call it the legacy, the original partitioning scheme that has the 4 primary, and then within that one primary, which is the root, there's a bunch of other logical partitions, and you're going to run across that a lot, and you're going to need to know that as a job for a Linux administrator. And then when you deal with a GPT partitioning scheme, it's just easier to deal with it simply because the fact that it allows you to have more than 4 primary partitions, and then you can storehouse or compartmentalize your data easier. So these are some extended examples. So the /var log, or the var folder, this can actually be a primary partition when you're doing your installation of Linux, but you can also just have it be one of the logical partitions. So it can be the extension of the root, right? So it's the root is represented by this /. The var right here would be the extension, and then inside of this you will have the var log, and then the var email, or var whatever, and you'll have a bunch of other logical containers that will have a variety of different types of data. So for example, log files and databases, email spools, and any other dynamic content that is being frequently used or updated. So it helps manage large amounts of data that change frequently. So this is one of the very common extended partitions, which could also be considered a logical partition. And then you have the /temp, the temporary files. So this is also another extension of the root partition, and it holds temporary files, right? Then you have the /dev, which is a logical partition for development work, or it can be the other, we can call them virtualized portions of your machine. So this is another extension of the root partition that can act as a logical partition as well. So essentially what you're doing is you are extending the root drive, and then within these folders you will have a variety of other folders that will act as the logical partitions that are stored inside of these extended partitions. So hopefully that's making sense a little bit. And finally, we have the logical partition. So these are the subdivisions within an extended partition, right? So you can have within the home directory, within the home extended partition, you can have a bunch of user partitions, a bunch of user folders, and all of those user folders end up being the logical partitions. Within the var directory, you can have the /email, /log, etc., and you can have a bunch of other folders or directories that act as the subdivisions of that specific directory, and that ends up being the logical extension, the logical partition of this extended partition. So hopefully that makes sense. So just going back to this image right here, just to kind of give you another visual with the example of extended and primary and logical partition. So if these two, for example, are our primary partitions, and then within this primary partition we have these extended partitions, and then this one could be the var partition, this one could be the dev partition, and this one could be the TMP partition or the home partition, for example. So these could act as anything, right? And so if you want to expand on this, so if we bring this one right here, and this ends up being the var partition now over here, which ends up being our extended partition, and within this var partition we would have the log and then the email and whatever else it would be. That's how it breaks down, right? So you have the primary that gets broken down into these extensions, and then these extensions can come, and then one extension could be broken down into multiple logical partitions. So that's really how the whole thing ends up breaking down, and it's essentially just a way to organize your data and to compartmentalize data, so you can, as the benefits that we talked about earlier, you can just have better access to these things, and you make sure that it performs better on the actual system, and in case there's any security or backup issues, you'll be able to compartmentalize and access certain points much easier, and if one thing crashes, it doesn't affect everything else, so on and so forth. So partitioning serves multiple purposes, and it's fairly a simple concept once you kind of really get a chance to wrap your head around it. You have 4 primary partitions. Within those primary partitions, one of them can be turned into an extended partition. So from that root, we can have multiple extensions, and then each one of those extensions inside of it is going to have a variety of different partitions that will be the logical. So there is 4 primaries. One of those primaries is going to turn into an extended, where you can have multiple extensions inside of it, and within each one of those extensions end up being containers for all of the other logical partitions, right? So you can think of partitions also as containers if it helps you. And that's essentially all that partitioning is, when you just want to understand the concept of partitioning. And to give you a few examples as far as the way that the file system looks, so let's say that you have the extended partition, which is dev SDA4, right? So this is the extended partition that's on your disk, and this partition itself doesn't store any data directly, but it actually has it becomes a container for other logical partition. So within this partition, you can have multiple logical partitions that serve various purposes. So for example, within dev SDA4, we can have dev SDA5, which is allocated to data, right? So this is done inside of either the partitioning process as you're doing your installation, or it's done inside of the configuration file that is stored inside of our etc directory. And within that configuration file, we can make all of these assignments of these partitions, and we'll talk about that in a little bit. So this logical partition is created within the extended of SDA4. It's assigned to the mount point of data, meaning that when you access data in your file system, you're actually accessing this specific logical partition that is housing all of the data inside of that. It kind of seems a little bit confusing, but if you can just wrap your head around it, you'll see what it means. And then I'll show you what the tree structure of it actually looks like and how these things are connected, so you have that visual as well. But it's typically used for storing user data, documents, media files, etc. So that's what the /data file is, or folder, with the /data folder. That's what it houses, is the user data, documents, so on and so forth. And it gets mounted, right? So it gets mounted onto this logical partition that is sitting inside of that extended partition. So we can also have SDA7 that is inside of the SDA4, right? So SDA5 would be in there, SDA7, I think it was supposed to be SDA6 or something, and I accidentally clicked 7, but it's allocated to backup, right? So this is the third logical partition within this specific extension, and it's assigned to the mount point backup, which is used specifically for storing backup files and system snapshots, and it helps in organizing backup data separately from other system and user data. And then this is our tree visual of this. So this would be our extended partition, And then within this extended partition, you have these multiple logical partitions. And this one is mounted at data. This one is mounted at the var folder. And this one is mounted as the backup folder. Okay. So you don't need to go really deep into this. It's beyond the scope of what's covered inside Linux Plus. But you just need to understand the difference between primary, extended, and logical partitioning so that as you are asked questions or you are looking at potential examples, you can differentiate between these various partition types. A final note on this: during installation, the wizard will guide you through the partitioning and will ask you how you want to partition your hard disk. Even if you boot from a USB drive as a live boot, you can still choose USB persistence and maintain your partitioning options. And in this case, you'll likely have to manually edit your partitions. You'll create the partitions using the fdisk or the cfdisk command, and then from there you'll mount each of the new partitions inside of the etc fstab configuration file, and that's essentially how it looks like. So this portion of it, I don't know if this will be right before we go through the actual wizard for the installation of Linux, or this portion of the lecture will be after we've gone through it. But either before this you will have seen this entire concept, or after this you will see the entire concept. I'm not sure exactly how I'm going to end up putting the edit together, but for sure you will see this this example of how this partitioning is actually done, especially with the installation of the wizard. In 99% of environments, there's going to be a wizard that will guide you through the partitioning and will do all of these things for you. So if you want to boot from a USB, you'll need to know how to configure the fstab configuration file, but more often than not, you're not going to need to worry about that, because if you're booting from a USB, you're only using it for its capabilities and not as a storage device. And that is a completely different situation, and it's beyond the scope of this particular training series. So that's essentially how you can ensure that your partitions are run and configured during installation. And you will have either definitely seen that prior to this, or you will see this right after this, right after a piece. Swap space is something that is disk space that's designated to act as the overflow for the system RAM. So when the physical RAM on your system is exhausted, the system uses the swap space to temporarily hold inactive memory pages, allowing active processes to continue without crashing. So let's say you have a bunch of software open and a lot of them aren't currently actually being used. So what's going to happen is that those memory pages are going to be stored in the swap space, and your physical RAM is going to be dedicated towards anything that you're actively using. And if that ends up being too much, so if your swap space ends up getting overflowed as well as your physical RAM, that's when you start seeing the system slow down drastically, and then sometimes you even see a system crash because you're really overclocking the processing power of your computer, and at that point it just can't handle everything that you're throwing at it. But more often than not, what happens when your physical RAM is maxed out, it just sends everything that's temporarily inactive. So it could just be something that is minimized on your computer, or a document or something that you're just not using. Those end up going in the inactive memory pages, but you can quickly call on them to bring them back to the forefront. And then once they come back to the forefront, they go from the swap space and they start using the physical RAM. So the swap space is for inactive memory pages. So just keep that in mind. And that's how it alternates back and forth between the physical RAM's processing and what is being done in the background, so to speak, the inactive memory pages that are running in the background. By doing that, swap space extends your memory's capacity. So when the system hangs, because memory demand exceeds what's available on your physical RAM, the swap space acts as a buffer to prevent crashes of the system. It takes a lot, especially in modern computers, because modern computing is strong enough that you really don't go into a system crash unless you're really just you haven't done a reboot in years, and your computer has a million different tabs open and a bunch of different software open. You typically don't see, I haven't seen a system crash on my computers in a very, very long time, because the swap space along with the RAM that I've chosen works very well. And I just like using computers or buying computers that have a lot of physical RAM, because I want it to run fast, and I do video editing and I do gaming and all these things, and you just want a good computer that has a lot of physical RAM. And the CPU's gigahertz, the hertz power of the CPU also contributes to the processing power of this. So if you have a really strong CPU as well as a lot of gigabytes of RAM, you're not going to worry about this kind of crash or anything. But in the event that you're dealing with a computer that is mainly just for Linux and data processing, it's acting as a database, and it can't handle a lot of the workflow that's being thrown at it for whatever reason, then the swap space will kick in, and it'll help alleviate some of the pressure that's being put on the physical RAM, so that there is no crash that happens. So it will extend the memory capacity of the physical computer. And then it also facilitates hibernation. So we already kind of touched on this a little bit, but it's also required for the system going to sleep, right? So when the system goes to sleep, there's a lot of stuff that is inactive at that point. And a lot of those things go inside of those inactive pages, the data pages, memory pages that we refer to. And those things are just stored in the background. And when the computer wakes back up or it comes out of hibernation, all of that stuff is recalled from the swap space. So your computer can pick up where it left off. And that's another one of those things that's really, really powerful, especially if, like, for example, when you have a laptop and you don't actually turn off the laptop, you just close the screen, like you pull the screen down, that's going into hibernation. And when you lift the screen back up, you literally are waking it up, and it's pulling all of its data from its swap space. And this applies to both Linux and Windows and Mac OS. So swap space is not something that is just inherent to Linux, right? So it applies to everything. They may have different names for it or titling for it, but this concept applies to everything. So it's just an extension of the physical RAM capacity to make sure that the RAM itself is actually all good and the computer runs smoothly. And in case the computer goes to sleep, you want to pick up where you left back up, so it recalls all of the data and all of the processes that were active and then went to sleep, and now you need to reuse them again. Now, some general commands that we need to just keep in mind. These are very important partitioning commands. To create a partition, you can do it with either the fdisk command or the parted command, and we'll talk about those in a little bit in depth. But these are all sudo commands, so it does require some kind of a root permission, or at least for the user to be on the sudoers list. But you do sudo fdisk dev sda, and it creates or modifies or deletes some kind of a partition in this particular case. And then parted is another one of those things that with this specific command, it's creating a primary partition with parted, and it's using the format of the ext4, and it's giving it a 1 megabyte to 512 megabyte capacity. So these are just examples of parted. We're going to go further in depth into fdisk and parted in a few slides, but these are just some sample commands of what it looks like to create a partition or to be able to modify a partition with either parted or fdisk. And parted also has a graphical user version of it that is outside of the command line that's very, very intuitive, and you can use it with just point and click, and it's very easy. So if you're not using just a Linux command line type of a computer and you actually have access to a graphic user interface, more often than not you'll end up using gparted, which is the graphic user version of this. So these are just some sample commands of what it looks like to create a partition. These are the sample commands to view your current partition. So lsblk lists the block devices and the partitions that are associated with them, and an fdisk-l will list all the partitions and their details. So these are some ways that you can view your current partitions and how much storage they're using and what they're assigned to, so on and so forth. So these are things for viewing partitions. And then these are some sample commands for dealing with swap space and managing your swap. So mkswap swap on and swap off. Swap on and swap off are fairly intuitive. You can kind of tell what they do from just their name. But mkswap makes a swap space at this particular location, so it initializes a partition for use as a swap. And then swap on activates a specific swap file. All right, now we need to look at file systems from the perspective of partitioning. And this is another review of what we talked about earlier. Earlier, we were just talking about file systems in the context of file systems and where things are located, how things are broken down. Now we're going to be looking at it from the perspective of partitioning. So the ext4 is the fourth extended file system. So it's the most recent version of ex2, ex3, etc. And it's the default in most Linux distributions. It's very reliable, it supports large files, and journaling. The file system is one of the most widely used in Linux, typically set as the default in many distributions like Ubuntu and Debian. And Kali Linux is technically an Ubuntu distribution, and so it runs with the ext4 as well. It builds upon the previous versions, which is 2 and 3, and it has enhanced reliability, speed, support for large files, etc., etc. So ext4 is most likely what is going to be run in a lot of desktop platforms if you're going to be doing system administration for Linux on desktops. These are the key features of ext4. We've already talked about this, so I'm not going to spend too much time on this slide, but it provides for journaling, which helps protect data integrity. It records changes before they're applied to the main file system, making recovery easier. It provides large files or supports large files. It has backward compatibility, meaning that it can actually work with ext2 and ext3, allowing users to mount and use those specific file systems without reformatting, which is actually very convenient. And it has delayed allocation and extent. So what that means is that it improves the disk input-output performance by reducing the fragmentation, the breaking down of data, and better managing storage space. So it's as the expected performance is, it should be the better version of ext2 and ext3, allowing for better performance, the better management of storage, so on and so forth. So ext4, the most commonly used, and it does journaling, large file support, backward compatibility with the other versions, and delayed allocation and extension so that you can better manage your storage space and better manage your actual input-output performance. So the input of your requests and calls into the system and the output from the system to reply to your calls and grant the requests that you're making. The typical use cases for ext4 is, as we mentioned, desktop systems, personal laptops, general purpose servers. It's because of the fact that it's most commonly used and it's one of the most versatile. It's used in a lot of common use cases. And it's a good option for people who prioritize data integrity and who may need backward compatibility with older types of file systems. So this is for the personal computer, desktop system, general purpose server, so on and so forth. That's what ext4 is great for. And more often than not, as a beginner Linux administrator, you're not going to be dealing with massive data centers and things like that. So you're going to be dealing with ext4 file systems more often than not as a beginner Linux administrator. If you wanted to make an ext4 file system, you would just run sudo mkfs, so make filesystem.ext4 to just make sure that it's creating an ext4 file system, and then you give it the mount point that you wanted to make the file system on, and then check or repair that would be fscheck filesystem check .ext4 and then give it the mount point that it was already installed on. So these are some ways that you can create one and check or repair the status of that specific file system. And then we have XFS, the XFS file system. It's for performance and scalability. It's a very popular choice in enterprise environments. So this is where you actually go into data centers and high performance 64-bit file systems. That's for speed and scalability. So it's used in enterprise environments, meaning handling a lot of users, most likely, or scenarios where high data throughput is critical. It was originally developed by Silicon Graphics, so it's become a popular choice in Linux distros like CentOS and Red Hat Enterprise Linux, which are the enterprise choices for Linux, right? So this is scalable. This is the notable factor or the notable characteristics of XFS is that it's fast and it's scalable, so that you can have a large environment with a lot of users or a lot of computers that use its data. So high data throughput means that it provides data, access to data, it processes data very quickly compared to the XT4, right? So this is designed for big environments. The key features is that it has efficient metadata management. So handling metadata heavy workloads, which is basically for requesting or requiring frequent file creation, deletion, or renaming. And this doesn't seem like a big deal, but when you have 1,000 users, that's kind of a big deal, right? So a lot of users are going to be creating data, renaming data points, or renaming files, creating files, deleting files, and that process by itself just needs to be done quickly when you have a lot of users. Journaling, a very similar concept. You're going to be hearing about this a lot. It's done a lot in all of the different file systems that you're going to be dealing with. More often than not are going to have journaling, just in case there's some kind of a crash and you don't want to lose data. It is scalable, so and large file systems, making it suitable for system handling large data sets and high performance workloads, which means if you have a lot of employees, if you have a lot of computers or servers, it's a really, really good file system for that. And of course, it can resize file systems without requiring them to be unmounted, providing flexibility in storage management, which is, again, something that's very important in data servers or in data centers, so that they can work with the data without unmounting it and for somebody stopping the use of it. You know what I mean? So you need to be able to allow your employees and your users to still access that data, so you don't unmount the data, and you can still allocate various dynamic or do dynamic allocation, which is essentially the name, that can help you just resize the file system. So resize the potential allocation of that specific file system for this one computer or for this data center to make sure that yada, yada, yada. I feel like you get it. I don't want to kind of regurgitate and repeat myself over and over. But it allows for live environment allocation and changes to be made so that the users can still use the system and you can do what you need to do as the administrator. The typical use cases for this are going to be, of course, enterprise servers, data centers, environments that have a lot of input, output, performance, and scalability requests, such as databases, media servers, scientific computing, etc., etc. So a big environment that requires a lot of processing power and high performance applications. So large files that need to be accessed and managed efficiently, like video production or big data analytics. These are some of the environments that require XFS or make use of XFS. And these are some of the example commands to create one. So make file system, make mkfs.xfs, and then you give it the mount point, sudo xfs growfs, sudo xfs underscore growfs, and then the actual mount point itself. So resizing requires the file system to be mounted and is supported only for increasing the size. So just keep that in mind. So you can't decrease the size. You can increase the size of the file system by using growfs, grow the file system, and then check the repair file system. So xfs repair, and then give it the mount point. So these are just some of the example commands for using and interacting with XFS. And of course, we have the swap file system. So swap space. It's the dedicated partition or file that's used to extend the memory, as we've already discussed. It's unique compared to everything else that we talked because it's not a traditional file system. It's actually used for live data, right? So it's an extension to supplement the physical memory which is our RAM, our random access memory. So it's not storing files or storing data. It's just a live type of swap space or file system, technically. It allows the system to avoid out-of-memory issues. We've already gone through all of this. So memory overflow management is used when the system memory RAM is fully utilized. We talked about this. Hibernation support, we talked about this. The partitioning versus the swap file is kind of a concept that I guess should be noted here. A swap partition versus a swap file. So a swap was created as a separate partition. So a swap partition. It was created as a separate partition which could offer performance advantages due to the dedicated space on the disk. The swap file, which is inside of a lot of modern systems, they use the file inside of a partition itself because it's more flexible. and it can be resized or removed quickly without having to deal with all of the partitioning commands. So previously the swap partition was something that you had to actually have to create that specific partition using fdisk or any of these these various types of tools. Whereas if you're dealing with a swap file, you can resize the file, remove the file, do anything without actually having to mount, unmount, and deal with the process that's done through partitioning. So more common systems are going to have a swap file, and the older legacy systems are going to have swap partitions. The size recommendations for your swap file or your swap partition, it really has to do with the RAM size itself. So if there is not that much RAM typically available, then the system would benefit from more swap space. So twice the RAM size. That would really, I don't exactly know what is technically considered to be not that much RAM. If you have ample RAM, so let's say more than 8 gigabytes. If you have more than 8 gigabytes of RAM, then you don't need that much swap space. So for example, you can get away with having 2 gigabytes of swap space, and in some cases none at all if the memory itself is actually really, really powerful. So if you have really, really good RAM, you probably don't need a swap file or swap space. So it just depends on the physical size of the RAM itself. Now again, unless it's a really old business with very little RAM or like a really old computer, you're not going to run across a situation where the server doesn't have enough RAM. That's just, I feel like this is a bit redundant, but it is something of note. So it is something that you should just keep in mind, because you may deal with like a legacy computer or an old computer and they may not have that much RAM, or maybe they're expanding and the computer itself doesn't have that much physical RAM, and so you need to deal with some kind of a swap space or a swap file to cater to the massive size of the company, or as the company expands and continues to grow, so that they don't crash and until they can upgrade their systems and buy better RAM or a bigger computer, or so on and so forth. So these are some of our example commands for creating and activating a swap partition. So you make the swap space first and then you turn it on. So make swap, that would be the swap space. Swap on, you turn it on. Create and activate a swap file is a little bit more. So the file allocate or F allocate, 2 gigabyte, or excuse me, this would be an L, it's not a 1. So this would be 2 gigabytes to the actual swap file, which would be the name of the swap file or the path to the swap file. And then you need to change the permissions, so to actually give it permissions, and usually it's the type of permissions that the system itself requires or a root user requires. And then you create the swap space, so make the swap space and then give it the swap file path, and then you enable it. So first you have to allocate something for that swap file, then give it the permissions that it needs, and then make that as the swap space, and then turn it on so that that specific swap file can be used. And then if you want to just look at the usage or see how it's working, so you can do swap on show or free-h, and those will give you the swap usage data points that you would need. All right, so now we're going to talk about the various commands that will allow us to do everything that we just talked about. So fdisk is one of the more common ones. It's a command line utility that's used to create, modify, and delete partitions on a disk, and is commonly used for managing the master boot record, or the MBR, which is the traditional partition that allows you to have 4 primary partitions. But it can also handle the GPT, which is the GUID partition table, that can allow you to have more primary partitions. So fdisk is the most commonly used, right? It's a command line utility, and you can create, modify, and delete partitions on a disk. The key functions would be things like, and this is in no way meant to be the full list of commands that you can run. If you just do man fdisk, then you'll get the full list of what you can do with fdisk. So this is not something that's supposed to be all-inclusive. But this, these are some of the common ones. So sudo fdisk l would list all the available partitions and the basic disk information about them. Interactive mode, so if you run fdisk as well as the name of the partition, so this would be the path to the partition, so you would need to replace that with the actual target disk. It opens an interactive mode where users can add, delete, or edit partitions inside of it, so this could be a interactive version of running fdisk instead of just running individual commands to do what you want to do. And then after you've done all of your commands or modifications in interactive mode, you would type W and press enter, and that writes all of the changes that you just made to the specific disk that you are associated with. So you would create a new partition using the N option in fdisk. You would select that partition type or choose a partition type that you want. So for example, xt4, and then assign the size that you would want, and then you would press W to press the changes. This is like a overview. We're going to do this in detail when we actually go into the command line portion of this whole thing, but you can also get a lot of different breakdowns of this if you just go to Gemini, or if you go to GPT or anything like that and ask it to walk you through creating a partition and going through the various options of what it would be like to mount it and delete it, so on and so forth. But we will go through those examples as well. And then we have parted. So it's a more versatile command line tool than fdisk because it supports, obviously it supports the MBR and the GPT schemes. It's ideal for resizing, copying, and modifying partitions without losing any type of data. So it's kind of a more recent version of it. You will probably run across both of these, and the command line structure of them is relatively similar. And they, for the most part, allow you to do the same things. You just need to be familiar with the fact that both of them exist. There's an interactive mode, so very similar to fdisk. You would just do the same similar type of command, except now you just do sudo parted, and then you get into interactive mode. You can create, delete, resize partitions with commands like mkparts for make part, rm to remove, and then resize part. Very like intuitive. I think that's one of the big things about it. And then when you get to the GPT partitioning table, when using large drives, which are massive, so 2 terabytes in today's world is actually a very large drive, parted is often preferred because it natively supports GPT, which is used for a file system that is that requires more than 4 primary partitions, right? So the smaller file systems or the smaller storage disks use the previous one, the MBR, and then GPTs for the file systems and the disks that are definitely going over 2 terabytes because they're considered to be much larger, especially when you're not even dealing with media and you're just dealing with text documents and configuration files and logs and things like that. 2 terabytes is a lot of space. So parted ends up being the premier choice, the first choice for that. An example command to create a new partition would be to just use parted. This would be the disk or the physical location that you want it to be stored on. You are making a partition, so mkpart, and then you're making a primary partition with the ext4 format, and you want it to be 1,000 megabytes. In this particular case, what ends up being a gigabyte. So you're creating a gigabyte size primary partition with the ext4 format on the specified disk, which would be at this particular location. And then you can just run disk utility or a variety of different command line tools to figure out what partitions you actually have mounted onto your device. And then from there, you would choose that specific path for it as you're creating your new partitions or extensions or logical partitions, so on and so forth. And then we have gparted, which stands for the GNOME Partition Editor, and it's basically the graphical front end for parted. And it's available for a lot of Linux distributions that actually have a GUI, a graphical user interface. If it's just a command line Linux, then it doesn't exist. But most of the desktop versions and anything that actually has a graphic user interface, there is a gparted version of parted available for you. And you can do everything that you would do with parted using an intuitive graphical interface. So it's very user-friendly. It provides a visual representation of partitions and unallocated space, allows for easy resizing, creating, and deleting of partitions, and it's ideal for users who prefer graphic over command line management and need a quick way to modify partitions. So pretty much does everything that parted does with a graphic interface. Since you're not going to be using the command line, you basically just need to know how to install this thing, and so you would do sudo apt install gparted, and we're going to go through apt, which is a package manager, and that's for Debian or Ubuntu. And then you can do sudo dnf install gparted for Fedora, and then you just run it sudo gparted to open the graphical interface. So the launch and the installation is actually done on the command line, but the rest of the stuff will be done through the graphical interface. So you just need to know how to run these things to install them and to start it, and then from there you can go ahead and use the graphic interface. Okay, so now we need to list the block devices, right? So we've created the devices, and now we need to display the information about those devices, including the disks and the partitions to those disks. And you want it to be user-friendly or close to user-friendly. So it does it in a tree format, which you've already seen. So list lsblk will list the block devices. It's a great way to get a quick overview of storage devices on the system. And the key features is that it has a hierarchical display, so it's the tree structure that we referred to earlier. They're showing you the relationship between the actual main device and its various partitions, and it puts the information like the device name, size, type, and mount points. So the essential info. You're not going to get a lot of crazy details from this. So, but this is a very common tool to use to just see what all the block devices are, essentially meaning what all the physical devices are and what the partitions are that are attached to them, and it's done in a nice tree format. And these are some of the example commands. So lsblk displays a simple tree view of all the devices. Using the -f includes the file system information like file system type and UUID, and then -d shows only the main devices, excluding any of the partitions. If you have a very large environment, you don't want to see all the partitions, you just want to see the main devices. This will show you just those main devices using the -d flag or option. And then we have df, which is disk free, that basically reports what is being used or what is free. So it gives you the free space for each of the mounted file systems, as well as what's the use space on it. But it's one of those things that if you wanted to see just specific data about the file system disk space usage, you would use disk free. It displays total and available space for each file system. DFH to display sizes in megabytes and gigabytes, making the information more readable. And then DFT will show the type of each of the file systems along with the usage stats that you have. So this is for DF. And then these are just some of the example commands. So H again lists all the stuff. H home will show you the disk usage only for the home directory. And again, all of these things you can find the specific options that you can run by going through the manual page for each one of these tools. We're just going through sample commands, and then when we actually get to the practical version of this where we start using the command line and going through everything, we're going to go through a lot of this stuff in depth. So this is, I'm just going kind of like a quick overview of this so you can get some familiarity with it, and then we'll go into the great details later. DU is for disk usage, and it's used to check the space usage for specific files and directories, providing a detailed view of which directories consume the most space. So it's not a file system thing. It runs when you run DU-SH with the -sh on a specific directory, it provides a summary of its total size. When you run DU by itself, it shows disk usage for each directory and the subdirectory, and then DUH and then the threshold of 100 M for megabytes displays only files directories that have over 100 megabytes of space that they're taking. The command examples would be sh on this particular path would give you the total size of the verilog directory itself. The AH home provides a detailed recursive view of the home usage, listing all of the individual files in the directories, which can be massive. So this you don't want to do on a super large directory because the output could be massive. So if anything, you would take the output of this command and you would pipe it or export it into a separate file so that you can look at it outside of your terminal. Because it really can be a lot of data if you're going to list all of the files and directories. So it can just be a big output. So just keep that portion in mind. Most of this specific thing you don't want to run just on the terminal just to look at it, because the terminal doesn't output everything. It's like it's limited to how much data it can actually show you on the display. Even if you scroll all the way up, you may not see everything. All right, now we can run through our package managers and the various commands that are associated with them. So the intro to package managers. Package managers are tools for managing software on Linux. So it's like a tool for managing other tools to help you install tools and to help you update tools, so on and so forth. They automate the process of installing, updating, removing software, and it makes it relatively easy, or if you know what you're doing and if you are very familiar with the command line, it makes it easier to maintain a consistent and up-to-date system. They handle dependencies, meaning the stuff that the software requires to run, right? So each software may require a certain number of dependencies for it to run. So the apt manager, or the package manager, the package manager will handle those dependencies to make sure that any required libraries that you need and the tools are installed alongside whatever the software is that you are installing. So when you say, sudo apt install such and such, it won't just install the tool, it'll install all of the dependencies and the libraries that that tool needs to run properly. And then it saves you a lot of manual dependency resolution and potential conflict. So you don't have to go hunt down all the different dependencies, because it can get very, very tedious, especially if it's a piece of software that requires a lot of different elements and adjacent tools for it to run properly. You don't have to go hunt those things down manually. You just run this one command, and that one command gets all the dependencies that you need, the libraries, so on and so forth. So very, very useful. We have apt, which is the most common that I've used because I usually use Ubuntu and Debian versions of Linux, and it stands for the Advanced Package Tool. It's very, very common. So if you want to install something, you do sudo apt install the name of the package. If you want to update something, sudo apt update and sudo apt upgrade. You can technically run those both at the same time. That's what the double ampersands go into, that we kind of talked about. Actually, I don't think we've covered operators yet. I was just doing a Linux tutorial, a Linux fundamentals tutorial. So we haven't gone through the operators yet. But when you do two ampersands right here, that means you're running both of these commands simultaneously. So it's going to run this one first, and then it's going to run that one next. So it's going to update the list of the softwares as well as the software itself, and then it'll upgrade anything that it needs to. And if you want to remove something, sudo apt remove, and then you give it the package name. So very, very intuitive. And most of the package managers are actually similar to this. apt or apt is known for its ease of use, the robustness and extensive repository of software packages. And again, it's the most commonly used because it's associated with Ubuntu and Debian, which are the desktop versions of Linux, and very, very user-friendly. As you can tell, the commands themselves are super intuitive as well. So very user-friendly. We have yum, which is the Yellow Dog Updater Modified, or DNF, which is the dandified version of yum. And this is for Red Hat, so CentOS or Fedora. These are the distributions that would use yum, but it's pretty similar to what we did with apt, right? So it's like sudo yum install name of the package, or sudo dnf install name of the package, update or updates. It's pretty much the same. So you just use yum instead of apt, or you would use dnf instead of yum, or whatever it is, depending on what version of Linux you're running. And typically, if you try to do like sudo apt install such and such, the terminal will actually tell you, oh, this is not what is used on this system. We use yum on this system, or we use dnf on this system, and it'll give you an updated command to run. So it'll say, yeah, this doesn't run here. Instead, run sudo yum install the package name. So it's also very, very intuitive and very user friendly. Yum has been replaced by DNF in the newer distros like Fedora. So DNF offers improved performance, better dependency resolution, and a modern design. But essentially, they kind of operate on the same distributions of Linux. And then finally, we have Pacman. This is my favorite name. It's the package manager, and it's used for Arch Linux. And Pacman's commands are a little bit different than what we've seen with apt or yum. So sudo pacman -s, and then the package name is the installation. Sudo pacman and this is a capital S, by the way, and then capital SYU would be the software update, and then capital R package name would be the removal of the software itself. So it's known for the simplicity, speed, and flexibility, which is a common or a favorite among Arch Linux users and handles binary packages and source packages with ease. So all the other ones do too, in my opinion, or in my experience, I guess I should say. But this is something that is specific to the Arch Linux distribution, so you need to be aware of it. So the name Pacman is not the video game, it's a package manager, and it's for Arch Linux. And these are the commands for the installation, update, and removal of software using Pacman. And finally, for this section, we have the updating, removal, or troubleshooting of packages. So updating packages and system upgrades. The reason why we want to do this is a few-fold. So the first one is security, obviously. So there are patches that need to be applied to certain packages as the vulnerabilities are discovered. So when you're considering the approach for ethical hacking and pen testing, the reason why they do those things is because they want to try to break the package so that they can find whatever the vulnerabilities are. Sometimes vulnerability scanners don't do their jobs, and sometimes there's an announcement that's made that, hey, we found this vulnerability, you need to go patch this specific package that you're using. So this is not uncommon. This happens very frequently, and running an update on your package manager should be a habitual thing that you do, maybe even daily, every time that you log into your Linux, or every time that you're about to install something, or every time that you're about to use a specific piece of software or specific package. Anytime you're about to use that thing, just run update real quick and just make sure that it's the most recent version of that includes all of the patches for it. Then there's also security features that come with those updated versions of those packages, and then of course the dependency updates as well. So if there's new dependencies that are required to run the updated version, that's something that you may need. And these are just some of the common things that fall under the bracket of security. And then you have stability. So there are bugs that are associated with these softwares or these packages. So just make sure that that's all updated. I mean, these are so common sense that I feel like I don't even need to go through this. You just need to understand that updating packages and the system itself, whatever you're running, needs to be a regular thing. You need to check for system updates and package updates regularly to make sure that compatibility is there, performance is there are no bugs that are running, there's no security issues, and the functionality is all great, the user experience is great. And of course, if you're in a regulated environment, you need to be compliant. So if there's something that has to do with customer data and it's not updated, and then there's a leak of the data because there was a security vulnerability, you are now in grounds for a lawsuit, or the company is in grounds for a lawsuit. And guess what? You as the Linux administrator are going to be fired, because this is something that's so simple, that can so easily be done, and it's so powerful. So it's like, just keep all of your packages up to date. Keep your system up to date. It's not complicated to do, runs a couple of commands, and it's very, very useful. And of course, compliant to the regulatory environment that you may actually be in. Now, these are some of the update commands, the upgrade commands. So you do sudo apt upgrade, and it updates all of the installed packages that you have on your particular system that runs apt. And then sudo dnf upgrade runs all of the updates for the packages that you have installed on the DNF system. So if you don't want to upgrade the package individually as you're about to run it, you can just run this daily upgrade with apt or DNF or pacman or whatever it is, and just make sure that everything on your system in your environment is fully upgraded. I would say removing and cleaning up the packages is probably just as important as running the updates on the packages. The main reason for this is to free up space. There's also something called the orphaned package or unused dependencies that you just don't use them anymore, and they're taking up storage space. So this is probably something that is also as important to run as the updates of everything, to just make sure that if there's something orphaned, meaning that it's outdated and there's a newer version of it, if you run an upgrade on something, you should also run the auto remove to remove whatever that's been orphaned. And a lot of times you will also get a notice from the system, some kind of an alert that says, hey, are you sure you want to remove this? This one's associated with this, and then you can either say yes or no. But for the most part, it'll get rid of the things that are either orphaned or legacied or grandfathered, so on and so forth, or unused. So this is as important of a strategy as the upgrade and the update of all of your packages. And thankfully, troubleshooting the package issues is not something that you would have to do super in granular detail as well. You just need to run a certain series of commands. So if you have a locked database, for example, so if there's a locked package manager in a Debian-based system, which is Ubuntu, for example, it means that another package management process is running or it didn't terminate correctly. So what you want to do is you want to remove that specific locked front end. So sudo rm removes the lock file, and this is the location of the lock file. So this is the file that's used to lock that package database while the apt is running, and then sudo rm removes that specific file. This is the full path to that file, right? So this is how you unlock a locked database, for example. And then you'll get the notification again. Your terminal will tell you that, hey, this can't work because this is happening, or this didn't terminate correctly. And then you can go ahead and just run the sudo rm, sudo remove, and it'll work for you. And then you have broken dependencies. So if something is no longer current, or it's outdated, or it's missing a piece, or a dependency for whatever reason wasn't patched properly. So if it's not installed, right, any of those things, the version is outdated or it's not the correct version, any kind of conflict that would fall under a broken dependency, you can do a fix broken command. So sudo apt -- fix broken, and then install. So it tells apt to fix broken dependencies by automatically installing or removing packages that are necessary. And then DNF check will check for dependency issues and report them. And then you can use DNF distro sync to synchronize installed packages to the versions in their repositories to make sure that all the dependency issues are resolved. So again, this is what's really awesome about these package managers. You don't have to do the manual hunting of, oh my God, I gotta go fix this. A lot of these things are automated. So you just run a command and it'll just automatically install or remove packages that are necessary. It's so freaking useful, but you just need to know that you can do this, right? And then you need to know what the command is. So by the end of this whole thing, you're going to have a dictionary of commands that you can run to take care of a variety of different things, which is just, I think it's super freaking useful. So there we go. This is the broken dependencies, and then we have repository issues. So repositories can be unavailable or misconfigured, causing issues with the package management. To resolve this, you might need to re-enable or update your repository resources. And those things can be done using the various resource lists or the locations that are on the sources list. So apt sources list or the apt sources list.d, both of those are very useful on the Debian-based system. So you can view the sources list in those regards and just see if it needs to be updated, or the sources or the links or something might not be right. And then one of the most powerful tools for that is just copy the contents of it and then take it to Gemini or GPT and paste it and say, hey, does this look right? Is something wrong with this? And it'll tell you if something is missing or if something is wrong. And then Red Hat Systems check the repository file in the etc yum repos directory, and that you can just make sure that all the sources for your repos are all good. However, if you don't want to do all of that, if you don't want to go to GPT or whatever, you could just run these commands, right? Because they're automated and they can just make sure everything is all good. So if you run for APT, you can run apt update. For DNF, you could run a make cache or DNF update. For yum, you could make a cache or do a yum update info, and then pacman, you can do this as well. And essentially, they'll just make sure that the URLs in your repository files are correct and accessible, and they'll make sure that everything on your sources list is up to date and current. So again, you don't need to do a lot of these things. You don't have to do manually, because these amazing package managers will automate a lot of that processes for you, and just make sure your sources are up to date, make sure all the dependencies are up to date, make sure the versions are current, and if there's any bugs or anything that's been patched, all the security vulnerabilities, all of that stuff is taken care of by running regular updates and regular removals as well. So make sure that the removals and the updates are being done in tandem to get rid of anything that might be orphaned or out of date, and to make sure that everything that needs to be updated is updated. To make sure that everything is all good, you gotta update the package list. And basically, this is literally, these are the commands that would do all of that stuff for you as well. But sometimes you might need to just restart the system, or you might need to restart your shell, or just really just not running the update command. I think is actually all good. But just restarting the shell sometimes can do wonders if those update commands aren't making everything run properly. And then if that fails, you can just restart the system. And then it just guarantees that everything is updated and current, as well as your package lists themselves. All right, now that you have Linux installed, hopefully you took some time to actually install either your own version on a USB so you can boot it live, or you have it installed on your computer where you booted it as your operating system, or you're using a virtual machine, or you've used TryHackMe's virtual machines that are all Linux based, or you have a Linux computer, whatever it is. So hopefully now you're in an environment where you can actually run these commands. Now, if you have a Mac OS, for the most part, you can run most of these commands as well. If you don't have them, you may need to install them using one of the package managers and get access to them. But in either case, I would say do it in a Linux environment. If you can download Kali Linux or a version of Ubuntu, whatever it may be, so that you have no problems and you can be sure, you can rest assured that you can run all of the commands that are coming up. What we're going to do is we're going to go as an overview, because we're technically still in the lecture portion of this training series, and I'm just going to show you what these commands are. I'm going to tell you what they do and the purposes that they serve, and then when we get to the second portion of this whole thing, where we actually get to the practical exercises, you will get plenty of chances to run all of these commands, and we'll run all of these commands in an actual live environment where you'll see me run the commands, and we'll look at the output that comes from the commands, and we'll combine a variety of these different things. What we're going to be talking about is just the basics of the command line and the basics of scripting, so that you have an idea of what it all looks like and the syntax and the general structure of all of this stuff. And then we'll go into the other chapters that we have, and then when we come back at chapter 12, we'll actually run all of the commands as well. So that's essentially where we're at right now. The essential command line tools and navigation is what we're going to look at. All of these commands will yield some kind of information about the system that you're logged into. So who am I gets you the current logged in username. By the way, all of these things are case sensitive. So if you do who am I with a capital W, it's not going to work. Who am I gets you the current logged in username. Uname displays all of the detailed information about the Linux machine that you're on, including the hardware installation, the name of the Linux, the version of it, the OS kernel version, so on and so forth. And then there are various options that come along with uname as well. So this is just uname by itself. There are other options or flags that you can attach to uname to get different results. But uname is typically about the detailed information about the machine, the hardware, the name, and the OS kernel. Then you have the host name, which gives you the VPS name, the VPS host name, and other related info. So depending on what flag you run with it, it'll get you different information about that individual host. So with no option, it just prints the host name. With the I flag, so dash lowercase I, it checks the server's IP address. Dash lowercase a prints the host name alias. Uppercase A gets the system's fully qualified domain name, which is also known as the FQDN. There is a difference between the who am I and the host name. So the who am I is just the user. So whoever you are as the user. You can be multiple users on the same host, and that host would be on the same machine. So there could be multiple users logged in, but they would be on the same host machine technically. And then the same thing with the hardware and the Linux machine, and so on and so forth. So who am I specific to the actual user that's logged in. Uname is specific to the hardware of the machine, the name, the OS kernel, stuff like that. And then the host name is relevant to the actual host itself that you're logged in on, which is typically that machine, as well as the IP address, the hostname alias, if there is a hostname alias, and the fully qualified domain name as well. Another way to look at the username and the hostname is that the username is assigned to a specific user on a computer network, while the hostname is a label that's assigned to the device on the network. essentially identifying the computer itself rather than the individual user. So there would be an IP address assigned to it, the MAC address, and so on and so forth that would be assigned, that would come under the host name data versus the username that comes under that individual person. So the username is the login name, while the host name is the name of the computer on the network. And that's not to be confused with the uname. So the host name would be the name of the computer, the username is the name of the user, and then the uname just brings various data points about the computer itself, for example, the hardware and the OS version, so on and so forth. All right, on to navigation. So navigating the actual computer itself. So the first thing that I always run is pwd, that prints the working directory, meaning the directory that you're currently logged in or the directory that you're currently accessing. It prints that path for you. CD changes the directory. So if you do CD home user documents, you're changing the directory to the home user documents, and you're going to end up inside of the documents directory, the documents folder. And then when you run pwd while you're inside of the folder, what's going to happen is that you're going to get this full path. So it's going to print that full path of wherever you're logged in on onto your screen, and that'll say that is your printing of the working directory. And then once you're inside of that directory, you can list the contents of the directory, which would be with ls. And ls typically just by itself would just list whatever is visible. It's not a hidden file specifically. What happens is that when you do ls-l, it'll print the detailed view of all of those specific files. And then when you do ls-a, it shows the hidden files. And then you can combine these two flags and you can say ls-la. So instead of doing -a or -l, you could just do -la, and it'll give you the detailed view of everything as well as show you all of the hidden files as well. So print working directory, change the directory, and list the contents of any given directory. And then there's the interaction with individual files and directories, namely creating files and directories, copying files and directories, moving files and directories. And these are what these commands are for. So touch by itself, if you just want to create any kind of a file, you can do touch and then the name of the file, which would be this specific thing. If you want it to be inside of any given directory, you can give it a full path. But typically you would be inside the directories, let's say the documents folder, and you just say touch file.txt and it'll create file.txt for you. And then if there are any options that you want to attach to it, you can attach those as well. We'll get into all of those things in a little bit when we actually get to the practical section. But touch is designed to create a new empty file in any given directory, even the directory that you're in or the directory that you give the full path to. Make dir, which would be make directory, it creates one or multiple directories if you wanted to, and very similar, it's mkdir, and then any options that you wanted to give it, and then the name of the directory 1 or directory 2, and that again could be the full path to the directory, or you could be inside any given folder and then you create a new directory. And basically what it does is it creates a folder that can house files, whereas touch by itself creates a file. So you can't expect the file that's been created by touch to be a container for any other files, because it won't be. It'll just be a file. So make directory creates a folder that you can house a variety of other folders, or you can house a variety of other files inside of it. CP is copying, so it can copy a file or a directory, and then when it copies the directory, it'll also copy everything that is inside of that folder. And so you would do CP, and then you would provide the source, which is the thing that you want to copy. And then you would provide the destination, which could be the location of where you want it to go to. And if it's going to be inside of the same folder that you're in, you would copy whatever the file is that you want to copy. And then you just need to give it a name so that it won't be the same exact name. So if I want to copy file, I would need to have as my destination file2 would be the second argument that we supply to this command. And it can still be inside of the same directory that we're in. It'll be inside the same folder that we're in. Or we can just say that I want you to take whatever the file is inside of my current directory and I want you to copy it and move it to this whole other location. And then you would give that full path to it. And move would be another one of those tools that you can use, but instead of copying, it actually just takes that original file and it will transfer it out of wherever it's sitting and move it to a different location. You can also use it for renaming something. So if I say move file 1, I would give the new location and it will transfer file 1 to that location. Or I can just say move whatever the old name is and rename it to change it to the new name, and it won't copy anything, it won't do anything like that, it will just rename the file for you. So it can either move the file from wherever it's sitting and transfer it somewhere completely different without copying it, so just keep that in mind. If you move it, you're not duplicating it, you're transferring the exact file itself, or you can just rename the file. RM would remove the file, so that would be the command that you can delete an entire file, or you can delete the directory that includes everything that's inside of that directory. So if you do rm-r, it'll actually delete the directory and everything that's inside of it. And it's very similar to doing rmdir, so it removes the directory and everything that's inside of that directory. So you can do removal of the directory using the -r flag that goes with it, or you can just do remove dir and then remove everything that's inside that directory as well as the directory itself. So just keep that in mind, that when you remove a directory, you're also removing everything that is housed inside of it. So if you need it, you need to make copies of it, or you need to move whatever is inside of it to a different thing so that you can delete that directory. File gets you the file type of whatever the name is that you give it. So you say file, either the path to the file or whatever the name of the file is inside your current folder. And in that regard, it'll say, okay, this is a text file, or it'll say it's a Python file, or it'll be a CSV file, comma separated value file, so on and so forth. It gives you the file type. And believe it or not, this is actually very useful, especially when you get into scripting, because there are certain interactions that you can't have with certain file types. So you need to know what type of file that you're dealing with. And if the file type is the file type that you want to interact with, you would then use the series of commands that could potentially interact with that file. So getting a file type is actually very important, especially when you get into scripting. And then zip would compress the file. So it basically just creates a zip file for you from one or more files or a directory that you assign. So you can say zip and then choose whatever option that you want. And then you would take the file name and then that you want to create. So this would be the zip file name that you want to create. And then this will be the file that won't be added to it. The next file that's going to be added to it. You can have a series of files, but essentially you would zip. This would be the name of the zip file, the name of the zip folder, and then these would be the files or the folders that would actually be compressed into that one zip file, that one zip compressed folder. Unzip extracts the data or the contents of that individual zip folder. So it's a pretty simple concept to understand. So again, if you choose any specific options, you can do that. And then you just give it the zip file name that you want it to unzip. Typically, it would unzip inside of whatever location that it's already in. So you just want to make sure that wherever you are unzipping it, you want those contents of those files, because sometimes a zipped file will have a bunch of content in it. And when you do unzip it, if you wanted to move to somewhere else, you would have to move all of those things manually by doing the mv command. So if you want to unzip it in any given directory, a specific location that you want all of that content to be, first you move the zip file to that location and then you unzip it. A tar or tar command itself, it bundles multiple files and directories into an archive, but it doesn't compress them. So you just run tar, the tar file name, wherever the location is going to be, and then the files themselves. They don't get compressed. Typically, it's good for archiving and creating archives so that you can interact with them without having to unzip them. Because when you zip something, it gets compressed, and then you would have to unzip it to be able to interact with it. Tar just bundles it, multiple files into one location known as an archive, and then you can interact with the contents of that without having to decompress it or unzip it, so to speak. These are some of the key operators that you need to keep in mind, and this is actually very important because you're going to be using this very, very frequently. So the first one, I'm just going to call this the greater than symbol, or pointing forward, I guess we can call it, whatever it is. The greater than or pointing forward adds the outputs of any command to an output file. So for example, if I do echo file contents just by itself, it'll just print file contents onto the screen. But if I do echo file contents and I push it into the new file, then it takes this, whatever is inside of this, or whatever is inside of any given command really, and it puts that inside of this file. then this overwrites anything that is currently inside of the file. So you need to be careful with that, because if you want to append something, if you want to add data to any given file, you would use the double greater than symbols instead of a singular one, because the singular one literally overwrites everything inside of that file and you lose whatever else was previously inside of the file. So more often than not, what you're going to do is you're going to take a given command. So you're going to run some kind of a command that will analyze something. We do this a lot in security, where we would run a, let's say a top command, or we would run TCP dump or something like this. We would run some of these commands, and instead of getting the contents displayed onto the screen, because it's going to be a lot of content, we would output the content inside of this file so that we can review it later and manipulate the content of it. When you're appending something, you would add whatever those contents are to a new file. And for scripting, this is very, very important to understand, because more often than not, when you write a script, you don't want that script to overwrite everything that would be inside of your folder or inside of your the output file. You want it to add, every time that you run that script, you want it to add the contents to the output file instead of overwriting everything that's inside of that file. So this one overwrites everything and creates a new file, or it'll just create a new file for you. Then this one appends it. It adds the output to the file, and you keep everything that was previously inside of that file. There is the AND, so ampersand. You place this at the end of any given command, especially if it's a big command that takes a long time to process, so that it backgrounds the command for you. And then when it's backgrounded, you can still continue to use your CLI, your command line, instead of having to wait for that command to finish. So for example, if we were to run something that's big like this, and then we were going to output the results of it to a file, but we had to wait for the command to finish, we would just put an ampersand at the end of this command, and then it would run, it would do whatever it needs to do. It's going to create our output file for us, and then we can continue to run whatever other commands that we wanted to run while that previous command was completing. This specific one right here, where you have a double ampersand, it combines multiple commands and then gives you one overall input. So you can do touch new file, so you create a new file, and echo onto the screen that there was a new file that was created, and echo the contents of the file into the new file that we just created right here, right? So technically you're running three commands. You're creating a file, then you're notifying that the file was created, and then you're adding whatever contents you want to that file. So this is very useful, especially if you actually know what you're doing and you want to get a lot done and not have to do multiple commands and then just press enter, wait for it, press enter, wait for it. Instead of doing that, you can just combine a series of commands, and then that way, with one pressing of the enter button, you run the whole thing. And then if you have notifications in between each one of the steps, you will get all of those notifications, and you'll know exactly where you are in the process, and then it'll be done real quick. So ampersand by itself, you put it at the end of a command, and then you run that command in the background. When you do this, when you double up the ampersand, you can combine a variety of different commands, and you can string together really as many commands as you want. If it gets to the point that you have to run a bunch of commands and you're trying to combine a bunch of commands, at that point you might as well create a script, which we're going to get into in a little bit. So so far, these are the key operators that we got. Once you've created files, or if you have a bunch of files that you're trying to view, there are a few different ways that you can do this. When you do cat, it concatenates, that's what it stands for. It concatenates the contents of that file, and it just prints everything onto the terminal. If it's a massive file, there's going to be a very large output, and sometimes the terminal limits the amount of lines that's output, and you may miss all of the contents at the very, very top of the file if it's a really large file. Typically, that happens usually with log files. So if you have a very large log file, then instead of doing cat and displaying everything on the terminal, you can either do less and more to view large files page by page. So you do less and then the name of the file name, and then you can click your the arrow buttons on your keyboard, and then you would go onto the next page and on the next page. Head and tail will display either the starting or ending 10 lines, and then you can also just display however many lines that you want. So if you do tail end 10, it'll display the last 10 lines of this file. If you do tail N5, it'll display the last 5 lines of this given file. So this is also very useful if you're trying to, if you know that a certain amount of data, like if you want all of the headers, for example, of the file, you would look at the top 10 lines. And then if you want the most recent data, which is typically what's going to be at the bottom of any given log file, you want the last 10 lines or the last 5 lines, whatever it is, so you can look at the most recent data instead of having to scroll back and forth to try to find it. And then there's find. So find itself is actually very, very useful if you know kind of what you're looking for, you just don't know where it is, right? So for example, it would be find, and then if you do the path, it could be just / that represents the root, which means that all of the folders inside of the root, you want to search basically in the entire machine. So you want to search inside of the root, which would be the path, or you could say, the documents, for example. So you can give the path to the documents and you say, look inside of the documents and look for let's say if I do -name, which means that I want you to find something by its name, and then you give it the name that you want it to look for. We're going to do a lot of this because this is actually very useful. And locate of the file is essentially the same thing, and it prints this location onto the screen. So locate keyword, and sometimes depending on where you're at, what type of machine that you're on, locate may not give you results, find may give you the results, or find won't give you the results, locate will give you the results. They essentially do the same thing. So that's kind of what it is. For find, usually you need to actually give it the path that you want it to search for. Locate just looks for it and then says this is where the path is. So you can locate and then find whatever the path is for whatever keyword that you're looking for. Find itself, you would need to give it a location for it to search, and then it'll go look for whatever the name is, or if you're looking for a file type or a permission, so on and so forth, it'll display all of those things for you. And then we have our common text editors. So Nano and Vim are the most common text editors that are available on Linux. Nano is very, very user-friendly. Vim is also user-friendly, in my opinion. It's just not as straightforward to deal with. So for example, if you do nano file.txt, it'll open up file.txt. If you don't have something called file.txt, it'll actually create file.txt. So it's very similar to using the touch command. But what happens is that you can now write inside of that file. So if I do nano file.txt, there's nothing inside of the file, I can start writing inside of the file. If there is something inside of the file and I do nano, I open it up and now I can interact with the content inside of that file. So I can look at everything, scroll back and forth. If it's a massive file, instead of doing cat and then printing it onto my display, I can just do nano and just open it and scroll through it as I wish. And then once I'm done, I can, if I want to save any changes that I've made, you do Control O. We're going to go through all of this stuff. So these are just overviews. You do Control O to save it, and then Control X to exit. Control K could be cut the line. Control W would be to locate something. So it would be where is something, and you can look for certain text. There's a lot of options that comes with it. Those are just some of the common ones. But Nano is a text editor, and Vim is the other one that, I mean, it says it has a steep learning curve, but in my opinion, it doesn't. It can be opened just to read something. It can be opened to insert something. It can be visual, and it can go in fairly deep options that it has. And there's a lot of help manuals for all of these things as well. So you're not going to be left to the wolves, as so to speak, just to kind of go through this stuff. And I would be to enter insert mode, so it would be Vim and then I to go into insert mode. Once you're inside of Vim and you're done with everything, you can do :W to write or to save, :Q to quit, :WQ to save and quit, etc. And then you can search for any given pattern to delete a line. You would do DD. These are just common options. This is not anything that you're supposed to memorize right now, because again, we're just going to go through the interactions. But these are the text editors that you should be aware of, so that once we go into it, we don't have to just do an overview of, hey, this is a text editor and this is what it does, so on and so forth. When we go to the practical section, we're just going to start using these tools, and it'll just kind of reinforce all of the data that we're covering right now. All right, now we're going to go into another level of dealing with files and manipulating them and searching through them. So grep is another one of these tools that you're going to use very, very frequently because it's very powerful and it searches for stuff. So it stands for Global Regular Expression Print. So you don't have to know that. You just know that grep searches for things. You can search for text within files. So typically it's like you're searching for any given pattern or a word, or you can even do actual regular expressions. And then you give it the location that you want it to search within. So if you want it to be case insensitive, you would do -I so that it can just look for whatever without having to worry about capital letters or lowercase letters. If you do R, it'll be a recursive search inside of a directory. So if you do, if instead of having a file right here, if you give it to something to search for inside of a directory, it can actually do that, and it can search for whatever that is. V would be to invert the match. So it shows lines that don't match the pattern. So if you want to show something, let's say that there's a lot of noise and it all has to do with a certain event ID. So if you want to show everything other than that event ID, you would do V, and it would show everything that doesn't match that event ID. So it will show everything other than that event ID. So grep is a very useful tool. And typically you can also do a combination of commands where you pipe the output of another command into grep so that it'll search for you. So for example, you can do cat and then concatenate something and then use grep to search through the data of that file. Typically, that's kind of just a very, very simple example, but you can do that a lot. Sort will arrange the contents in a specific order. So you can actually combine grep with sort. So you can grep for something, and if you know there's going to be a lot of data, you can then sort that data to be output onto the screen into any given order. So for example, to sort alphabetically from A to Z, you just do sort by itself. If you want to reverse the order, so do Z to A, you could do sort -R and then the file name or the contents of grep, right? So you can just do grep, etc., and then sort -R, and it'll show everything Z to A. If you do sort by itself, it'll just do A to Z, or ascending order. We can call it ascending order, and then you can have descending order as well. You can also sort files numerically using the N flag. So that could be potentially, if you're sorting files specifically, that could be potentially what you can do. You can sort output numerically as well, and then you can reverse the order of that using the -R. So it's very flexible. There's a lot of different ways that you can do interact with it. You can then use cut to take certain pieces of data, so certain columns, let's say, from that given file. So you do grep, it searches for the data, and you want to take, instead of getting every line that comes out of that result, you want just the first column or the first two columns. So you would do that, and then you provide whatever the options are, and then you cut that data from the results for yourself. So there's something called SED, that is the stream editor. So data streams are just another way to look at text that is inside of a file. And sometimes when you're looking at certain types of text, it may not be plain text. It may be formatted in any type of display or format. So it may not necessarily just be plain text the way that you're seeing inside of the screen. It could be base64 formatting or encoding. That's probably the better word. So it could be encoded in some way, and you want to just display certain things that you know that might necessarily match into something. So what you can do is you can edit it for the output, right? So set stream editor will take the first instance of old. So let's say it finds something that is called old, for example, and then it'll replace it with new. So the first one is the actual data that it's found, and then the next one is what it's going to be replaced with. And then it's going to do that for every line that it actually finds this specific pattern in. So if it finds old inside of whatever line it finds, it'll replace it with new for that line. If you want to edit it, if you want to actually transform that inside of whatever the file is, you can actually do that using the if flag. So it'll still find the thing that you want it to find, but it'll do an in-place editing. It'll actually edit the contents of it within the file for you. You may not necessarily want to do that. Maybe you just want to search for it and display the results. So that one should be used cautiously. But this is what the stream editor does for us. if we want to extract data. So these are things that actually have fields. So typically like a CSV file, for example, or something that has a field that has a value inside of it. This is the type of data that you would use awk for, AWK. And the usage is to take essentially the first column. So this is what this is right here. So it would print the first column right here of this file, which is what I mean when I say field-based, and usually CSV files are like that. CSV files are separated by commas, which turn into a spreadsheet, for example. So when you use something that has those types of fields, you can extract the data of that, and in this particular case, it's going to take the very first column and then print all of the data that's inside of that first column from file.txt. If you have a condition that you want it to print for you. So if the third column is greater than 50, for example, you want it to print everything from 1 to 3, right? So, or not from 1 to 3, it would be columns 1 and 3. So column 1, for example, would be the name of the field or the name of that specific line item. And then column 3 would be the value that's associated with that line item. So if the value inside of column 3 is greater than 50, I want you to print the name of that thing and then whatever the value is. And that's what that does for you. So you can actually give it conditional examples. And this is almost like writing a script. It is basically a script. It's like a conditional statement, right? So if the value of column 3 is greater than 50, I want you to print that data onto my screen. And this is the perfect segue to get into shell scripting. So setting up a simple shell script, we've kind of already talked about this, so I'm not going to spend too much time over here. So first and foremost, you want to create the script, so you can do touch script.sh. That would be a basic command to create your script. And then add a shebang line, which we've already talked about, at the very, very top. So the very first line of that script.sh file is going to be the shebang line, which is this piece right here. So we just call it shebang, right? So that's the shebang line. And you have to put that at the top of every single script in order for the script to actually run as a script. Otherwise, it's just going to be a file with a bunch of lines of supposed code, but there is no interpreter. This is what the interpreter would be. There is no interpreter, so that it won't be executed as a script. Now, once you have that file and you have your code and everything in it, you need to make it executable. And that's done through the changing of the permissions. So chmod, which we're going to visit later when we get into permissions, stands for change mode. And then when you do plus anything, you're adding that permission to it. So in this case, we're adding X, which is the executable permission, and we're adding it to script.sh. So change mode, add executable permission to the script, and that's the general outline of how that permission change does. Now, if you want to remove executable permission, you would do -X, and then it removes executable permission from whatever that file is. And that's basically how permission adding and removal works. So fairly simple. Now, once you have it, so let's say you want to create a bunch of variables inside of your script. The first variable in this particular case would be the name equals Linux GPT. And then when you want to refer to this variable, so that would be the variable name, it equals, so this is called an assigning operator. We're assigning this value to it. If you use two equal signs, it's a comparative operator, and we'll talk about that in a little bit. But typically, every single time, when you use a singular equal sign, you're assigning a value of something to this specific variable. So in this case, we're assigning this string, Linux GPT, is now assigned to this variable, which is name. Then you refer to this variable with $name. So if I ever use echo $name, it'll print Linux GPT onto the screen or inside of whatever it needs to do, because we have now assigned this string to this value. Very simple. You can also substitute the variable by assigning an actual command to it. Now, in order to do that, you would need to do $, and then put the command inside of parentheses. But the way that this works is that if I just typed date onto my terminal, it'll give me the date and time that we're in right now. but I want to store that value of this command inside of this variable. So I can do date equals, and then I do a $sign and put that command inside of the parentheses, and now I've assigned the value of this command to this specific variable. You could do name equals uname, for example, and it'll give us all of the data that is assigned to that machine, and it stores all of that data inside of this variable that we have over here. So you can assign text or strings to the variable, or you can assign the contents of another command to the variable. It's called assigning variables. Both of them are technically an assignment because you're using a singular equal sign, and then you're just choosing the type of value that you want to assign to that variable. Once you have your variable, you can then create your conditional statement if you want to use a conditional statement. So a conditional statement it's very basic, right? So if something, do something, else don't do something or do something else. And then you have to add fee at the end. Well, I consider it to be finish, just like short for finish, but I think it's just a backward version of if, and that's how the scripting in shell works in shell, the shell language. I don't know if it's a language, actually. I think it's a language, but whatever. When we're looking at this specific, the conditional statement right here, we can see that if, and then inside of our brackets, we have our first condition. So we say if the variable, whatever that variable is, equals value. So now look, we're looking at a double equal sign. So now it's comparative, right? Before, when you use the single equal sign, you were assigning the value, but now you're comparing. So you're saying if the value of this variable equals to the value that we're looking for, and then you do a semicolon, you say then I want you to print onto the screen the condition has been met. Notice that there's an indentation here. Typically there's at least either 2 spaces or 4 spaces. For user friendliness or reader friendliness, I recommend you always use 4 spaces. So if the variable equals the value that we're looking for, then I want you to print onto the screen that the condition has been met. If it hasn't been met, that's what else means. Else, just print that the condition has not been met. That's it, and then finish. And that's the full basic structure. If any of these things are missing, so for example, if the semicolon is missing, this is not going to work. This entire conditional statement is not going to work. If this fee at the end, the fi at the end is missing, this is not going to work. And usually you'll get some kind of a notification that there's an error on line such and such and something is missing or the syntax is wrong, so on and so forth. So you'll be able to debug your code accordingly. But it's very important that you understand that everything in this piece in this block of code has to be here. If this if this quotation mark at the end is missing, you're going to get an error. If this specific equal sign is missing, then it's going to say, well, this is also a logic error because you're trying to assign a variable to this value when it already has been assigned something else, and now you're trying to reassign it. Like, that doesn't make sense. So every piece of this needs to actually work here. If this $sign is missing, it's not going to work. So a lot of these things you got to be very specific with. Scripting is very specific. Once all the details are there, it's going to work like a charm. But if the details are not there, you're going to have a lot of issues. So this is just a basic structure of a conditional statement. And these are some of the comparative operators, the comparison operators that we're looking at. So right here, we're looking at equals to the value. But right here, you could say, okay, if it's less than the value that we want or greater than the value that we want, or if it's less than or equal to, so LE would be less than or equal to or greater than or equal to the value that we want, or equal to the value that we want, or not equal to value that we want. All of these operators that you're looking at right here have to do with numbers, okay? So if you're going to use any of these things, you're using integers or you're using numbers as the value operation or the value comparison, excuse me. The ones down here have to do with strings. So a double equal sign is comparing the value of a string. So if you can see right here, we actually have a string as our value. So we're using a double equal sign. So if we say, if this equals da da da, I want you to do da da da. In this case, double equal equals equal. A double equal means that you are looking for the actual comparison to be made. So if this does equal to this, if you do a exclamation equal, means that it does not equal to that. There's too many equals that I'm talking about. I'm losing myself in this explanation, but I think you get what I mean. So if you have two equal signs, that means it does equal to whatever the value is. If you have an exclamation equal sign, it means it does not equal to whatever the value is. And then this is where a lot of automation stuff comes in. So this is actually it's very basic what we're looking at on the screen right now, but this is the foundation of automating tasks. So for something in a list, I want you to do something, right? So in this case, it would say for item in 1, 2, 3, I want you to echo that item. So what it would do in this case is it would print 1, 2, and 3, 1, 2, 3. So per line, it would say this value, and this value, and it would print that onto our screen for us, right? So for item, and this could essentially be anything. So it could be for I in 1, 2, 3, do echo $I. So this name is another one of those variables that has been assigned in this particular loop. It doesn't necessarily have to be exactly this. In a lot of cases, it could just be a single letter, or it could be any word really. It could be for value in 1, 2, 3, echo value, right? So for the whatever this is, for this inside of this list, and this could be a variable that stores a massive list inside of it. In this particular case, we don't have a massive list stored, we just have a simple list. You would do your semicolon because you have to separate this piece, and then you say for this condition, I want you to do this action right here. And then when you're done, that's it, you're done. So this has to be here in order for this block of code to be complete. It's kind of similar to what we do in Python, except in Python we don't have done and we don't say do or something like that. We just say for whatever. I don't want to confuse you. But this is a for loop, and this can iterate over a list. The list could be a completely separate variable that houses a bunch of data, or it could be a variable that is reading from a separate file and then you're going through the contents of that file. There's a lot of stuff that you can do with for loops. This is a very, very simple for loop, but for loops are the essence of automation. And this is one of the most powerful things that you will learn when we actually get into scripting and creating some advanced scripting. This is one of the most powerful things that you're going to learn, is creating complex for loops. And inside of a for loop, you can have an if-else statement. Inside of a for loop, you can have another for loop, and there's a lot of different great things about it. And as long as you have your indentation correctly, then everything should run smoothly. So keep in mind that the indentation is very important in order for a for loop to work. You have the header, which is this piece right here, and then you have the body, which is this piece right here. And the same thing applies to our if-else statement. This is our header of the if statement. Then you have the body of the if statement. Then you have the else, which is another header. And then you have the body of the else portion. And then you have the finish at the very end. So the indentation is very important. Just keep that in mind, especially as we go into the writing of the scripting. You'll notice how those things work. And then so there's a for loop, and then there's a while loop. Now, a while loop runs as long as the condition itself is true. So while loop has a condition that it needs to be met. So for example, we have counter equals 1. That's our variable, okay? So the counter equals 1. Now, we're saying while the variable counter is less than or equal to 5, then I want you to echo counter. And then counter, in this particular case, inside of the while loop. So remember, there's this indentation. So inside of the while loop, now we have a new counter variable, but what we're doing now is we're assigning that previous variable plus 1. So for every time that this iterates, what it's going to do is it's going to print, the first time that it iterates, it's going to print 1 onto the screen. Then for the next line, it's going to iterate again, or actually, excuse me, it's going to print 1 onto the screen, and then it's going to add 1 to this variable, which would then equal 2, right? So then it's going to loop through this again, and it's going to say, oh, okay, it's still less than or equal to 5, So I'm going to echo that onto the screen, but now the value is 2. So then it's going to add 1 to that new value, which will make it 3. And then it's going to go, oh, okay, yes, it is still less than or equal to 5. And then it's going to print that onto the screen. And then it's going to keep going until it hits 5. So once this condition at the top right here is now saying, oh, it is equal to 5 now. So if it is equal to 5, then you're done, right? So that's it, because that at that point, the condition is no longer true. The condition becomes false, right? Because once that's done, once it's equal to 5, it's going to go over here and then it's going to add 1 to it. So it'll become 6. And then when it goes up here and it says, hey, is this equal to 5? It's like, no, it's not less than or equal to 5. Now it's 6. So I'm done. I'm not going to do this anymore. So this is a while loop. So it'll keep running as long as the condition itself is true. And in this case, our condition is if this variable is less than or equal to 5, then just print it onto the screen. Once you've done printing it, then I want you to add 1 to that value right here. And then on the second iteration, and then the third, and then the fourth, and then after that, it should be at 5. And that's it. That's when it's done. Because the fifth iteration, it'll actually turn into 6. And then it's done. It's no longer true. So the condition has been met, and the condition is now false, and it can't continue. So that's what while loops are, and that's how while loops work. All right, now that you know how the system works and how the file system works and how to create files, manipulate files, and do all of that stuff with the actual system, it is now time to move on to the users and the actual human beings that are going to be using the system. And this is where a lot of the roles, a lot of the responsibilities for being a system administrator actually comes in, right? Because you have to deal more than just dealing with the system itself, which is fairly simple to do, especially once you understand how to find the guides and the manuals and so on and so forth. Now you have to learn how to deal with the people and manage the users and the groups that they are in. So first and foremost, creating users. Depending on the distribution that you're on, it'll be one of these two commands. So it'll either be user add or add user, and it requires sudo permissions. So basically administrator permissions or maybe root permissions even. Just you run the command and then you have the username at the end of it. And that is basically it. That's literally how you add a new user. Now, this is very simplistic. Typically, there's going to be multiple options that you would run along with your user add command just to kind of handle certain things altogether. But you can also run them after the fact. So you can just do sudo username add or user add and then the actual name of the person. And then first you would set up a password for them, and I'll show you specifically what that is. And that also requires sudo permissions as well. Then you would need to assign a home directory to them. The default home directory, if you just do user add -m, if you just have the -m flag, and then you do username, what it'll do is that if the person's name is Alice, it'll add their home directory to home Alice, which is typical of where the home directories of all the users are based on what we've already learned about the file system. Now, if you want to declare a specific directory for that username, then what you would do is you would add -m and then you would do -d, and then you would have to declare where you want that username's home directory to be. And in this case, it'll be data users Alice, and that'll be the directory of their home. And then from there, this would be the username itself that we're going to add. So you're adding a user, and then you're declaring where you want their home directory to be by assigning these two flags as well as the path. And then this is the name of the user that's being added. You can specify the login shell for that user. So again, you're adding a new user, and then you do -s, and then you say that this is their login shell, which is the typical login shell location for the binaries. And then that would be the username itself that's being added. And then supplementary groups, and we're going to deal with group management in a little bit as well. And we're going to do all of these things, by the way, when we get to the practical portion. I feel like I just have to keep saying that because this is just more of an overview, and I know I'm glossing over a lot of these things, but it's mainly because of the fact that we're going to do a lot of the practical exercises. So sudo user add, and then you have a capital G right here. and the developers would be one group, and then admins would be another group, and then Alice gets added to those supplementary groups. So these are just some basic commands to add user details. Now, this is a full command that you're looking at over here, right? So we're going to do sudo user add, and then we're going to assign a directory for this person, which is going to be this place. This is their home directory. We're going to assign their shell, which is going to be at this specific location. We're going to add them to a supplementary group, which is going to be developers and admins. And then we're going to add a comment. So -c right here is just a basic comment for this particular user, who's going to be Alex Johnson, developer. And then the final piece right here is the actual username itself. So M creates the home directory, D sets the custom home directory, -s would be their ZSH at the login shell, -G developers and admins adds them to developers and admins, and then -c is just a comment at the very end just to say that this is who it is, and this is mostly for the system administrator that's going to be looking at this. And then finally Alice, the actual username of the person, and this one long command, but it does a lot of things when you're creating that user. And then if you wanted to add their password, right? So typically what you do is you assign a password once you create somebody, and then you have to immediately expire the password so that the next time that they log in, which would be the first time they officially log in, they get notification that your password has expired and you need to set up a new password. So you create the user, you set up a password by doing sudo pass wd and then the username, and then there's going to be certain prompts that are going to come in. So they're going to be like, yeah, what do you want their password to be, and then confirm the password, and then you do this specific piece right here to expire the password that you just assigned to that person. And then from there, the next time that they log in, they're going to be prompted to actually set up a new password themselves. So this is the very basic gist of creating a new user. Now, some of our basic commands for managing users. So if you want to modify an existing user, details with user mod, that's typically how it would work. So if you wanted to change their username, for example, you would do -L. This would be the new username, and then this is the old username that's being changed. If you wanted to lock an account or unlock an account, it would be with the capital L, and it would lock that account, and then capital U to unlock that account. And there's a variety of user modification commands that we'll be working with once we get to the practical section. And then there's also the user delete portion. And the -R right here would be a cleanup of everything. So you're deleting the user, and you're also removing their home directory and all of the contents of that user and their directory. So these are just basic user management, so to speak, commands that you're going to be implementing when we get to the practical section. And then we have creating and managing groups. Creating and managing groups is as simple as using the group add command and then just specifying the group name. You can also add a user to a group using the AG, so the A stands for append, and then G stands for the group itself, and then you can just add them to a single group or multiple group. So this would be outside of the user add version of adding somebody to a group. So when you do user mod, you would need to do the lowercase a, uppercase G to be able to add them to whatever the group is, and this would be a supplementary group that you're adding them to. And then of course you can just do group del to delete somebody, or to delete the group that you have specified. So the group name, that would be what you would be deleting in this particular case. Understanding the difference between primary and supplementary groups is very important. So a primary group is the main group that's associated for that user. When they create a file, and if they create any kind of file or folder, the group ownership permission of that file is set to whatever the user's primary group is. Now, by default, every time you create a user, there's going to be a new group that's created by their name. So if it's Alice as the user, there's going to be a new group named Alice that's going to be created inside of your groups directory. And that's going to be the primary group that's been assigned to that person. So when you want to change their primary group, you would use the user mod command, and then you do a lowercase g, and then the name of the group itself. So whatever, it could be one of your existing groups. It doesn't have to be a new group that you've created, but you're changing the primary group of that person by doing a lowercase g flag and then assigning the group name and then the username themselves. And then now you've changed their primary group. A supplementary group is additional groups that they have access to. So, based on who they are and what the permissions they have or what roles they have, they could have multiple groups that they're assigned to, so they can get access to the resources that are available to all of those individual groups. So that's mainly the big piece that you want. And multiple memberships can happen in a lot of cases. In a lot of cases, they do happen. So, for example, just a manager, for example, a manager will have access to the management group as well as the regular employee group, for example, so that they have access to all of the stuff that's inside the manager folder as well as everything that's inside of their own regular folder or along the other groups folder. So they could be a manager, they could be in marketing, and they could have their own regular folder as well. You know what I'm saying? So they have multiple groups that they're a part of. It's very useful for granting people access to different sets of files and directories owned by various groups. You just have to be careful that whenever they leave that department, so if they're no longer in marketing, they need to be removed from marketing unless they've gone up a level and they do still get access to the marketing group. But if they've left marketing in general completely and they went into tech, they shouldn't get access to the stuff that's inside of the marketing folder. And this is mainly because that you want to protect the company from potential, if the person leaves, for example, and there's a bunch of intellectual property that's inside the marketing file or marketing folder, and now they have access to all of the stuff inside of marketing and they can steal that IP, for example. That's just an example. So it could also protect the company from any security issues if that person gets hacked and they still had access to marketing, for example, and now the hacker knows that they're a part of that group and they go inside of the marketing folder and they see all of that IP, and then they can steal that data because a system administrator didn't remove them from that group and they should have never had access to that data to begin with. So this is very important to keep in mind. You can have multiple groups that somebody could be a member of. You just need to be careful as you go along and as the company grows and as people's roles change that you modify the groups that they're members of, because as long as they're a member of that group, they have access to everything that's inside of that group. You can add or remove somebody from a supplementary group by using the AG, so lowercase a, capital G, and appending them to the specific group or groups that you want them to be added to. So very similar to what we did previously by using usermod and then lowercase a, capital G, and then you start assigning the various groups that you want them to be added to. And speaking of permissions and ownership and all that stuff, access, we are now in that particular section. So file permissions overview. Permissions model is a very fundamental component, a very concept of managing access to files and directories. It makes sure that only authorized users can read, write, or execute files, or delete files, or modify files, so on and so forth, maintaining the system security and integrity. There are permission models that are involved in 3 levels of access. So there's the owner of the file or folder, or the asset, or the whatever it may be. There's the group permission level, and then there's others. So it's basically everybody other than these people. So it could be guests, for example. So there's the owner of the file or folder. There's the group that they're assigned to, which would be the primary group, as we've already discussed. Their primary group would be the group that it's assigned to, and then everybody else that falls inside of others. The owner is typically the user who created the file or the folder. They have the highest level of control over their files and directories, and they can set permissions to read, write, or execute the file or directory, even if they are not a root user specifically. So if example.txt is owned by the user Alice, she can control who else can access and modify that file. The group is associated with a specific group who are members of this group can be given certain permissions on the file or directory. So whatever the group permissions are. The group permissions determine what group members can do with that specific file or directory. Like the owner, group members can have read, write, or execute permissions, or whatever the permissions are that have been assigned to that specific group. So if example text is associated with the group developers, all the users and developers can be given permissions to read, write, or execute the file depending on the permissions available for that group specifically. Okay, so keep that in mind, because you can modify the permissions of the group and it may not necessarily be read, write, and execute all the files, right? And then you have others. So it could be all the users who are neither owner nor members of that specific group. So it could be everybody outside of developers group, or everybody who's not the actual owner, somebody that's a guest, for example. So there's a lot of different people that could fall under the category of others. So as long as they're not the owner or they're not inside of that primary group that's been associated with that file, then they all fall into the others category. The permissions for these people determine what any other user can do with the file. It can also be set to read, write, or execute, or it could be read, or it could be execute, or it could be none of the above, right? So they could have no permission to access it. Just depends on what the company infrastructure is like. So if example text has read permissions for others, any user on the system that can actually read the file, regardless of the user or group status. So a very common file that is limited to a bunch of people, or all the people that falls into others, would be the etc shadow file. The etc shadow file has the password hashes of all of the users that is inside of that environment. So even if somebody is not necessarily the root owner, even if somebody is not necessarily inside of the administrators group and they're in marketing, for example, that means they fall in the others category and they should not be able to read that file. So that's very important to understand. There are some files that even if people who are not guests and they're actually senior executives of the company or something, there is a number of people, a large number of people that should not have access to the etc shadow file because it has all of the password hashes for every user that exists on that system. So it's very important to keep that in mind. Now, the way that permissions are designed, they go by read, write, and execute, and they have acronyms for them. So R would be for read, W would be for write, and then X would be to execute. So read means you can view the contents of the file or the directory. Write means you can modify or delete the file or the directory. And execute, or X, means that you can actually run the program or the script or access that specific directory. So RWX. So keep these in mind, okay? This is typically what it looks like. And I would say that this is not typically what it looks like. This is just this particular example, but this is what it looks like when you look at the permissions of a given file or directory. The first character, which is represented by this dash right here, indicates the type of file that it is. So if it's a dash, it would be a regular file. If it's a D, that means it's a directory, okay? So this is representing the very first character, which is this dash right here. So in this case, we're looking at a file. If this was a D, then this would be a directory. Now the next three characters represent the owner's permissions. So in this case, R, W, and then we have a dash right here. And if it was X, that means it's also executable, right? So this would be RWX representing the owner's permission, read, write, execute. In this case, the owner can read and write. There is no execution, so it's probably not an executable file, right? It's just read, write, and then that's it. And these are all of the permissions for the actual user that created. The owner that created this particular file would be this, this, and this right here, okay? And then we have the next three characters that represent the group's permissions in this particular case. In this example, they're saying R to X, but in this case, it's just R dash dash. So the group can only read the contents of this particular file. They can't write to it, and there's no executable permission, so there's no execution that they can do on this particular file either. And then the last three represent the others permissions, which also in this case are read, and then no writing or modifying, and then no executing. So this is what it looks like. So the very, very first one is either it's a file or it's a directory, so a file or a folder. So if it's a regular hyphen, a dash, it means it's a file. If there was a D here, that would mean that this was a directory. The next three characters represent the owner's permission. The next three characters represent the group permission. And then the last three characters represent every single other person. And this is what the outline, what the frame, the template, I should say, the template of permissions are when you're viewing the permissions of a file. Now, let's say you want to change the permissions of any given file or folder. So we've already kind of touched on this. So in this particular case, we're going to do chmod, so change mode. And when you do +X, which is what we talked about in the very earlier example, +X adds executable permissions. But what you're doing in this case, you've specified that you want a U, which is the user. So you want the user to have executable permissions to that file, whatever the file name is, right? So chmod changes the mode, +X, which is a symbolic method of changing. We can also talk about numeric methods, which we're going to do right now. But so we're giving the user executable permissions to that file name, which allows execute permission for that user. Now, octal values would be a completely different thing. So 755, so 7 represents the maximum permission. So 7 is read, write, and execute for the user. 5 would be read and execute for the group, as well as read and execute for everybody else. So the value of these things breaks down. If you had all of the permissions, read, write, and execute, you would have all permissions for that individual group. So this is actually what the numeric value looks like. To have read permissions, you would be getting a value of 4. To have write permissions, you'd get a value of 2, and to have execute permissions, you would get a value of 1. So if there's read, write, and execute, the value would be 7. If you can only read, the value would be 4. So if there was 744, that means the user could do read, write, and execute. The group can only read, and everybody else can only read, right? If it's 0, then that means they have no permissions. Okay, so 740 means that the others group has no permission. The user that created it, the owner, has read, write, and execute, and then the group has just read permission, right? So this is the breakdown of what the values, actually the numeric values of these things look like. Read equals to 4, write equals to 2, and execute equals to 1. And then when you have the breakdown like this over here, then what that means is that the 3 numbers that are represented on the screen, so chmod 755, the 7 is representing the owner, the 7 represents the owner, the 5 represents the group, and then the 5 right here represents everybody else. So these 3 numbers represent the overall owner, group, and others categories. If it was 777, that means the owner, the group, and everybody else also has read, write, and execute permissions. So just keep that in mind. There's the numeric value of this, the numeric method of modifying permissions, and then there's the symbolic method of modifying permissions. Along with changing permissions, we can also talk about changing ownership. And you can have chown and then chgrp, which I'm sure you can imagine what these things mean. So chown stands for change ownership, and chgrp stands for change group. These are also pseudo commands. So change ownership of the user to this particular group, and then the file name as well. So you're changing the ownership of the user and the group for the file name. So this is the example right here. We have change group. So change group of the group name to the file name. That's what we're looking at. So in the particular case that we have seen in the first line, you're changing the ownership of the file name right here to this particular user and the group. In this case, we're changing the group for this file name to whatever the group name is. Okay, so just keep this in mind. So these is how you change the ownership of the file name, and it would be the user inside of this group, and then you change the group of this file name by assigning it to this actual group. So fairly simple. It's like fairly intuitive as far as the commands are concerned, but you can, and again, just keep this in mind. So once the file name has been assigned to this particular group, that means now all of the permissions that are inside of this group are now applied to this file name, and anybody who's inside of this group has all of those permissions on this particular file. This is what's very important to understand, okay? When you change the owner, then you're changing all of the permissions of this owner to this file name. So if they have the permission, and typically it's everything, they have all the permissions or whatever the main permissions are. So you change all of the permissions of that owner to this file name. If you're changing the group of this file name, everybody inside of this group has access to that file name, and they have the permissions for that group over this file name. So just keep this in mind. It's very important. And then we have special permissions. So SUID, SGID, and the sticky bit. So when the SUID, when the set user ID, when that permission is set, that file will execute with the privileges of the owner, not the user that's running it. So this is very important to understand. If the owner has administrator privileges and the set user ID, the SUID, has been set on that file, if the user, so the user is not the owner, right? So whoever the user is, when they run that file, if it's a script, for example, when they run that thing, they're running it with the permissions of whoever the owner was that was created it. It's very simple, and it's very powerful to understand, okay? you're setting the execution privileges of that file to be the execution privileges of the owner and not the user. The user could be lower privileged, the owner could be an admin, and if the user is running it, they're running it with the privileges of the admin, which is the owner. So if you want to change and add that specific permission to the file, you would do the change mode, chmod, and then you add on the user level the S permission right here, which is the SUID, and then you give the path to whatever the file or directory is. So this is very much for things that are executable that everybody else should be able to access, meaning a binary. So a binary, for example, the password binary inside of the user bin. So this is for the user binary, not the binary of the entire system. So just keep that in mind. So this is the user's binary for their password, allows regular users to change their passwords securely. That's what this specific binary allows them to do, because we already established that the password binary allows somebody to change somebody's password. So if the user wants to be able to change their own password, they should have the permission to be able to do that. So this is what this does, and this is the case that it would apply to. And you just got to keep in mind that this is a security issue. Okay, so if this is a system binary, and this is again something that we've done a lot in pen testing, we search for files by the permission that is set. So if they have SUID permission on that given binary or on that given folder, we're going to try to go ahead and access that folder and drop some kind of a exploit in there, a payload in there, so that we can run that payload by the permissions of the administrator, for example. And so if that directory has admin privileges and we have a shell that we want to execute and we want to switch ourselves to the admin privileges, we can then run everything that's inside that directory because it has the S permission set. And then now we're running it with the admin privilege, which means we can execute as an admin and then give ourselves access to that system as an administrator. So this is very important to understand, okay? That may have been a little bit confusing. That last piece may have been confusing, but what you need to really understand is that SUID will execute the privileges of the owner, not the user that's running it. So the user could have no permissions to do anything, but the SUID has been set on that file or folder, and now they can run it as that owner, right? Just keep that in mind. SGID is very similar, except it applies to the group. So it executes with the permissions of the file's group and not necessarily the person that's running it. So for directories, files that are created inside of that specific directory are going to run with the parent directories group. So whoever the group is that owns that particular directory, any file that's dropped inside of that directory will run with the permissions of that specific group. So if you want to change and add this specific feature for permission for any kind of a directory, this would be it. You would do G plus S, and that's it. And this is a chmod that is done with sudo, by the way. This is not something that typically would be done by everybody. So a lower level user should not be able to add the special permissions to these things. This should only be something that's allowed to be done by somebody who has administrator or root privileges, so that we know that it's the right person that's making these changes. So everybody should not be able to make the special permissions or modify the special permissions on files. It should only be reserved for root administrators and domain administrators, so on and so forth. And then there's something called the sticky bit. So when you set a sticky bit on a directory, only the file owner or directory owner can delete or modify the files within it, regardless of the group or other right permissions or anything else, right? So only the owner of that file or directory can delete or modify it. Nobody else can do it. This is called a sticky bit. And so you do chmod plus T, you're adding the sticky bit, so just T, you're adding that to whatever the path of the directory or file is. This is commonly used in shared directories like the temp folder. So the file owner or the directory owner can delete or modify the files within the temp folder, regardless of the group or other right permissions that may be assigned to that temp folder, right? So only the owner of the temp folder or the owner of the temp directory can delete or modify the files within that directory. Doesn't matter who else is trying to do it. Doesn't matter what other group or write permissions exist. Only the owner can delete or modify the files within that directory. So this is something else to keep in mind, because this is also a security issue. So if there's a sticky bit that's been assigned to something, it's also something to keep in mind. And it's typically something that you do to make more secure, like make the environment a little bit more secure. So this is opposite of the special permissions, where it technically makes it less secure. If something has the special permission attached to it, any user can run it with the owner's permissions or with the owner's privileges, whereas the sticky bit only allows the owner of that file or directory to be able to modify, meaning change or write to any of those files or delete any of the files inside of that directory. Which brings us finally to our user authentication and pseudo permissions portion. So user authentication, we've already touched on this particular file already. So the etc password file stores all of the user names. So the user accounts themselves. There is no password hashes or any plain text or anything like that that's inside of this file. The name is kind of misleading, and I think it's been designed to be misleading. Each line in this file corresponds to a single user account and contains several fields separated by colons, and those fields all stand for something. So all of the users, the user names, are stored inside of the etc password file. Now this is an example of a specific entry. So you have Alice, then there's a colon, and there's an X, and this is typically where the password hash would be. And then you have colon, and then an ID, and another ID, and then the name right here, separated by a few commas, and then another colon, and then we have their home folder, and then we have another colon, and then we have their bash path. So the username Alice would be the user's login name. So this is what their login name is. The password placeholder, which in this, once we actually go into the shadow file, and you'll see this is a very large hash value that's right here. The user ID would be this piece right here. So unique numerical identifier for whatever their user ID is. The group ID would be the primary group ID that's associated for them, which is in this case their actual personal group that was created when the user was created. Geckos, this is the optional user information, like their full name, office number, etc. So this is the comment, for example. This is where the comment piece would fall, which is everything that's inside of this specific, separated by these two I'm having a brain fart. The colons. The inside of these two colons, this is called the geckos, which is the comments essentially. So user information, full name, office number, etc. And then we have their home directory, which is the path to the user's home directory. And then we have their shell, the default shell that's been assigned for this user. And this is what a typical entry inside of the etc password file looks like. Then there's the etc shadow file. So the etc shadow file has everything else that we just talked about, except now it actually has the password hashes. So the encrypted password information and other details related to the password management of that person. This is more secure than etc password. So a lot of people can actually access the etc password file because it doesn't have the password hash in it. The etc shadow file cannot be accessed by anybody other than somebody who's the root user or on the sudoers list. So it's very important. In this particular case, it's saying it's readable only by the root user, which means that only the root user can access the etc shadow file because it has the encrypted password hashes of all of the users. Now, what we can see here is the same thing. So we have Alice, there's the colon, and then you see all of this data right here, and all of this, and you see there's this ellipsis that's right here, because this specific hash value was actually massive. It took multiple lines. I think it took 2 lines. So it was a very, very large hash value, but we can see that it's been separated by these 2 colons right here. So everything inside of this, including the $sign and the 6 and the rounds, and then including this // at the very, very end, all of this was the hash value of Alice's password. And then there's 18661, and then there's 0999997, and then the last 3 colons at the end. So we have the username, which is Alice, the password hash, which we already talked about, This field contains the hash, including details about the hashing algorithm and any salt that's been used. And typically the very beginning portion right here, the $6 and $, this typically is the hashing algorithm, and based on just what the breakdown is of it could be SHA-256 or whatever it is, that's typically what is determined at the very beginning right here. And then the last password change, so this is what 18661 looks like, was the date of the last password change represented as the number of days since January 1st of 1970. So 18,661 days, 18,661 days since January 1st of 1970 that this particular password was changed. That's been how many days it's been changed. So you have to actually count forward from January 1st, 1970 and come 18,661 days forward until you understand what date it was that the password was changed. And then the minimum password age in this case is 0, meaning the number of days required between password changes. So this particular case, there is no minimum age that's required of this. So it can essentially last as long as possible. And you can change this, and this would be the number of days. So if it's 30, after 30 days, it would have to be changed. My bad, excuse me. So yeah, the minimum password age, meaning that they are not required to change their password. They can, or they're not required to wait any number of days to change their password. So they could change their password immediately. That's what the minimum password age means. They can change their password every day if they wanted to. The 99,999, this thing right here, means that they have 99,999 days until they are required to change their password next time. So this would most likely need to be set to, let's say, 90, so that you can have the user change their password every 3 months for security purposes. So this is a very important field as well. So the 0 is kind of understandable. So you don't want, they can change their password any day that they want. They can change their password daily if they wanted to. But this piece right here is a security issue. So 99,000 days, almost 100,000 days. They're given almost 100,000 days before they're required by the system to change their password again. And that's very, very important to understand. As a security issue, you want to change that to make it 90 days, for example, or 120 days or something like that, so that there is a definitive limit on how long they can go with the same password, and it would be required to change their password. And then there's the password warning period. So we already talked about the 99,999. The password warning period, which is represented by the 7 this time, is the number of days before a password expires that the user is warned to change it. Now, in this particular case, it would be 99992. So it's still too long, right? So they need to have, let's say, still 90 days, and then on day 83, they would be notified that, hey, in 7 days, you need to change your password. The password inactivity period in this particular case is represented by this colon that's separated by these 2 other colons. The number of days after a password expires during which the account is still usable. And in this case, there is none. So if the password has expired, that means they have to change their password in order for them to use their account again. And then they have another one, colon right here, the date when the account, so actually I was incorrect. So the very next colon is what we're talking about for the inactivity period. The second colon is the date when the account will be disabled, represented as the number of days since January 1970, which has not been assigned here either. And the final colon is reserved for future uses. So these last 3 colons, especially this particular one, so the password inactivity would be the number of days after a password expires during the account still usable, which in this case is none. So as soon as it expires, they have to change their password. The account expiration date, there is none, because as long as they're in the system, as long as they're an employee, as long as it's your computer and you haven't deleted your username, for example, that's not going to change. And then you have the reserve field that's been reserved for future uses for a variety of other reasons. And so that is the full explanation of a line inside of the etc shadow file. So as we've already discussed, the etc password file, it can be world readable, meaning that everybody essentially can read it, but the password placeholder should be X, meaning that it would be less sensitive. So that is potentially something that you can do if you wanted to do it like that. I still think that the password file should not be world readable, because lower privileged users should not get access to all of the usernames inside of that system, because we have gone through a variety of pen testing exercises that we found a variety of different users, and then we did brute force exercises to be able to find the passwords for a variety of different users, and then kind of did lateral movements, and then eventually had vertical movements until we got higher privileges. So this should, in my opinion, should not be world readable, but it can be world readable, so that as long as the password hash has been replaced by this X, then technically it should be fine. The etc shadow file, however, should only be readable by the root user because of the fact that it has the encrypted password hashes. And that is a very, very strict file that only the root user or root users, just in case you're working in a company and one person is out sick, or you want to have redundancy, you have just a handful of people who work in IT who are the highest level of management that have root user permissions that can go ahead and access the data that is inside of this thing. And the thing is, you don't need to give everybody root permission, because not everybody needs to see these password hashes anyways, because you can just reset somebody's password very easily without having access to their password hashes. So that's the piece where it's like, okay, it is understandable that they say that only the singular root user is the person that has access to the etc shadow file, because somebody could just be an IT administrator, be on the sudoers list, and they have permission to reset somebody's password if they've been locked out or expired, so on and so forth. So these are the major security considerations to think about when you're looking at these two specific files in particular. So managing sudo permissions, granting the ability to users to execute commands with root privileges via sudo is a critical aspect of system administration, because you want to have redundancies with your administrators. You don't want everything to rely on one person. This involves adding people to the sudo group, configuring the sudoers file, and applying command restrictions for fine-tuned access control. So when somebody's in the sudoers file, essentially they can run sudo command, and they can do really basically what any root user would be able to do. They may not be the root user, but they could be in the sudoers group, which means that they have those administrator privileges, those higher level privileges. And the sudoers file is really the highest level of privilege that somebody can get, because they can modify and manipulate a lot of different things inside of the system. Adding users to the sudoers group is as simple as doing sudo usermod add to group, and then the group sudo, and then the username that you want to add to that group. So it's very, very simple to do, except this is a very, very powerful command. The command that you see in front of you is a very powerful command that somebody can run. And now whoever this person is right here, they have the key to the kingdom, so to speak. So basic sudo permission adding, you just use the usermod, add to the group, sudo, and then give the username. And this is just a breakdown of how that command works. So usermod ag sudo, and then the username. And you already know what all of this means and how these things break down. So that's how you add somebody to the sudo group, the sudoers group. And this is an example. So we're just adding Alice to the sudo group. So this one's kind of redundant, but now you've seen this in multiple regards, so you can see how you can add somebody to the sudo group, or really, again, any group, right? So if we just replace sudo with whatever the group name is, we're adding Alice to that group. So this is how we do the fine tuning. This is how we do the controlling of what people can do inside of the sudoers group. So the sudoers configuration file is located as the etc sudoers location, and it controls sudo permissions for users and groups, basically showing you what commands they can actually run with sudo if they are inside the sudoers group. So if you want to edit this, you would do it with vsudo, and you go sudo vsudo. And the explanation is that this is the safer way to edit the sudoers file, because it checks for syntax errors before you save it. So you don't want to do this with nano or vim, because vsudo actually checks for syntax errors, and then it'll open the sudoers file in the default editor that you have. It just does it while checking for syntax errors. And once you're inside of the sudoers file, you can basically designate or define specific commands that people can run with sudo when they're inside of the sudo group. So for example, giving somebody full sudo access would be assigning their username. So this would be Alice, for example, and she has all. So she has all of the permissions. The breakdown is whoever the name of the user is, the first all allows sudo access from any terminal. So all of the terminals would be this one. So on all terminals, she has access. And then all inside of the parentheses right here allows her to run commands as any user and as any group. And then the last one is allowing her to run any command. So she can do it from any terminal as any user in any group, and she can run all of the commands. So she's getting granted full sudo access. If you want to grant sudo access without a password, which is another one of those things that like now you're just giving this person literally everything in the kingdom, you just add that no password parameter or that no password argument inside of this piece, and now she has access to everything. So on all terminals, as all users, no password required, she can run all of the commands, and now she has access to the entire kingdom. If you want to restrict access to a specific command, which is most likely what you're going to end up doing, this is what it looks like. So you have the username. She can run on all of the terminals as whatever user, no password required, but she can run system control. The user, this is the full path of the system control binary, and the system and the reboot binary. So this is how you, and then it's separated by a comma and a space, right? So you have the path of whatever the command is, meaning the binary path to whatever the command is. So whoever the username is can run the system control and reboot commands with sudo without a password. This is what we're seeing over here. So this is how you specify what commands they can run by assigning the actual binary path inside of the user directory inside of our root directory. So root, user binaries, and then system control. And this is what this specific user can run without a password requirement. And just to make it legit for Alice, this is our example of giving Alice that permission. So Alice can run on all terminals as whatever user, no password required, the user bin systemctl binary. And that's pretty much it. That's how you specify what Alice can run on a computer. So just to give you a couple of practical examples here. So we got adding a user to the sudo group. So we got sudo usermod add to group the sudo add to the sudo group, the user Bob. We have sudo vsudo that edits the sudoers file, so it opens it with vsudo so that you can actually get all of your syntax checked automatically by the system to make sure your syntax is correct. And then we have the managing of the sudo permissions and our summary here. So granting and configuring sudo access involves adding people to the sudo group, editing the sudoers file with vsudo, and defining the command restrictions for fine-tuned access control. You don't want to do all. You don't want to give them everything, right? So you get them access to the sudo group, get the sudoers file open with vsudo so that you have your syntax correct, and then you just want to give the specific path to the binary that they should have access to, which means the commands that they can run. And this ensures that the user has necessary permissions to perform administrative tasks while maintaining security, which is very, very important in this regard. So security is a big deal, and we're going to go into security as its individual chapter and everything, but we are now bringing all of these concepts into play. So you've talked about file permissions so far, and we've talked about groups that they can add to and inheriting the permissions of these various groups. And now we're talking about the ultimate group, which is the sudo group, and inheriting the permissions of that group. But now you want to limit the individual command that these people can run as sudo. And that's how we assign that, was going into the sudoers file with etc sudoers and then opening up the sudoers file with vsudo to make sure that we can actually get our syntax correct as we're doing these things. And then from there we say, okay, these are all the different commands that you can run. So that's how you do that. And as a last example over here, we got the full series of commands here. So you have the user mod. So you sudo user mod, adding the person into the sudo group right here. and then you open up vsudo, and then you go and use various options. So for example, the no password option, or giving them all terminal access, so on and so forth, inside of the sudoers file. And then the username all equals all, no password, so on and so forth. This means that this person, whoever this guy is, this username person, can run this particular system control without any password requirement. And that's the only thing that they've been given sudo access to without a password. Or even if they had a password, this is the only thing that they have access to that they can run. They don't have all assigned to all of the commands that they can run, because that would be silly. That would be careless on our part as system administrators. So this is it. This is the very final cheat sheet kind of a thing that you get for permissions and sudo and so on and so forth. And we can now jump into the next piece right here, which is file management and file systems. All right, so let's get deep into the file management and file systems. So the file system hierarchy standards and the directory structure is what we're going to be talking about. As a review, these are the key directories that we have inside of our FHS, our file system hierarchy standard. The FHS defines the directory structure and contents in Linux, helping maintain consistency across a variety of distributions. So you will see this in pretty much every distribution of Linux. The main directory is the root directory. Then you have the binaries, then you have the etc, you have home, var, temp. We've talked about all of these things. So none of this is news to you unless you actually skipped that particular section of this training. But it was towards the very beginning where we went through the file system hierarchy. So these are our key directories. And since these are the key directories, and I mean, there's also a lot of a variety of other directories as well that kind of fall under the not necessarily primary directory. So if you go back to the section that we were talking about partitioning, it was in chapter 3. If you visit that, or if you kind of remind yourself of everything that we talked about, we have the primary partitions, and then we have the extended and the logical partitions. And this goes directly into the concept of mounting and unmounting file systems or partitions within file systems. So here's what that is going to look like. So we have the mounting of file systems. So when you mount something, you're attaching the file system to a directory so that it's accessible within the larger directory tree. And you would do this with the mount command. So you have any given file system, you attach that file system, and this could be the XFS file system, it could be FAT32 or a variety of other file systems. You're essentially mounting it, you're attaching it to any given directory, and then as you can see right here, we'll just talk about a few different ways that you can do that. But when you do this, you're making that file system accessible. You attach it to your directory hierarchy so that it can be accessible through the OS and for whatever the user is that's using it, so on and so forth. So in order to do that, you would use the mount command, and this is a sudo command. So you have the sudo pre-command, I guess we can call it, or the qualifier at the beginning of this. So sudo mount, and then you have the device name, which is going to be mounted onto the mount point. So you would find out what the device name is running dev. And again, we also talked about this as we were going through the installation part of chapter 3. And I showed you how to find the various devices that are currently mounted or plugged in, so to speak, the devices that are currently plugged in to your system. And then from there, you would get the path to that device. And it usually is something like, disk 4 or something like this. It's not a complicated thing. So it would just be /dev, and then there would just be the device name or the name that the system has given to it. And then from there, you would give it the mount point, which is the path that you want it to be attached to. So using an option like T would specify the type of the file system. So if it's the xt4, means that that's the type of file system that you're working with. And then this is what I mean right here. So you see how it says dev device name. In this case, it's saying SDB1. So it's the standard disk portion 1. of that. So this is the second one, that the second physical partition, the physical disk that's been attached to this particular system, because SDA would be the first one, SDB would be the second one, SDC would be the third one, so on and so forth. And then you have the first portion of that physical device, the first partition of that physical device that's being mounted onto the mount directory inside of our root directory. So that's typically what it would look like. And then you're just saying that I'm dealing with an XT4, or I want it to be mounted as an XT4, right? So there are various options, and we're going to go through all of this again. I have to constantly remind you, we're going to go through all of these as we go through the practical portion of the command. But this is what essentially it looks like. You use the mount command to mount any given file system or any given specific partition, primary partition and extended partition. You can mount that onto a mount point. You can also declare automatic mounting, and this is done inside of the etc fs tab configuration file that defines all of the file systems that should be automatically mounted when you start your system. So when you boot your system, there would be either one or two or a handful of file systems that you want to be mounted as the system starts, so you don't have to manually mount everything. This is considered a manual mount, what we're doing over here, and sometimes you want to do that, sometimes you want to unmount something as well. But automatic mounting is typically for the file systems and the partitions that you're going to be using regularly. So you're going to use an automatic mounting configuration that's inside of the FS tab file inside of the etc folder. The etc FS tab is essentially where all of that stuff is housed. So the disk partitions or any other file systems that you have that should be automatically mounted, all of those configurations are going to be inside the FS tab. And then each line in the FS tab represents a file system and the mount options that are attached to it. So this is what it would potentially look like inside an example or the typical FS tab file. So you have the file system first, and then you have the mount point. You would have the type of the file system, and then any options that you want to attach to it, the dump location and the pass location. So as an example, we have the file system right here. So just breaking this down, it could be the dev SD1, which refers to the first partition on the first SATA drive. So you have SD for the SATA drive, you have the A representing the first SATA drive, and then 1 representing the first partition of that SATA drive. So that would be the file system that would fill in right here. A more robust way to specify this using the universally unique identifier would be this piece right here. So you could do a UUID and then fill in the UUID instead of giving the path to the partition itself that you want to use. Obviously, that requires that you know the UUID, which you can also find running the previous commands that we ran to find our partitions that are attached to our system. You could have a label and the label variable equaling the value of whatever that label name would be, specifying whatever that file system is by its label. Typically, this is like, what do I have? I have like a SanDisk something. I don't know what the name of the drives are, but let's say you have an external drive and it's a SanDisk drive and it has the label name. The label name is very different from its UUID, obviously, and label from the partition location or the partition path that's been assigned inside of your system. This is actually what it looks like when you plug it in and then you see your list of connections and then it says, oh, this is this particular one. And then you can change the label name. So I always change them because number one, I don't like spaces in the names. I want the whole thing to just be one word. And then I turn it into an acronym that I understand. And then I also put the size of it. So primary 2 terabytes, for example, that would be like one of the labels that I would rename mine to, so that I know exactly which one I'm dealing with as I go through my my standard disks or my external hard drives, so to speak. And then we have the server share path as well. So this is a network file system. Like, for example, the SMB or CIFS file system. Those are network connections that are being accessed from a separate location, from a remote location. So it's sitting on a file server somewhere, and then you've connected to that file server, and now you have the path to that file server that's going to be inside of your file system variable. So all of these fall under this very first piece right here, which is referring to the file system. So since now we have the location that we're pulling the file system, we now need to give it the mount point, which is the location that it's going to be mounted upon. So the mount point is the directory where the file system is going to be mounted. So it could be the very root directory. It could be inside of the home directory. It could be inside of the mount data directory, which typically is the mount point for any additional data drives. The user directories, so all of the home directories for users, are going to be mounted on to the home directory. And this would be, for every user that you have, you typically would need to assign inside of the etcfs tab entry, inside of the etcfs tab directory, or configuration file, my bad. So inside of this configuration file, you would assign the actual home directory for the user inside of the home directory path that we have for the root. So this would be done one time inside the fs tab, and then as soon as the system is booted and it's up and live and running, it's going to be accessible and everything is going to be mounted. You don't want to be doing that every single time, especially if you have like literally dozens or hundreds or thousands of employees. And in a lot of environments, especially when it gets that big and you have that many people to deal with, it becomes something that is done with a script, because you would probably get a dozen employees per day or something, or per week or something like that. And that's just not something that you want to do manually, because it's so much faster to do it with a script, and then you can also avoid making any errors if you use a script. So root file system, the user home directories, the mount and data points for any additional data drives. So we have the location that it exists, we have the location that we want it to be mounted to, and now we need to give the type of the file system that we are dealing with. So ext4, xfs, nfs, vfat, which is one of the variations of the fat file system, so fat32, so on and so forth. So we had all of these. We have already talked about these various file system types, but you would need to know what type of file system it is that you're mounting, so that you can give it the type in this particular variable, and then the system will know how to interact with it. And for the most part, the most commonly used is going to be ext4, which is for Linux file systems in personal computers or in small environments. XFS is the high performance file system that usually is used for a file server and for a web server, for example, which would most likely be combined with some kind of a network path, because if you're accessing it remotely from a series of computers that are in a different city, for example, that is going to require the network path for the file system name right here, instead of the file system nickname or something like that. You actually need to give it the network connection path that you have over there. And the NFS would also be the type that would be used in that regard. So if it's internal and you're hardwired to it, then you would use XFS as the type. But if you're accessing it from the network connection, then it would be NFS for the network file system. And then VFAT is just one of the FAT file systems that's often used to USB drives or external hard drives that are being attached via a USB wire or even a FireWire or something like that. It's just something that's being externally attached. It's an external hard drive that's being connected to the machine. And then we have our options that we need to attach to this particular path. So it could be the mount options that control how the file system is actually mounted. It can be multiple options that are attached to this. And the default options, you can refer to them by just saying defaults. And those are the RW, SUID, dev, exec, auto, no user, and async. All of these happen all at the same time. I'm not going to break these down right now. You're more than welcome to Google them if you want to. But these are all mounted or assigned to this particular FS tab entry by just using the defaults entry or the defaults option. There is no A time, which prevents the file system from updating the access times. There is RO, which mounts the file system as a read-only. There's RW, which mounts the file system as a read-write, which is what's represented right here. And then a variety of other options that you're more than welcome to go check out. And I'll actually just show you what all of those options are real quick. Okay, so we have the defaults option, as we already mentioned, which will include all of these options right here, and the example entry would look like this. So this is the partition, it's being mounted onto the root, it's an ext4 type of a file system, and we're adding the defaults to it. And the defaults would add all of these individual options as one entry, which would be this piece right here. Then you have the RW by itself, which is this guy right here. And RW represents the read and write mode, so that anybody that gets access to it has read and write capabilities. You have RO, which represents read only. You have no exec, which prevents the execution of any binaries on the mounted file system. And that is actually not included on here because this is the exec, meaning that they can execute all of the binaries on that particular file system. No SUID disables the set user identification or set group identifier bits that we just talked about in our previous sections, making sure that you can, or the person who's running anything from this doesn't do it with the permissions of the owner or the creator of it. Then we have the no dev, which does not interpret character or block devices on the file system. And really what that means is that the users cannot create device nodes within that specific directory structure, which enhances the security by restricting access to that device's management functions on a mounted partition. So the users can't create devices on that specific file system. They can't attach external devices or create any virtual devices attached to that particular file system. So no dev. If you can recall what we were talking about with the actual dev partition or the dev portion of the file system and how it creates a file structure for a printer that may be added, or for the driver of the printer, for example, or a USB drive or something like that. So when you think about that's what dev does, then you can think about no dev, meaning that it doesn't allow them to do that on this particular file system that's been mounted. No A time does not update the access time on files when they are read. So this will improve performance potentially, but it's essentially the access time on files. So you open a file and then there's a little metadata that's updated that says, oh, this file was accessed last at this particular date and time. So this is the piece that you're going to remove from there. No dir a time does not update the access time on directories, so very similar to the last piece. Rel a time updates the access time only if the previous access time is older than the current modified time, which obviously it would have to be, which improves the performance while maintaining some of the a time functionality. So it will add an access time only if the previous access time is older than the current modified time, which again, it would seem like, how would somebody go and access something at a date that is newer than the old? Like what? That part is like, if the previous access time is older, meaning so the very last access time was June 1st and then I'm accessing it today on June 10th. So obviously the previous access time is going to be older. So that's the thing that I'm like, okay, whatever, that doesn't make sense, but okay. Then there's the user, which allows a normal user to mount the file system, meaning that somebody that is not an administrator or a pseudo user, they're allowed to mount the file system. And then no user, only the super user can mount the file system, meaning the super user being the root or the administrator or somebody that's on the pseudo list. And then you have auto, which is the mounting of the file system at boot automatically, which is one of those things that was actually included, I believe, in our big list at the top right here. Yep, we have the big list, and then you have no user. That's also one of the ones that's here. Dev, meaning that you can mount other file systems onto it or create device nodes onto it. There's the SUID, which means that people can actually access and run this with the permissions of the person who was the owner. And then async. So let's see if we can go and check that out specifically at the bottom right here. No auto, preventing it from being automatically loaded. We have sync, which is all input and output operations are done synchronously. And then you have async, which all input and output operations are done asynchronously. And let's find out what those things mean specifically. Okay, so actually this is very easy to understand. So all input output operations being done asynchronously means that when the computer performs the operation, for example, reading from a file or writing to a network, it doesn't have to wait for that operation to finish before continuing with the other tasks. Meaning, if it is synchronously, it has to wait for the previous task to finish so that it can move on to the other one. If you do asynchronously, it can run those things simultaneously. So the program can send the input-output request and continue executing other code while the input-output operation happens in the background, receiving a notification only when the operation is completed, which is actually very helpful. So that's probably why this is one of the defaults, which is it is async, right? Asynchronously. And then we have the ACL. So it enables the access control lists for the file system. And the access control list, whatever that is on your specific computer that's been, or on your system that's been configured, it'll just enable that access control list for this particular partition as well. So we have a few examples in this case, or at least one example in this case, where the example entry would be something like this, where you have the SATA A, so the very first disk, and then the first partition of the disk. It's being mounted on the mount storage extension. It is an XT4 file system. It has the defaults as well as no A time, and then we have 0 and 2, and so we can really quick find out what the 0 and 2 are as we go through the rest of our options, but it gives us right here, so no dump option. So the 0 represents the dump option, which is set to 0 for file systems that should not be dumped, which means they shouldn't be downloaded. You should not have the option to be able to dump everything from that file system onto your current machine. And then the pass option sets the order in which the file systems are checked at boot. So when you're running the boot, this particular file system is going to be done second in line. And that's what those dump and pass options stand for. And we literally just talked about it. So 0 would in this case represent do not dump, and then 1 would represent dump the file system. So that is something that would be those are the only two options that are available for the dump parameter in this particular case, which means that it's a backup type of a feature, right? So it indicates whether or not that file system should be dumped and backed up. If it has the 1, that means it is going to be dumped and it is going to be backed up. If it has a 0, it's not going to be dumped and it will not be backed up. When you look at a hash dump or a data dump or anything like that, that means it's being taken from where it's currently sitting and it's being dumped onto this particular mount point. Okay, so it's going to go from here and it's going to be dumped onto here at boot, right? Because this is something that we're configuring for our boot options when we start the system. And as it goes through all the various partitions and file systems that we have, it's going to check for this. And then if it should be dumped or should not be dumped, and if it is supposed to be dumped, it's going to go from this location and it's going to be dumped onto that location. And then of course pass, as we already just talked about it as well. So 0 would be do not check. So this is the order in which the file systems are checked at boot time by the FS check utility. So 0 would be don't check it. 1 would be check the system first, usually the root file system. And then 2 would be check the system after the first one has been checked. So you have 0, don't check it. 1, check it as the root, which is typically the root file system. So we're not going to mess with it unless it is the actual root file system. You're not going to turn that into 1. The only thing that should be checked primarily before anything else should be the root file system. And then you have the 2, which is basically check it after the other file system, meaning after the root file system, you can check this one, and then you can assign 2 to essentially all of the other file systems that have been mounted onto this particular machine, because they all come after the file system does. The root file system, they all come after the root file system does. Okay, so this is an example of our FS tab file. So we have these columns, so the file system itself, the mount point, the type of the file system, any options that would be attached to it, and then we have the dump, whether or not it should be dumped, and then the pass, whether or not it should be passed. And so you have the UUID in this particular case, and then you have this one external or this extra partition that's been attached because it's the SATA disk B, which would be secondary, and then the first partition on that drive. So you're looking at the UUIDs here. This particular file system is being mounted onto our root. So this is standard. This is going to be a standard entry on the FS tab because you have to mount the root every single time that you boot the computer. It is an ext4 type file system, and it's going to be mounted with the default options. And of course, it's going to be passed at 1, meaning it's going to be checked primarily before anything else is checked. And then you have the secondary file system, which is going to be everything inside of the home location, which would be all of our users. So ext4 again, all the defaults, no dump required, and it's going to be checked second in line after the root has been checked. And then you have this particular one, which is our swap space. So if you remember talking about our swap partition for our partitioning section, this is our swap partition, and it is a swap type, and it is a SW option because it represents swap. And then there is no dump required for it because it's going to be rebooted or wiped every single time that we reboot the system. And it's not going to be checked because for the most part at boot, this is empty, right? So if you reboot the system, the swap space gets emptied out. The swap file gets emptied out. So when you're booting the system, which is what this whole thing represents, right? So the etc/fs tab is the configurations that are run when the system is booted, and all of these things are being mounted on boot. So when you boot the system, the swap space is empty. So there's no requirement for us to check it, to run fs check on it. And then you have the dev SDB1, which is one of our external or secondary file systems that is being mounted onto this particular location, and it's going to be mounted on to our mount data partition. And the SDB1 is also an ext4 type of a file system. There is no access time that is assigned to this, so no defaults or anything like that. It's just a no access time that's been assigned to it, and then it has a dump of 0. We don't want to back it up, and then it's being checked after the root as well. So if you notice that all of these things are going to be checked, so if this was a longer list, essentially every other thing would also be checked, with the exception of the swap space because it's unnecessary to check it. And then the options would be the only thing that would change for it. And then you would have the order in which they're being checked, which apart from the root, all of them are going to have an option of 2 or 0, which would be the swap space itself. So this would be the example of the etc/fs tab file. And so this is the actual explanations of what I just gave you. So if you want this, you can just pause the screen real quick, take a screenshot of this, but it literally just explains everything that I just explained in this particular slide right here. So if you want to take a screenshot or pause it or take these notes, whatever it is, feel free to do so right now. 1, 2, 3, moving on. Okay, so unmounting the file system is something else that you would need to do. This typically is not going to be done with the fs check or the fs. Okay, so unmounting the file system would typically be done manually using the umount command. This typically is not in the fs tab configuration file, and it is just done manually using sudo umount and then the mount point itself, or sudo umount the device name. So either one of those things. So since we have the mount point, you could umount via the mount point itself, or you could umount by the device name that's been attached to it right there. So let's go back to this direction. Okay, so there we go. So that is the command that we're going to have to be able to unmount something. And it's a crucial step to prevent any data loss or corruption, especially for removable storage devices like USB drives and things like that. So this is actually in a GUI, in a graphic user interface, you would typically either right click on it and unmount it, or there's like an eject button that's next to it that you would click on the eject button and it would unmount it for you. But when you're inside of a command line interface, like a lot of Linux servers are, and they don't have a GUI, when you're inside of that environment, you would need to use the umount option so that you can unmount it and make sure that it's saving everything it needs to save. And then usually, if something is open inside of that partition, inside of that, for example, that USB drive, if there's a file that's being accessed from the USB drive and that file hasn't been saved, usually you're going to get some kind of a notification saying, hey, there's something from this USB is being used and you need to save and close it before you unmount this. And that's always a notice that you would get if you're running Windows or Mac OS or something that has a GUI. When you try to unmount it or disconnect it, instead of just, obviously, hopefully you're not just pulling it out of the USB location. I sometimes do that, but I only do it when I know for a fact that I have all of the files closed, or I've saved what I need to save, and I can just pull it out and just make sure that, I can be certain that nothing's going to happen to the file that I was dealing with. But if you haven't saved something, or if it's still in use, then you're going to get notification, and basically just save it and then close out whatever software is using it, and then you can unmount it without any problems. And just to kind of articulate the reasons to unmount, just to make sure that you're all good and you understand what we're doing. So there's something called a buffered write. So OSs often use a process called buffering to improve performance. Instead of writing the data to the disk immediately, they temporarily just store the data in your random access memory, which is volatile memory, which is temporary memory because it's going to get wiped when the system reboots. So when you unmount it, it takes all the buffered data and actually writes it to the disk. So it takes it out of the RAM, out of the random access memory, and it actually writes it to the disk. And then that way you can, when you unmount, you can be sure that everything that's currently buffering and just kind of hanging out in limbo, it's actually being written onto the disk so you don't lose any of your data. Then there's the flush cache. So when you unmount something, you flush the cache. And cache is kind of another one of those temporary storages that just houses some data, meaning anything that's pending, any kind of pending write operations are completed, and the data is accurately transferred to the storage device, and then it comes out of the cache and it actually goes into the device itself. It's written onto the device, and you don't have to worry about losing that data. Another reason would be the integrity of the file system. So when you unmount it, you cleanly close the file system, and you make sure that the data inside of it and the state of it is consistent and it hasn't been corrupted in any way, which is actually very useful. It's like a good habit to have, because most likely you're not going to ruin the integrity of the USB, especially in a lot of modern USBs. Most likely you're going to be fine. But if you do that repeatedly, there could be some something that happens where the corruption, in this particular case, corruption is like a very strong word, but the integrity of the USB may be messed up. The integrity of your file system may be messed up. It may not run as quickly. It may not save what it needs to save if you just keep doing it repeatedly without properly unmounting it. And then, of course, the corruption of the data. So if the network file is removed or disconnected, or if the USB drives typically are fine. I'm still going to tell you to unmount it and just make sure that you eject it properly. So that part is going to be fine. But a network file system, if you remove it or disconnect from that without properly unmounting, within that relay of data, because if it's network connected, that means there's definitely something hanging in the ether in that connection that you have with it. And if you don't unmount it, then the data will potentially be lost, because it's just going to be hanging in the ether, in the medium portion of that connection. It's not going to be on the actual server that you're pulling from, and it's not going to be on your actual machine. It's going to be somewhere in the middle. And if you don't unmount, then you're going to lose all of that data in transit. And then it makes the file unreadable, or the file system itself will become unusable. Most likely, it's not going to destroy the file system, but it is going to lose some data in that transit, and you just don't want to do that. Then you have preventing access conflicts. So files may get locked. So if you open a file and process might still be running, or something might still be interacting with that file system, unmounting it, make sure that all the file handles are closed and no processes are using it. So this is what I was referring to earlier when I said like something may still be using it, a software may be using it. So for example, when I'm editing a video, as an example, all of my video files are stored on an external drive because I don't want to take any space on my actual computer. And if I still have Premiere Pro open and it's still using any of those raw files or my project files, and I try to unmount, I'm going to get a notification saying I can't unmount this. Like my computer will say this can't be unmounted because of the fact that, or disk can't be ejected. That's another way that it says it, because of the fact that there's a program that's still using it in some capacity. So this is the portion right here where it's like it locks the file, right? It won't disconnect. I mean, I can still pull it out, right? I can still pull it out of the USB, but that process right there might lose my last save, my auto save, or it might affect some of my data or my video files or something like that. So in that regard, I'm like, oh, okay, let me just go save Premiere, let me close out Premiere, and in that way I can unmount easily or eject the disk easily. There are shared resources, and again, this is inside of the network connected file systems. Multiple users or systems may be accessing the same exact resources, and if you unmount them, it manages these resources and prevents the issues arising from unexpected disconnections, right? Make sure that everybody who is using it is notified, number one, that it's being unmounted and it was unmounted, or it just saves all of their work because it is a shared resource and you don't want them to lose their stuff because it's important stuff. Everybody's working on something that's relevant to the organization. So you just want to make sure the shared resources are protected. Again, I feel like network file systems, in my opinion, are much more volatile and much more sensitive than USBs, right? So USBs are typically very resilient. Network file systems are susceptible to loss of data because of the fact that it's being connected via an internet connection. So that's the piece that I think is kind of important to understand, especially in a network file system. You really want to make sure that you are unmounting that file system. All right, so some sample commands here. So sudo umount dev sdb1, sudo umount, and then the mount location itself. So this would be the device name. This would be the mount location. And this is the network file system. This is a USB drive, right? So umount, and then whatever the name of it is inside of the file system or the path of the network file system. And that's basically it. It's very, very simple. And so in summary, for this particular section, we want to flush all of our buffers. You want to maintain integrity. You want to prevent any conflicts, to close all the file handles and any processes. If you unmount correctly, you help safeguard the data and maintain the reliability of the file system. And you always want to unmount before physically disconnecting USB drive or network shares to just make sure all the integrity of the data is preserved and you don't have any conflicts. And now that we understand the mounting and unmounting and the importance of those two actions, we want to talk about the actual management of the disks and the various partitioning tools. So fdisk, the fixed disk, is one of the tools that you're going to use to create partitions and modify them or delete them. So this is a command line utility that's used to create, modify, or delete partitions. And so you run it with sudo, and then you run fdisk, and then go into whatever the individual disk is that you want to partition. So you would have to run sudo fdisk and the location of the actual physical drive and the physical file system or the physical disk that you're going to be opening for partition. And this could be done with a USB drive as well. So this above command right here, it opens this particular disk for partitioning, and then you can replace this with any device that you want to open for partitioning. A common command that you can run with it would be the print partitions command. So it would be just the fdisk and then P as the option, which prints the current partition table showing all the existing partitions on the disk. And we ran something very similar to this to find out what our partitions were earlier as we were installing Linux. So it would be P for partition list, right? Or print the partitions, excuse me. You have N to create a new partition. So creating the partition, you'll be prompted to specify whether you want a primary or extended partition and the partition starting and ending sectors. And then you have the usage for this, which is going to be N right here. So choose P for primary or E for extended, which would be combined with the N command. And then you can specify the partition number, starting sector, and ending sector or size. And all of that will go into when we actually run these things practically. I also think I have a couple of example commands as we go through this as well. So deleting a partition would be done with the D command. So deletes an existing partition. You'll be prompted to specify the partition number to delete, and then specify the partition number to delete using the D command. You can write changes. So once you've made the changes, you need to write them so you can enforce them. So anything that is made, all the changes to the disk that are made before you exit, you have to write the changes. Otherwise, they're not going to be saved. So you could be doing all the work, creating partitions, doing everything that you've done, unless you actually write everything that you just did, it's not going to save when you exit. So that's the big piece that you got to keep in mind. Whatever edits you're making, deleting, modifying, adding, anything that you're making, you need to use this W to make sure that it's being written so that it saves it. You can set a partition as a bootable by using the A command with fdisk, which means that the partition will activate for boot purposes, meaning on startup, when you start the partition or when you start the computer that you're running, that specific partition is going to be added to your list of bootable partitions, meaning it's going to go to the fs tab configuration file. So that's what it means when you make something bootable. So here's our example workflow with fdisk. So you open the disk using the fdisk, and then whatever the path is that you want to partition, you partition or you print the partitions for help. So P, enter, right? So because you've opened it and you're inside of the mode where you're now interacting with fdisk, you press P and then enter. You press N, enter. And then P for primary. After you pressed N, you are saying that you want to create a new partition. You would then enter either P or E. So P for primary or E for an extended partition, and then specify the partition number, starting sector, etc. And then you write the changes, meaning you press W, enter, and then you can exit fdisk safely because all of your work that you've done would be saved. LSBLK, so you should be familiar with ls because we already talked about ls inside of our introduction to the command line. BLK would be the block devices. So you're doing LSBLK to list the block devices. It's displaying the information about all of the available block devices, which are basically our partitions, right? The disks and the partitions in a tree-like format. And it's a clear overview of what you have on that system as far as the storage configuration, the device names, the types, the sizes, the mount locations, the mount points, and every other piece of data that would be relevant to knowing about what your disk structure looks like and what your partitions look like. The basic usage is literally just press LSBLK and you press enter, and you see a tree format of what everything is on your computer. And this is what the sample output looks like for list blocks devices. So you have the name, maj, min, RM, size, RO, type, and mount point. So in this particular case, we would have the first physical disk, and then it has 3 partitions, and then you have the second disk, and it has 1 partition. And then we can actually go and look at the various columns right here and what each one of them mean. But for the most part, you can try to understand what it is, right? So the very first line, the type is that it's an actual disk, and then 1, 2, and 3 are the partitions of that disk, and then you have another disk, and then you have a partition of that disk. You have the mount point locations for each one of them. This one right here is a swap space, as you can see right here. The size of them are going to all be listed here as well. But just to give you a good idea of what all of these columns stand for, we can go and look at our handy dandy AI assistant here. So we have the common fields for the LSBLK output. So the name would just be the device name, as we've already established. The maj and min is the major and minor device numbers, in this particular case 80 or 81. The RM is then indicating whether it's removable, and for the most part, if it does have it, that means it is a removable partition. So 0 would mean that it's non-removable, 1 means that it is removable. The size would be the size of the device, the RO indicating whether it's read only, so 0 would be it's read and write, 1 would be it's read only. The type, so disk, partition, or ROM, which is read only memory, or swap as we just saw. Mount point would just be the path that has been mounted on. The FS type would be the file system type. The UUID would be the universally unique identifier, and then the label that has been attached as if it's a backup or a data or so on and so forth. So these are the individual fields that we have right here, and then we actually didn't even have the label or anything like that. So what we do see in this particular example is the maj min right here. We have the removable, so these ones are not removable. This one, because it is an external, it is removable. You have the sizes of this, and then you have the read only, which means these are not read only. And then you have disk partition, the mount point would be swap, so on and so forth. So that's what we got. That's the output example and the breakdown of it. So in the example that we saw with the AI, there was the type, label, and UUID, and that would be done with the LSBLK-F so that it gives you the full, I believe that's what the F would stand for. So it gives you the full display of all the block devices along with all the information like the type, label, and UUID. And the output for that actually looks like this. So it removes a few of the other pieces that we saw. So the read-only or the swap location or the swap type, for example, those things we see that they've been removed from this particular location or from this particular output. But now we have in its place, we have the UUID, we have the label, and the mount point is also still there. The FS type is still there as well. And here's a quick little screenshot just in case you want this. So if you want to pause it to be able to write this down, or if you want to screenshot this, you have 1, 2, 3 seconds, and we are moving on. If you're looking for specific data to be printed onto the screen, you can actually use the -O flag or argument or option to be able to list what you want. This has to be all in caps lock, and then you do need to know the actual name itself of the column that you want to print onto the screen. So in this particular case, it would print the name of it, the size of it, the FS type, and the mount point location, and you can just customize your output in whatever way that you want. If you do the -D option, it'll display the information about the whole disk only, excluding the partitions of the disk, meaning that you have the disk right here. So this is the disk, and then these are the partitions of the disk. So these will be removed. If you use the -D option, you will only see the disks themselves. And so there's a quick little summary. So LSBLK provides the detailed tree view of the devices. With the F option, it'll include the file system information. It is customizable, so you can actually use the -O to be able to view whatever you want to actually view on the output. And yeah, that is the list block devices. MKFS, very similar to MKDir, is a making of a file system. So you can make file systems. It's used to format a partition with a specified file system type, and you can use it with the MKFS. So, and very similar to what it looks like in Python structures, you would use the dot to declare what type of file system you want to create. So you would do sudo mkfs dot xt4 and then on this particular disk. So you can see that this is obviously the file system type that you want to create, and this will be the partition, which is on the SDA disk on the first position, and it's being created as an xt4 file system. The XFS file system is a high performance file system known for robustness, So you can do sudo mkfs XFS, so sudo mkfs.xfs, and then you can now create an XFS file system. Same thing with the FAT32. In this particular case, you would actually need to say it's a VFAT type of a file system. I love saying that. The VFAT type of a file system, and then you do a -F and then say that it's a 32 extension of it. So these are the older ones that are typically used for USB drives and things like that, and they are widely supported, meaning that you can use them on Windows as well as Mac OS and so on and so forth. But they're typically limited to the amount of space that they can tolerate, which is 2 terabytes, as we discussed earlier in the training. So this is specifically for USB drives for the most part, or something that is maxed out at 2 terabytes. It is a little bit slower, it's a little bit older, so that part of it you should already know about. But if you want to create it, instead of saying FAT32 on the dot afterwards, you would say VFAT, and then you would go -F32, and then the rest of it stays the same. NTFS would be the new technology file system that is a Windows ingrained or intuitive to Windows. And this is for advanced features like journaling, support for large files, formatting, and partition. With this can be useful for compatibility with Windows. And you would say make fs.ntfs, and then give the location that you want it to do it. So this is our example workflow. So you want to first identify the partition. So you would use your list block devices or fdisk list to list whatever block devices you got. So for example, LSBLK would just be you type it out, you press enter, and it gives you the list. And then you choose the appropriate MKFS, the makefs command based on the desired file system type. So if you want to do xt4, you would say mkfs.xt4 at this particular partition. And so again, so keep this in mind, right? So what if you've identified the partition that you want using the LSBLK, now you want to create a file system on the partition that you've found or you've declared, right? From that file system, you're going to create, or from that partition, you're going to create the file system that's going to be mounted onto it. And after that's done, you can verify the file system type using the lsblk-f command and press enter, and then you'll verify what you got onto that file system. So in summary, the makefs, the mkfs, is used to format partitions with different file systems. You can use file system types like ext4, xfs, fat32, ntfs, etc. And then you just need to choose what you want based on the compatibility. There's something called the disk utility, and so just to compare it to something that would be on Mac OS, for example, there's something called the disk utility tool that will do this for you with a GUI type of an environment. So you connect the USB drive or an external drive, whatever it is, and then you say that you want to reformat. You go to the disk utility, you select the USB drive that has just been connected to your device, and then you go to format, and then you choose the formatting option that you want, and it would be ext4, xfs, whatever is available for that specific drive, and then you finalize it, right? So this is what this is doing. It's looking at whatever that connection is, whatever that USB drive or external drive or disk is. It's going to look at that, and then once you know exactly where it is, what it's mounted on as, what its name is, so on and so forth, you then use sudo makefs, and then you reformat it, right? You format that drive to be one of these types of file systems. And to completely be like very brutally honest and just declare, like really note you know what I mean, like disclose this for you, this is going to wipe the file system. In most environments, in most cases, it's going to wipe everything that's on that drive. So when you format a USB drive, it's going to clean it out. It's going to delete everything that's on there because it needs to reformat the thing. So you need to make sure that if there's anything on that disk that you want to be backed up, you got to back it up first before you do this command, because it is going to wipe the file system. It's going to wipe the current formatting of that USB drive or of that disk, and most likely you're going to lose whatever's on there. So just keep that in mind, right? If it's not empty, if it's not a brand new USB or external drive that you're trying to change, or if it's not a brand new disk that you've installed, if it's not one of those things and it's already empty, you need to back up whatever needs to be backed up before you run this, because it's going to wipe it. FSCK for file system check. So this is what actually is ran from that the fstab file when we declared what we wanted it to run on boot, and we were looking at the various partitions and disks that were going to be launched on boot. The very last option was, do you want to pass or not? And we were going to say, yeah, I do want you to pass, or I don't want you to pass, which means you're going to check and run fscheck on it. So it's the file system consistency check. That's basically what it stands for. And it detects and repairs any file system issues, and you should pretty much use it. So obviously, if it's on the fstab configuration file, it's going to give you the option of running it on boot. So it'll run the check of that whatever file system that's been mounted as soon as you boot up your computer. But if you haven't shut down the computer properly, or if it crashed or something, and you just want to make sure that nothing has been lost, when you reboot it, you will run fscheck to just make sure that the file system is still all good, to identify any kind of issues. If there are any issues, hopefully there aren't any issues, but sometimes there's an improper shutdown, you lose power, or the system crashes for whatever reason. So that's all good. If you manually reboot or shut down the system without properly unmounting your file system, that would be another reason to run fscheck on it, to just make sure that it's all good. Any kind of an error that happens, so if there's a boot failure, for example, and you start up your computer and for whatever reason it doesn't boot that specific file system, you run fscheck to try to diagnose what just happened and why it didn't mount, or why it didn't boot it. Same thing for mounting. So if you can't boot it, or if you can't mount it, then you run fscheck to see what is going on with that particular partition and resolve any kind of underlying issues, because you need to understand that you can connect it, right? So it can be connected to the computer, but it won't be mounted, and that is a very nuanced difference. So you can have it be physically connected, but it may not necessarily be mounted. And so if it's not mounted, you need to find out why it's not mounting. Then we have periodic maintenance, so just preventative checks, right? So to just make sure that it's all good and there's nothing wrong with it, you just run routine maintenance. If there's any kind of an update or a health issue or any kind of a minor issue, you can catch that before a major issue comes into play and before there's a crash or before you lose any data. And then there's schedule checks. So many systems are actually configured to run this automatically at boot, like we already talked about. After a certain number of reboots or mount operations, you can write scripts to do it for you every week or something, or every month, just to make sure your mount points and your file systems are all good. So it's better to do it regularly instead of waiting for some kind of a crash to happen or some kind of an error to come up, so that if there is something going on, you can catch it in advance and then you can fix it. So running it at boot is as simple as making sure that the pass option has been turned on with your fstab configuration file. Manual invocation would be to just run sudo fscheck on whatever that partition is or whatever that disk is. And it's as simple as just running sudo fscheck. It's really, this part is not that complicated to explain. You can also have unmounted partitions that you want to check before running to avoid any kind of potential data corruption. So you can unmount the partition first and then run fscheck on it to just make sure everything is all good. And that's another strategy that you can run to run fscheck. There's interactive mode that can actually prompt you to fix anything within the interactive mode, and you can use the flags to automate the process. So for example, -y will be automatically answering yes to all of the prompts that come up. So do you want to automatically repair something? You just do -y, and then it'll go ahead and run the entire autocorrect for you, or the automatic repair for you, without you constantly having to say yes, yes, yes. So it can be opened in interactive mode for the repair of any file system if it needs to be repaired, or any partition that needs to be repaired. And then if you just attach that -y, it'll do everything automatically. So as a summary, you have any proper shutdown or file system error or any periodic maintenance that may be required that to run fscheck on it. And it just makes sure that the file system remains consistent. If there's any data loss, you can be preventing it or catch it in advance. If there is maintenance that needs to be done, making sure that the system just runs smoothly all the time without risking the loss of any data. It's very, very important. As an extra reminder, just make sure that you back up the important data before running fscheck, because sometimes through the repair process, you may actually lose certain data, because if there's something with that file system that has been corrupted, or if there's malicious data or some kind of a malware or something that's been installed on it, you most likely are going to, in the process of wiping that malware, you're going to lose other data that may be important to you. So you want to make sure that you run backups or save the important files before you run fscheck, just in case it wipes certain things as an attempt to repair your file system. Which brings us to the configuration and management of the swap space. So we've kind of gone over this, so we'll just re-review this, because this actually was a little bit of a concept for me to wrap my head around as well. So it's virtual memory. So the swap is virtual memory on your hard drive that's used when physical processing power is maxed out, right? So your RAM is technically part of the processing power of your computer. So you'll hear people like computer nerds, you'll hear computer nerds be like, oh, I got a 64 gigabyte RAM on my computer. There was literally somebody that actually commented on the channel that they're like, yeah, I remember my first computer had 24 megabytes of RAM. And then now I have a 64 gigabyte of RAM. I'm like, holy crap, dude, 24 megabytes. Like, the system is old when you're measuring the RAM with megabytes instead of gigabytes. So you'll have these nerds that really, really compete over the size of their RAM. My RAM is bigger than yours, kind of a thing. And it's mainly because it helps run things much, much faster. And usually, in modern computers, if they have 64 gigabytes of RAM or 128 gigabytes of RAM, if they have that much RAM, you're most likely not going to worry about swap space. But if it's limited, so if you have 4 gigabytes of RAM, or if you have 8 gigabytes of RAM or something like that, the swap space is very important, because it's going to serve as virtual memory to save live processes so that you don't lose anything, especially when you put the system into hibernation or it goes into sleep or something and you want to turn it back on and pick up where you left off. All of that data is either inside of the RAM, the random access memory, or it's inside of the swap space. So the swap is a buffer to prevent out-of-memory errors, meaning that the system can't run because the physical memory has been maxed out. And so it'll take whatever is being, it's kind of over the threshold of the physical RAM. It'll hold on to that by offloading the inactive processes from the RAM. So if you have too many things open and you're actively using something, the RAM processing power is going to be dedicated to what you're actually using, and everything else that's in the background is going to go into your swap space. If you want to create a swap partition, you can create that swap partition using the fdisk command. So you can create a partition simply by just opening up whatever it is that you're trying to open up, and then you would create a swap type of a partition. So a disk partitioning tool, which is fdisk, you're going to use it on the specific location. So in this particular case, it's SDB, as you can notice. So it's SDB, which is going to be our external or our secondary disk, and it's going to be where the swap partition is going to be created. You can replace it with whatever identifier that you want to use, and then you actually go through the process as you interact with fdisk to create the partition, right? So you would open up fdisk on that location, press N to create a new partition, press P to create a primary partition, and the partition number, for example, would be 2. And then you accept all the default first sectors to accept the default last sector, and then you have to change the partition type. So this is the part right here where you change the partition type to swap. You press T for swap. I don't know why it's T. Maybe it's temporary. That's what it stands for, maybe. And then you press 82, which is the Linux swap number, and then that's it. And you press enter, and then after all of that is done, you press W and press enter to write all of the changes to the disk, and then exit fdisk to make sure all the work that you did is going to be saved. So that's how you create it, right? So kind of review that, because I'm not going to keep repeating myself. Sometimes I keep forgetting that I'm doing a recording, and then I beat something to death. That's like a bad phrase, beat a dead horse or something, whatever the phrase is. I just keep repeating myself because I want to make sure that you get it. But then I'm like, oh, you know what? They could technically just rewind this and go replay it over and over again. So my bad. I've gotten comments from people that are like, did you have to talk about that thing as long as you did? And I'm like, yeah, well, I just want to make sure that people get it. So I try to say it in different ways so that it connects. Excuse me for trying to help you learn. Jesus. God, I'm having a conversation by myself in my room as I'm recording. Just so you know. Okay, moving on. So now you need to format that partition as a swap space. So now that you have that specific disk that you did everything with fdisk, now you turn it into a swap space by using the mkswap, make swap command, and you format it as a partition. It's very similar. We already have this understanding, so we're going to move on. Then you turn it on, right? So you've used fdisk, you've created that partition, then you use make swap to turn it into a swap partition, and then you use swap on to actually turn it on as the swap partition. And very simple. I'm not going to keep repeating all of these things because the instructions are meant to be redundant. But here, I'll just leave this on in case you want to screenshot it. 1, 2, 3, moving on. And so verifying the swap space, you just go show. You use the -- show option with swap on to just make sure that it's actually been created as a swap space and it's actually turned on and it's running as smoothly as it is. So it'll be the active swap spaces that are viewed when you run the swap on command with the show option. So creating a swap file is similar to having a swap partition. So creating a swap file. To turn a swap file or to create a swap file, it would be done with the fallocate, and then you use the -L. So don't confuse this with a 1, right? So sudo fallocate -L, and then 1 GB is going to be allocated to wherever the swap file path is, right? So you have a swap file instead of a swap partition. The fallocate allocates this space for that file. The -L1G would be the limit, right? So you're doing a 1 GB limit for this particular file location, and then you have the swap file, which would be the path to whatever the swap file is. And then you do chmod 600. So you change the mode, the permission of it to that swap file to set the file permission to read and write only for whoever the owner is. And then that should allow it to actually read and write as necessary. And then you would turn it into a swap. So this part is pretty much exactly the same as what we did with the swap partition, which in this particular case, we're just making swap the actual swap file path. And then you would turn it on, right? So swap on for that swap file. And then, of course, once it's been turned on, you just want to make sure that it is active and it's running. So you would do swap on -- show. So sudo swap on -- show, and it'll show you whether or not that specific swap file has been activated. The last step with your swap partition or swap file would be to make sure that it actually loads every time you boot your computer, right? So you need to add it to your etc fstab file, as we've discussed so far. So you need to configure the actual etc fstab file. We can do it with our trusty nano text editor by just opening up the etc fstab with nano. Of course, you would need to do it with a sudo permission so you can actually write to it and save it. Then you would add whatever the swap partition is in that particular fstab according to the formatting that we've talked about so far. So you would provide the name and then the location and then the type of the partition, which would be swap, and then whether or not you want it to be dumped, which is no, you don't want it to be dumped, whether or not you want it to be passed in the FS check when you reboot, and you don't want it to do that either because it's going to be wiped every single time that the computer is rebooted anyways. That's the whole purpose of the swap partition. It's not going to store any memory or any kind of data on it because every time it gets rebooted, it just gets deleted. So that's the whole purpose about this. So you don't need to dump it and you don't need to check it with FS check when it gets started on, but you do need to provide the name, you need to provide the path, and then you need to provide what type of partition it actually is, which is going to be swap, or what type of file system. So this is the piece for the file system, and so on and so forth. So this is how it looks. Notice how all of these things are exactly the same with the exception of whether or not it's a swap file or a swap partition. And even this looks very similar, right? You're just giving it the path to the partition, or you're giving it the path to the swap file. That's basically it. And this is the explanation of what we just looked at, right? So you can screenshot this, 1, 2, 3. So the first portion was the swap partition itself. It's not going to be mounted onto anything because it is a swap partition. It is the swap space and then SW for the swap. And those are the options that you got. And then so once you have written everything into the fstab file inside of Nano, you're going to save the changes doing Control-O, press Enter, and then Control-X to exit out, and then you can move on. In summary, creating and configuring swap space, whether as a partition or a file, is essential for maintaining system performance. By following these steps, you can ensure that your system has adequate swap space available, and it's probably a good idea to actually have this whether or not you have a massive amount of RAM installed on the computer. The Mac OS, whether it gets 16 gigabytes, 32 gigabytes, whatever the actual RAM is, or Windows, whether it has all of that massive amounts of RAM, it still has swap space. So it's probably a good idea if you're going to be a Linux administrator and you're going to use the type of interface that doesn't have a GUI or it doesn't come pre-configured with these types of things. It's probably a good idea for you to make sure that there is swap space that's been configured. And if it hasn't been configured, you go ahead and configure it the way that we just talked about. And of course, we're going to review all of this stuff when we go into the practical section. And this is your little cheat sheet. So if you want to create a swap partition, you can create it using fsdisk or fdisk, excuse me. You can create fdisk, and then you have the creating of the partition. Then you format it to become a swap space, and then you turn it on using swap on. And then same thing, fallocate L 1 gigabyte to the swap file, sudo chmod the swap file, and then make it a swap file and then turn it on as a swap. So once you've created the swap space, now you got to manage the swap space. The swap space usage and ensuring that the configuration persists across all of your reboots and restarts of the computer is very important for system administration. These are the detailed steps that you got to do to check the usage. So checking swap usage, you would go swap on dash S, swap on dash S, and it displays the summary of the swap space usage, listing all of the active swap areas. And this is the example output that you have over here. So you would have the file name, swap file, and then you have the dev sdb2, which is the partition for the swap. And then these are the sizes that they have. And then for the swap file, 2000 kilobytes has been used, and it has a priority of -2. And then this has a priority of -1, and it hasn't been used at all, as you can see over here, because it doesn't need to, for whatever the situation is. This is 1 gigabyte worth of space, so it seems to be fine. This is just a breakdown of the fields that we just looked at. So the path to the swap file, the type of file that it is, or the type of partition that it is, the total size of it, the used amount of it, and then priority of the swap space. So lower numbers mean that it's a higher priority, and the higher numbers mean that it's a lower priority, which is, again, I guess it makes sense, right? So number 1 would be a higher priority than number 2. So that is the breakdown of these fields. Another way that you can check the usage would be using the free command. So free-h provides a human readable format of memory and swap usage, and this is what the output would look like. So you have the memory itself, and then you have the swap space or swap partition, swap file, whatever that allocation is when you've created your swap partitions or swap spaces. The total amount of memory, and then the total amount of swap, and then the used amount of memory and the used amount of swap, how much you have free, whether it's a shared portion or if it has any shared portions, and then the buff cache, as we talked about, the buffer and the cache, and then the available that's going on with it. So if you look at the stuff that is sitting inside of the shared portion of this memory, as well as the stuff that's sitting inside of the buffer and the cache, these are the things that we were talking about when you're talking about unmounting, to make sure that this 5 gigabytes of data isn't lost. So you want to make sure that you properly unmount, or you properly shut down whatever the system is or whatever the partition is, so that you don't lose this data. Because out of the 15 gigabytes, losing 5 gigabytes of data would be catastrophic, because it represents a large amount of data on this particular system. So free H shows you the free space, the free memory, as well as the free swap space that is available on your computer. And these are the breakdowns of the fields. So you have the total amount of memory, you have the used amount of memory, the free amount of memory, the shared memory usage by the temp FS, the shared memory that's available, the temp file system. You have the buff and the cache, the buffering and the cache, the memory that's used by the kernel buffers and page cache, and of course anything that's available after all of these things are considered, right? So after this is considered, after the shared and the buffering and cache is also considered, after all of that is considered, this is the final available amount of space that is available on that individual partition or disk. And this is how we look at the permanent swap configuration. So to make sure that it's available after a system is rebooted, you have to add it to the FS tab, right? So this file contains information about disk partitions, so on and so forth. So where are we at? I feel like I accidentally clicked something. So there we go. So to be able to edit the FS tab file, we're going to use sudo and nano, and then we're going to go inside of it and just make sure that the swap partition is designed as it is. So we've already talked about this. This is just part of the permanent swap configurations as we've discussed, and you should already know what all of these things stand for. So I'm not going to explain this again. You can do a 1, 2, 3 screenshot, or pause it, or take it down, so on and so forth, and then we're going to move on. So add the swap entry to it would be as a swap file, same exact concept. The breakdown is exactly the same. So again, I'm not going to say this. This is just redundancy so that you understand that these actions fall into different categories. And so managing swap space or creating swap partitions both have a permanent feature, and both of those features are inside of the FS tab configuration file that is inside of the etc FS tab location. And then you save and exit because you're inside of nano, so you just got to make sure that you save it. And even when you try to exit without saving, it'll prompt you to whether or not you want to save it, and you just press Y and press enter, and it'll save it and make sure that all of your changes have been saved to that document. Activating it is exactly the same way as doing what we did before. So sudo swap on and A would be the activating all of the swap entries inside of the FS tab. So you can do a sudo swap on and then give the path or the location or the identity of the swap space itself, or you can just do -A to just make sure all of your swap configurations have been activated inside the FS tab, and then you just do --show to show you what the status of everything is and whether or not they're actually active and correctly configured. So in summary, we're going to monitor and configure swap space to make sure that the system can handle anything that's memory intensive and remain stable under a heavy load, which typically, if it's a high traffic environment, if there are a lot of users, that would be necessary. So even if you have a massive amount of physical RAM, you do want to have a good amount of swap space as well, because you have a lot of data that's being processed by a lot of different users. And it's your little cheat sheet. So to check the swap space using swap on, you can do swap on -s. That will list all the active swap areas, and then you can do free-h. That'll do a human readable summary of the memory and the swap usage. And then if you want to make permanent edits, you would do it inside of the FS tab configuration for reboots all the time, so that it just loads every single time. And then you can make sure that you have swap on -A so that it activates all of the swap entries that are inside of the FS tab file. All right, real quick, let's go into process and service management. So you got to understand the difference between processes, daemons, and services, okay? A process is an instance of a program that's running in memory. Each process has its own PID, its own process ID, and there's a parent ID, which is a PPID, so parent process ID. Processes can be in a lot of various states, or I guess 3 various states. It could be running, sleeping, and zombie states. So it's a program, it's an instance of a program that's running in memory, and it has a PID and a parent ID, and it can run in various states, including running, sleeping, and zombie states. A daemon are background processes. They're running without an interactive user, so it's basically what's running behind the scenes in order for your machine to operate the way that it does. And it starts at boot and it continues to run while the computer is on, so that all of the operating system functions can actually run the way that they need to. So for example, a web server daemon, like the HTTPD, so the D stands for daemon, and anything that ends with the D, so you have the secure shell daemon, or you have the cron daemon, these are all considered the background processes that are attached to each of one of these individual processes. So SSH process or the HTTP process, so on and so forth, okay? And then you have a service. Service are the higher level concept, meaning that they group one or more daemons together, and that provides a specific functionality. So the HTTPD service runs the Apache HTTP server daemon, right? So the HTTPD service runs the Apache HTTP, okay? So that's the thing to understand. So the service itself is a combination of a few daemons, or at least one or more daemons, that provide a specific functionality. And they're typically managed with systemd or SysVinit, as we talked about earlier. These are our initialization processes, and for the most part, it's probably going to be systemd on all of the modern computers in Linux. SysVinit is a little bit of a legacy, and it just depends on the distribution of Linux that you have and the version of Linux that you have. So you have processes, you have daemons, and then you have services, okay? These would be the commands that would manage the processes. So if you want to view the list of processes, you would just type PS and press enter. That's just by itself will actually show you the snapshot of all of the current processes. If you do PSaux, so PSAUX, it shows all the processes that are running on the system with their details, like their PIDs, the user that is running it, the CPU usage, and the memory usage that it's processing or that it's taking up, the power that it's taking up. And then you have PS-EF, which will display all the processes with the additional details like the parent's process ID and the full command line, and this is like where a lot of these things are actually very much used inside of security analysis and incident response and the pen testing exercises that we run. And the command line that is executed to launch that process can either be done by the system, or it can be done by the parent ID, the parent process that's running that individual process, or it can be done by a user. So when a user clicks on something, it actually processes a command in the background, and that command has a command line entry. So even if you double click on something to open it, there's actually a command line entry that's running in the background, and that is what's launching that process. So everything, whether or not you use the command line, everything has a full command line entry associated with it. And typically for a lot of people that can't read this stuff, it's mostly jargon, but in a lot of instances, it's the individual command that's associated with it and the path of the binary that is attached to that process, which is launching and actually running. So remember, all of these things have binaries or system binaries that are associated with them, and each of one of those system binaries is housed inside of the bin or sbin directories inside of our file system. Okay, so keep all of that in mind. So you don't necessarily need to know much about this stuff. You need to know the details that are presented, and then as we go through the practical portions of this training series, we'll start looking at a lot of these things in greater detail, and we'll run a lot of the common options that come with PS and looking at the various processes, so you can see what all of that looks like when it's displayed onto the terminal, so that you can have a better understanding and just really kind of get that into your system, into your your personal system as the person that's watching this, not your computer system. Okay, moving on. So we have real-time process monitoring that happens with top and htop. And top is typically what's available on all Linux systems. It's actually also available on Mac OS, because Mac OS has a Unix-like type of an operating system that's running in the background. It's a dynamic display of everything that's going on. So top actually, when you press it or when you type it in and you press enter, it shows you everything that's currently running, and it actually changes their line item positioning, right? So the order of everything that's being presented onto the screen changes in real time, because something may be coming to the forefront, something may be using more processing power or CPU or memory, and you can get a good idea of what specific process is using up how much of your memory in real time. And this is one of the things that you would look at to see if there's something that's running that you don't recognize, and if you need to kill it, right? So apart from the list of processes that are running, which we saw with PS, top shows you the real-time dynamic view by usage, right? So it'll typically show you what's currently running. That list changes in real time, and it'll also show you what CPU and memory it's using. You can press Q to quit, or K to kill a process, and R to release, which means to adjust the priority of the various processes. htop, if it's installed, it's essentially top, but it has a user-friendly interface, because top is literally command line, and it's just lines of entries on a black screen, and if you don't know what you're looking at, it can be kind of overwhelming. So htop is the user-friendly interface. It's like it's a visually pleasing version of top that you can run, and it'll still show you real-time monitoring of all the processes that are running. There's color-coded information and a better navigation interface so that you can navigate better, and according to the color coding that's done, you can prioritize things better. So top, again, is just a black screen with a bunch of white lines of data on top of it. htop is more user-friendly. It has color coding available, so on and so forth. Once you've established a process that needs to be killed, for example, if you notice something that might be shady or that might be taking up too much CPU or memory usage, you can kill it with either kill or pkill for process kill. And kill is a very simple command. So you say kill, and then you provide the PID that you want it to kill. and it sends a signal to the process ID and it just kills it. Kill-9 PID sends the signal kill to forcefully terminate the process if it's having if it's taking too long to terminate, or for whatever reason it might be slowing down something. So it's a forceful termination, very similar to what happens in the task manager inside of Windows, where you want to close something but it won't close. So you open up the task manager, and then you force quit that individual process that's running, and it just, no matter what's going on, it'll just crash and kill the process. And then pkill allows you to kill it by its name. So kill requires the process ID. Pkill can kill it by the process name. And then at the same time, you can also terminate all instances of a specified process by doing a kill all command, and it requires sudo permission. And then you would do sudo kill all and then give it the process name. So for example, in this case, let's say you have 10 Chrome windows open. That's kind of what my computer is like all the time. I have different Google accounts, Gmail accounts that are dedicated to different parts of my life. And so for each one of those Google accounts, there's a Chrome window that's open. And sometimes it can be overwhelming, and sometimes you might want to close Chrome in general altogether and then just start from scratch and open up a brand new Chrome window. So when you do that, for me in Mac OS, I can just right click on the Chrome logo at the bottom of my screen and then quit, and then it'll close all of those instances of Chrome that I have. But when you're inside of the command line and you don't get the option of right clicking, then you would just see, okay, there's 10 instances of this particular process, and I want to close it because I want to free up CPU usage, or I don't know what it is. I don't recognize it. It seems like it might be spamware or something like that. So what I want to do is I just want to kill all instances of this process. So then you'll do sudo kill all, and then you would give it the process name, and it'll kill all of those processes and free up whatever memory or CPU usage that those things are currently using. And as we manage processes, we also need to learn how to manage services. So managing services happens with systemctl, and we've actually already gone through this a little bit earlier. And systemctl is one of the big things that comes with systemd, which is the more modern version of the init process for Linux. And it's the primary command for managing the services in that environment. So starting or stopping a service is sudo systemctl start the service or systemctl stop the service. Very simple. Enabling or disabling it is very much the same. So sudo systemctl enable or disable the service. If you want to check the status of it, it will be systemctl status of the service. So it'll show you whether or not it's active and any logs that would be associated with the recent activity for it. And then restarting or reloading it would be same, restart the service or reload the service. So it's very intuitive. I love the syntax for this particular command because if you want to start something, you literally just type start. If you want to stop it, you just type stop. So it's very, very intuitive. Actually, this is probably one of my favorite commands when it comes down to everything that we're running, because the syntax is just real language. It's real words that you're using. So this is kind of an easy one to remember and to deal with. But systemctl manages services, right? PS manages processes. Systemctl manages services. So keep these things in mind. These are the types of things that you need to kind of internalize for yourself as you move forward. So when you want to manage a service, you use systemctl. Now, the service command is used in systems that have SysVinit. So SysVinit is the older version of systemd, right? So we look at this right here. Systemd is in the modern distributions of Linux. SysVinit is in the older versions of Linux or the older distributions. And it's fairly similar to what you went through with systemctl, except the syntax is a little bit different. So you do sudo service, the name of the service, and start, or stop, or get the status, or restart it. So these are the basic commands that would come with SysVinit. Now, what I'm going to be doing in the practical portion of our exercises are not going to be using the SysVinit commands. We're going to be using systemctl commands because we're installing a current version of Linux, or the most up-to-date version of Linux, because I don't want any security vulnerabilities to be loaded on my computer as I'm going through all the exercises. So I'm going to use the most recent version that I'm going to get from the Linux website. So we're going to end up using systemctl. But these are just the series of the commands that you would get for SysVinit, and then there's a series of commands that are also available inside of the Google document that I've created for the notes for this course. And then if all else fails, you can go to something like Gemini or ChatGPT and you say, I'm running a system that has SysVinit as the service management service, and what you're going to go through is, I need to do X, Y, and Z within this computer. What are the commands that I would need to run? And then it would tell you what you got to do. But the main things to remember are that SysVinit is for older versions or older distributions that run services, and you would need to manage them as such. And then systemd comes with the modern versions and the modern distributions of Linux. And then we have job scheduling, and cron jobs are more so repeated tasks that you need to schedule. And then the @ command is used for a singular command that's running for that one time. So if you want to do anything that's recurring, you would do it with the cron or the cron jobs, which essentially just handles all of the recurring scheduled tasks for you. So if you want to edit the user's cron tab, so cron jobs are defined in the cron tab files. And then when you open up somebody's cron tab file, you'll see something that is in this kind of a format. And it has these asterisks that represent the minute, hour, day of the month, and day of the week. So this would be the minute, hour, month itself, minute, hour, day of the month. So minute, hour, day of the month, and then the day of the week. So in this particular case, right, what we have over here, we have it doesn't need to run every minute, but it needs to run every 5 hours or at 5 a.m. So my bad. So this is the hour itself, which is running the 5th hour of the day. So it needs to run at 5 o'clock on that day. And then it's going to run every Monday, because Monday is the first day of the week. So 5 a.m. every single day. Doesn't matter, day of the month is empty. Doesn't matter the month, that part's empty. You're going to do it every Monday. So it's being run weekly, right? So this is an example of this. Now, there are a lot of great editors that are available online that if you want to modify something, if you want a job to run at a specific time or day or whatever, you can go to that editor and you say that this is the path to the job that I want to run, and I want to run it at this time of this day or this month or whatever it is, and it'll just create this version, this format of the command for you. So it looks like this, but I mean, this isn't really complicated to understand. So I feel like you should be able to wrap your head around this. So the first day of the week is represented by 1, and in this particular case, it's not Sunday, Monday. The first day of the week would be Monday, and then the first hour would be 1 a.m., and then 2 a.m., 3 a.m. So 5 would represent 5 a.m., and the day of the month itself would be the first day of the month, or the second or the third, and I think it'll go up to 28 because we do have limitations for February, so it'll go all the way up to 28. And then you have the month itself. So it would be the first month of the year, which would be January, the second month, so on and so forth. So you can look at all of that by going to cron tab edit, cron tab E, to look at whatever user that you're logged in, to be able to modify those cron jobs, those specific scheduled tasks. If you want to look at all of these scheduled tasks, you can, instead of opening the document itself, you can just do cron tab -L, and you can list all of the cron jobs, the scheduled tasks that are available for the user that you're logged in on. So this is recurring jobs with cron. Now, if you have a one-time job, you can schedule that with @. So for example, you would say echo the command, which is, it's technically just running echo, and it's going to print command onto the screen. Do a pipe, and then do it at the time, right? So the time could be a specific hour or relative time. For example, it could be at now plus 5 minutes, or at now plus 5 hours. An example of this could be echo the path to this script right here. It could be this specific thing. I want you to echo this, meaning just print this path, and then you pipe it. So you take the output of this result. That's what piping does. You take this result, the output of this gets piped into this particular command, meaning that at 10 a.m. it's going to echo this piece right here. And that's what @ does. So it'll run something one time for you. If you need it to run daily or more than once, you would do it with cron jobs. If you're just trying to run it once, you can run it with the @ command. You can look at the scheduled jobs for @ with ATQ, and you can remove them with ATRM and then the job number itself. So you would do ATQ, and it will bring you all of the jobs that have been scheduled with @ and then you'll get the job number with each job that's been scheduled. And if you need to remove anyone, you just do ATRM, @remove, and then do the job number. And then just like that, you can remove the scheduled task with @. This training series is sponsored by Hackaholics Anonymous. To get the supporting materials for this series, like the 900-page slideshow, the 200-page notes document, and all of the pre-made shell scripts, consider joining the agent tier of Hackaholics Anonymous. You'll also get monthly Python automations, exclusive content, and direct access to me via Discord. Join Hackaholics Anonymous today.